side, we have Ram, Daya, and myself, Karthik. And from DeepSphere, we have DP, and Jyotiji is waiting in the Zoom, and we are going to let him in. So we are just looking for it. And I think we have others also there. And Ramji, please, if you have any TANA leaders or something, if you would like to introduce, that would be great.
Yeah, we're still waiting for the leadership to join.
Sure.
So, good morning, guys. So we are going to admit one by one everyone. So please be patient, and we have another few minutes just to go through the introduction session. So nothing is going to be late. So let's get everybody in.
Yeah.
So while we are waiting for the TANA leadership to come and start the inaugural session.
Yeah.
So let's admit everyone.
Oh, Jyotiji is saying he is not joined as any name. It's not asking name. It should say name.
No, it should have been. He would have used his default.
Yeah, he is. I'm able to see his name. Yeah.
Belhan, is it good? Yeah, can you send it to me on WhatsApp too?
Yeah, Jyotiji joined just now. Yeah.
Oh, WhatsApp, huh?
Good morning, Jyotiji. Welcome. Welcome for TANA CAI sessions. Thank you.
Yeah, so Daya, keep admitting all the people.
Can you all hear me now?
Yeah, we can hear you very well, Jyotiji. Yeah.
All right. Thank you. Good morning.
We are letting the people in, so they are joining.
Sure.
We'll give a few seconds. And
okay. Okay, that's fine.
And we have DP also joined, so he's also.
Yes, so he texted me. Hi, DP.
Yes, Jyoti. Good morning.
Yes, morning.
Are you letting in everybody or? You are on mute, Daya.
So everyone is in admitted and no one is in waiting room.
Nice. Thank you.
Yeah, I think we are still waiting for more people to join. So
That's
welcome.
fine. That's
Welcome.
fine. We can wait for some time.
Yeah, Jyotiji, welcome. Thank you so much for giving us the opportunity to have
Sure,
our esteemed session.
Thank you.
I think, yeah, so while we wait, I think, yeah, Karthik, maybe you can, just.
Yeah. Thank you. Thank you, Ramji. And Jyotiji, from TANA side, we have Ram, Daya, and myself. And from DeepSphere, as you know, so you and
Durga Prasad.
DP is there. And there are many participants, and welcome all. And I'm sure it's going to be a very exciting and a very good session. And as you know, Jyotiji has conducted many sessions around the world, and so I'm sure it's going to be very informative, and it will be helpful for you to continue. And we will wait for a few minutes, then probably I will give an intro to Jyotiji, and then we will give the stage to Jyotiji. That's the one. So
sure. That's fine.
Chaudhary, can you make Karthik as a co-host? Hello?
Are we expecting, are we seeing some more there? How many participants are there now there? Joined?
The 63 people joined already.
Oh, very nice. Okay.
Yeah, Karthik, you are a co-host now. And you need to make a Jyoti also as co-host.
Yeah, I am not a host actually, so maybe it's not.
I think I am fine actually. I have everything what I need, so I can share the screen. All of them fine. Yes.
Okay, good. Okay.
Yeah, Jyoti looks like he is a host. Yeah, it shows host. Yeah.
Yes, I have the control.
Perfect. Thank you.
Hello, team. This is Bhupinder. I just wondering, do we get any reference material for future, like, record this session or PowerPoint?
Answer is yes. I am going to send you the reference material. I asked the organizers share the participants' name and email. As soon as I get it, I will send it to you.
Thank you, sir. Thank you very much.
No worries. No worries.
And it's going to be a very interactive session, Bhupinder Singh, like so. And all the materials, any reference details and everything, that will be shared by Jyotiji. Actually.
Okay. Looking forward. Thank you, sir.
Yeah.
And also I have one more.
Sure, one by one we can go ahead while we are waiting for the TANA leadership team. Yeah.
You mean by any chance, do you guys are sending the recording along with the reference material, or it's just
reference materials, yes. Recording, yes. So we are just discussing how we can post it, and we will think about it. And at the worst case, like what we will do is, like in the last session while Jyoti was conducting, so we had a WhatsApp group we created so that you all can, interactively work later too. So in case if you guys are in the field, and we will let you know about the recording, because it's going to be a 2-day session, right? So I don't know how we can share everything.
yeah,
but yeah, it's a long recording, right? So
I understand that.
Yeah.
And hi Karthik, this is Surendra. I have one more question.
Sure.
And by any chance, do you give, like, if I want to learn from Udemy or any other sites, can you give some references? And also, do you give references to bootcamps like Stanford, UCSD, all those things? So that will help. That will be helpful.
I will answer the question. I teach at UC. I also teach at university.
Okay.
Okay. So you will get to know that. I will answer this one. So first you need to understand what the learning objective. The learning objective is be hands-on. Those materials may not be helpful to you. Okay. If the learning objective, you want to be a high-level project manager where you talk something, but you don't know what's happening inside, if that's what your objective, yes, then those material would be helpful. Understanding, taking courses or bootcamp, whatever you are willing to take. So those things are fine. If the goal is to be hands-on, solve real-world practical problems, not abstract concepts, just like that's what happened. If we talk to 900 people, correct, 99.9 people very abstract. Okay, that means they know at a very basic level, they don't know insights how this works. So if your goal is to be a manager and understand some basics, yes, those would be helpful. If you want to be hands-on practical problem solver, that may not help you.
Got it. But can you give the, maybe in the class, can you give the
yes,
list
I will
of,
address that point. I will address that point.
So that some people might be interested in the manager thing. Some people might be interested.
I said I will address that.
Absolutely, Surendra. So it will be taken care by Jyotiji, and you will have a lot of information. And yeah, please.
Morning, Jyotiji. Morning, Karthikji. Morning, Ji. Thanks for everything. It's going to be a wonderful session, I guess. And thanks for all your help and service. Yeah. And Jyotiji, we appreciate all your service. Thank you.
Thank you, sir. Thank you, sir.
Thank you, Karthik, sir. Thank you, Jyoti, sir.
Absolutely, Surendra. And yeah. Ramji, are we expecting anybody to address from TANA, or like you want me to introduce, like Jyotiji, and we will start the session, and maybe we can slowly,
Ramji is very prompt. He does things on time. It's always very active.
Yeah. Correct, Reddyji.
Guys, we are going to mute all the participants and let the hosts and co-hosts to just be on the unmute and video to just begin and make it more organized at the beginning. Once we are into the actual boot camp, I think that time again we will be more interactive. Initially, we will be introducing the TANA leadership and the Jyothi's team and other volunteer force that was behind this boot camp. So please, I'm going to go yourself on mute, and I'm going to remove that thing.
And Mrutula, and we will talk about your thing, once we start the boot camp. I know you raised your hand, just we are aware of that. Thank you.
Yeah, so welcome to TANA Artificial Intelligence Bootcamp 2021. Good morning, all. So I just wanted to go over quickly about TANA, and then I will announce the agenda for the inaugural session, and then I think we'll go with the main event of the day, that is the boot camp. So TANA, as you guys know, is a largest and oldest Indian organization in North America with close to 40,000 members. And we also have a lot of service-oriented programs that are being done in the last few months. And as a continuation, we are doing this bootcamp. And TANA's mission is to identify and address cultural, social, and education needs of the Telugu community in North America. So part of that, we just wanted to connect back with the community with this kind of education program, and that's why we wanted to do this boot camp, because artificial intelligence is one of the core and emerging technology. So we teamed up with Jyothi's team, and that's how we're able to do this. So thank you again for joining and supporting our services from TANA side. And I will check. Yeah, so we have, I think, 1 second, our leadership team joined. I just want to.
I'm admitting whomever is joining, Ramji.
Yeah, please admit. Yeah, I'm just waiting for my leadership, president, and secretary to join. Just a second.
Thank you everyone for staying patient.
Yeah. So meanwhile, I think So please admit and take care of that. We'll come back in a second. Yeah.
And thank you everyone for joining and staying patient. So we wanted to inaugurate with a nice introductory note from TANA, and also I would like to introduce Mr. Jyotiji with this skill set and everything, and then the stage will be with him. So maybe by 9:30, I think we should be able to wrap up most of the stuff.
Satish garu. Pampistunnanu. Yeah. Leadership. Yeah, we're just waiting for our president, Sri Anjit. Yeah, so just a second. Yeah, I think we have some delay joining from overseas.
Yeah, Anjaya, right? Anjaya joined.
Yeah.
Yeah.
I keep accepting it, but it's
make him as a co-host so that he can.
He still says he is joining, so.
Yeah, I think that's what I was wondering. Yeah.
Okay.
Yeah. Welcome, Anjay Garu, the TANA president. If you can hear me, please unmute and come on video, sir.
No, I am on video. Can you see me?
Right now we can. Yeah, we can. Go ahead, sir. So, Anjay Garu is our TANA's esteemed president. So, I would like to welcome him to address the gathering and start this boot camp.
Yeah. Thank you, Ram. Can you hear me? Can you hear me, Ram?
We can hear you. We can hear you.
Yeah. First of all, I apologize. I'm in India and, I'm in a gathering outside. So, excuse me for that. My audio is not that great. But once again, welcome everybody for this, absolutely very useful boot camp, couple of days camp designed by Ram, our Secretary Satish Vemuri, and the rest of the team. Please pardon me if I miss any names. As I mentioned, I'm outside in India, but entire leadership I would like to thank for their unconditional support. And Ram, as usual, you and California team doing a great job. Please keep up the good job. And once again, thank you all. Let us dive into the session, Ram. Thank you so much.
Thank you, Anjay Garu, for joining from India at this late hour. We appreciate your support, and I would like to thank entire leadership on this occasion. Thank you. So, right now, I will quickly go over the
we have Satish, somebody, right? Satish Vemuri.
Yeah, if the Secretary Satish Vemuri Garu joined, can you unmute and come on video, sir? Yeah, while we wait for Secretary Satish Garu, I just wanted to say, so this event is a collaborative event, and we have organizing team consisting of myself. My name is Ram Tota. As you know, I am the regional representative for Northern California, and I'm part of the executive committee. And we have Satish Vemuri Garu, the secretary of TANA, and we have Karthik Perumal from Tamil Mandram and also AIA, who was helping us part of this event organization. And also we have Daya again from AIA and Tamil Mandram. So he was also very instrumental in helping and bringing everything together. We have Vamsi Vasreddy, he is a regional coordinator from New Jersey, TANA. So he's also very helpful and was part of this organizing team. So I would like to wholeheartedly thank the entire organizing team to bring together and coordinating in this very tremendous job of bringing all together. And thank you again. So I just wanted to see if Satish Garu is available.
I am. I'm in the ముందులో కూడా ఉన్నాను, but mute చేసుకోలేకపోయాను.
Sorry. So just to give you one line introduction before you go ahead. Satish Garu is our secretary, TANA, and he's been very instrumental in bringing new programs. So go ahead, Satish Garu. Just give a few words of.
First of all, I want to thank Jothi and Karthik and Daya Garu. When I requested them to do a program for TANA, they didn't blink it. Just they said yes. So from TANA, I want to thank you, each and everyone who are supporting this program, who are bringing this program to our community. I know I misunderstood a few things, and I thought I told a lot of people it is only for kids, but actually it is for adults. Then I realized, okay, I made a mistake. But still, Ram Tota and Vamshi Reddy and all other regional RCs, they did a wonderful job. Sorry for my wrong information to each and everyone, but I want to thank all these three people again and again, a number of times. But I want to do one more program with the 500 and. If it is a kids, I thought it is a kids. We want to do this program for kids, and I will make sure there is a 200 and more people is going to join. But now we have families. Basically, we register. Everybody thinks it is like 100 or 120 people, but it is not. It is a families. Basically, we told them entire family can sit together and learn it, so they can implement on their own, day-to-day life. So I want to again thank you, and I want to thank Bata team who bring all of you guys through AA to us, and you are giving you are wonderful persons. I want to thank you again. I hope this will help the entire community, and more people is going. We can do more boot camps where all the entire community is going to get a help from us. Jothi, you are the wonderful. Not only you sharing your knowledge is one of the best thing in my as for my knowledge. So you are doing that. I want to thank you again. Ram and the entire TANA team. I want to each and everyone who is supporting in this one. I want to congratulate and I want to thank who joined this one. Please utilize these 2 days spend and focus and while while the boot camp is ended, I am pretty much sure you learned something from this boot camp, and it is going to be useful in your life and in your career. I want to thank you, each and everyone who registered in this program. Thank you, Ram, again.
Thank you, Satish Garu, the Secretary of TANA. And now I think we have another support and part of organizing team member, the Vamshi Reddy Garu. If you are there, quickly give a line of introduction and a word about this event. Thank you. Vamshi Reddy Garu.
If not Ram, we can do it.
Yeah, sure. Go ahead. Yeah.
I will go ahead and introduce Jyotiji because people are waiting in patience.
Sure. Go ahead, Karthik ji. Please take it.
Yeah, and absolutely. And Vamshi Garu. So we will definitely, you can have a speech tomorrow morning. And thank you, Ramji, and thank you, Satish and Ajay ji, for giving us this opportunity to, create the awareness of artificial intelligence across, the world. And Jyotiji is excellent in that. And to give a brief intro about Jyotiji. So Jyotiji is the board member and chief data scientist of University of California. And also he has like almost more than 17 years of experience in the consulting and, end-to-end artificial intelligence experiences, mainly with, Deloitte and ENY and KPMG. And he has served more than 50 clients across various domains, like from retail and consumer and health, and also like energy, oil and gas and everything. And he is the head of artificial intelligence expert and Harvard Innovation Lab startup, and he is also part of his Harvard University, Boston, and where he is the head of AI team. And also like he is the facilitator in MIT. A lot of people, who did the AI through MIT, they might be aware of Jyotiji, and he is one of the excellent facilitator, and guide and advisor, you can say, like more than the trainer. So he did like a lot of training to many of the students. Like that's how we came to know Jyotiji too. Like so, he's now the best guy, and he co-innovates like industry solution along with SAP America. He is closely working with SAP America, and he found this company DeepSphere.ai. So the organization mainly, right? So it's to create the awareness of artificial intelligence, and he is doing like for in India, a lot of universities, whomever is having this artificial intelligence and the machine learning as an engineering course. So they are using their syllabus, like DeepSphere syllabus. So DeepSphere is like he's not doing training for the individual people. He is doing it for the universities globally. And, so that's what his organization does. And he's the co-founder of the organization. And also he has been invited by the Prime Minister's office of many countries. Like he has given his guidance and his advices to to the office of Dubai, and also like he went and visited the Malaysia and and Montreal, and all those Prime Minister's office he went and he did a lot of guidance and advices related to the AI. He is also the Stanford alumni, and as I said, like he teaches at MIT too. Like he is the head of AI and he is the architect, and he also does like a lot of things in the Harvard and everywhere. And I am sure and you might have seen him in many other things. As he said, like he is a trainer in the Uda city and many places. Like so thank you Jyotiji, coming during the weekend and helping the community and assisting the community in creating the awareness of artificial intelligence, and making sure that the people can choose if they want to choose the right path, right? So who knows, like the next 5 years, they are saying it's going to be artificial intelligence and machine learning, and you are well ahead and advanced and making everything, visible to all the people. And thank you so much again. I know it's a holiday time, and thank you all the participants for joining, before the holiday starts and this week, and it's a critical and thank you DP and the team, and from India, who is supporting Jyotiji from DeepSphere, and welcome everyone once again. And thank you Satishji and Anjaya Garu and everybody. I know there are almost 100 people with the families and everything. We will do the best next time, probably on the summer or something. We will work on it in a better way, to bring more community. It's creating the awareness of artificial intelligence and machine learning, right? So we will do the best we can do to serve the community. And with this, I give it to Jyotiji. Jyotiji, the stage is yours. And
yeah, Karthik, just a second before we hand it out to Jyotiji. Just a second. I think I just wanted to take 1 minute just to recognize the names from the leadership team that joined but not able to get the chance to unmute in time. So yeah, I think we have Raja Kasipurti Garu, Community Service Coordinator. Thank you for joining, sir. We have Niranjan Srungavarp Garu, the Executive Vice President. And I also would like to quickly thank the Bilhan Alapati Garu, who is the web chair, and he was very helpful in setting the live and all that. He also joined, and thank you, sir. And also we have Devineni Paramesh and Thagur Garu, so they also joined, and thank you, sir. So with that, I think without taking much time, I would like to give it back to Jyotiji. So Jyotiji, officially one more time, welcome to this TANA's great event, and I'm sure, like Karthik mentioned, you have so many feathers in our pay, like hat to just feel ourselves privileged to have you on TANA stage. And I think all these participants who are joining here will have a great boot camp for the next 2 days. Thank you, and the stage is all yours.
Okay, sir. Thank you all. I hope you are all able to hear me now. Can you all hear me now?
Yes, Jyotiji, we can.
Okay, wonderful. So, first of all, I want to sincerely thank the TANA organization for giving me an opportunity to come and conduct the session. And second, there are so many people behind the scene helped us to get here, and especially Mr. Karthik Perumal and Mr. Daya and Mr. Ram. So all of you, I'm not sure who else are involved in the behind the scene, but I can sense, I can see, I saw a lot of emails back and forth. So I really want to thank each one of you for making this happen. This is just more of a community effort. So we wanted to bring the best out of the best. So we wanted to help the community understand where we are heading towards and what impact it could make both in your life and career, future, financials, right? So we want to understand all of those things with full clarity, right? So what is missing right now? So there are some information, bits and pieces are there, but we are not able to connect all the dots, correct? So I want to thank everyone who put together the program. He brought things. It's not easy, correct? Telling is different, making things happen is different actually. So I really want to thank every one of you, helped to get here and make this event happen. So sincerely appreciate that. Once again, thank you all. All right, with that said, I'm going to go ahead and take over the screen. So, and also I want to make sure actually, this is not me teaching, you are listening. It's going to be very interactive. When I say very interactive, I will ask a lot of questions, okay? And you can also ask me questions. You can also challenge me, correct? So that is how I want to have the session. As I said, you find ton of abstract material in social media, correct? If you go to YouTube, if you search on something, you find so many material. But what is really missing? How does it work in a real world? How do we connect all the dots, correct? So where do I fit in, correct? How is my future is going to look like? And how do we take this to the next step? How do I want to train more and get in-depth knowledge, correct? So all these are all questions we don't have more clarity, correct? So that's what we want to address today, correct? So we want to address all of those things. So understand the core skill, what you need to learn and implement these kind of complex solutions, correct? So people could talk many things, correct? So I'm doing this, I'm doing this. If you go and look for people, I would simply say, people say, I'm a digital transformation leader, I'm a data scientist, I'm a data officer, I'm this officer, that officer, correct? But if you get to the bottom of the issue, if you ask them, they don't know much about it, correct? Why? That's very high level understanding. How does it work internally? How does it goes in deeper, correct? So those questions we don't have an answer. So we really like to address all these questions today. Okay, so we want to make it more interactive session. If you have any questions, please bring it up. If there is anything else you like to learn more than what I'm talking, so please bring it up. We can talk this through. All right. So with that said, I'm going to go ahead and share my screen. Can you all see my screen?
It's it just came, Jyotiji. Yeah.
Okay. So let's start with what we want to achieve in the next 2 days. Correct. So within the 2 days, getting to know everything and be an expert, it's impossible. It is impossible, but at least you can understand the framework, what is involved and how we are going to take this forward, correct? So that's basically what we wanted to focus on today. So the day one, we want to understand some basic building blocks. So even for definitions, correct? So if we go out and ask people, correct? I am 100% confident. Ask them, what is the difference between a machine learning and a deep learning, correct? So whether this individual studied in Stanford, Harvard, MIT, it doesn't matter where they studied. Their answer, 99.9% is wrong. People simply say deep learning is an extension of machine learning, correct? Answer is wrong. Answer is wrong. Why? I don't know the clarity. I don't know what it is, correct? That's what it is, correct? So the point is, let's understand the core building blocks, foundational elements. That's a session one. Second, how do we work on these things? You need an infrastructure. So we are going to focus on understanding Google Colabs. Okay. So there are other platforms you could use, but I found this to be a really fascinating platform for you to get started and understand how to build simple machine learning models. Right? So that's the second focus. Then we would like to do some hands-on exercise, correct? So I'm going to teach you and train you how to build a simple machine learning models. And based on that, I expect you to build as well. So that's going to be session number 3. And session number 4 is to understand. So now let's take one step forward. So we understand the basics. We understand how to work in a technical lab. We did some practices. Now let's implement some machine learning models, classification model, regression model, clustering model, with the focus on how it works in a real world industry. Correct? In a real world industry, how does it work? So that's going to be our session number 4. So session number 5, it's in a continuation. Okay, it's an extension to this one. It's just more of a continuation, correct? Because I'm not sure how much we can achieve. So I'm going to focus on today. Okay, the entire session today is going to be handled by myself, because I do have a team back in India, but I don't want to disturb them because they are already working on a project. We are working on a project, so they're working on it. So, and I'm going to focus today's session by myself. And the tomorrow session is going to be, the next day is going to be, okay, which is day number 2. So we are going to focus on, so I'm going to bring one of my team member, Durga Prasad. He's also on the call. I'm going to introduce him too. So the second day we are going to focus on, start with the understanding data engineering. I can tell you, correct, there is so many people in the class right now, correct, have done work in database administration, have done work in SQL statement, have done work in data related activities, either writing, like, working with the data sets, or doing some ETL work, right, like, or doing some data warehouse work or business intelligence work. All of them is gone. Okay, now the industry is leading towards building data engineering. When I say data engineering, how do we build data catalog? How do we build information model? How do we build extract, transform, load, correct? So traditionally, that's what we do, ETL, correct? Now that has changed, correct? It's ELT, extract, load, and transform. Okay, so things are changing in industry. So how do we understand that, correct? So this is going to be focused more on data engineering. And I do want to assess where do we stand, like, in terms of, like, so whether you understood what I thought, I understood what you learned, correct? So we want to have a small true or false multiple choice question, which is based on what we discussed in day 1. Okay, which is based on what we discussed in day 1. The data engineering, I would say, the most critical key skill, correct? Most critical key skill. If you see on the surface, correct, right now. So how many people correct, working in data? Either they're working in a business intelligence consultant, or working in a reporting and analyst consultant, or working in, like, a DBA, database administrator, correct, or a data architect, or a data modeler. All of those will sucked into this one. Okay, it's the one skill that is going to be, like, useful, and it's the only skill that's required is data engineering. Okay, the data engineering. How do you work with very large complex data sets? Correct? That is, don't think the data engineering is only for machine learning, only for artificial intelligence. Not at all, not at all. Data engineering skill is needed for across the board. Right? When I say across the board, let's say you are building in a transactional application. When I say transactional application, correct, an application which is not built for OLTP, correct, not for analysis, correct. Okay, so the data engineering skill is going to be very vital. So we will be spending time, then we will move on to advice. Okay. Then I do also want to cover a little bit about the cloud infrastructures. How does things work in a cloud infrastructure? And then we want to implement some industry use cases, correct? We want to implement some industry use cases. How does things work in a real world, correct? So we wanted to touch these points, correct? So this is the high level agenda. So basically session 4 and 5, which is going to connect all the dots, correct? So whatever we learned so far, how do we connect all of them? Okay, so how do we connect all of them? So in the day number 2, we start with data engineering. We'll do a small assessment, then understand how do we work within a cloud infrastructure, correct? And then do some industry use cases, correct? So this is the best I can do for the next 2 days. If you are serious, correct? I'm talking about people really serious, correct? So if you are serious, if you want to get onto this kind of skill set, learning about more deeper, then follow and practice. So if you are a high level manager, I just want to understand the concept, just please listen to this one. So you don't have to do hands-on, correct? So it's based on your goal, objective, your interest. You define how far you want to go. If your goal is to become a hands-on data scientist or a machine learning engineer or an AI engineer, then you have to perform hands-on work. If it is not, you can just listen and understand the concept and move on your life and career. So this is the today agenda. In case if there is any other topic that you like to learn, please bring it up. We'll discuss. Okay, we will discuss. All right. With that said, let's move on. So we are on day 1.
Jyotiji, just yes. If you can give me 1 second.
Sure.
Just wanted to make an announcement. And so right now we are going streaming, and so I want everyone to be on video, whoever is there, just for one full frame before we get deep dive into the session. And then I think if you are okay, like
yes,
to.
I'm okay. I'm okay.
Okay, just yeah.
Yeah, please, all of you turn on your cameras. I think that's what Mr. Ram is trying to do.
Can you guys all come and then we will put it into.
So hold on. How do I stop sharing mine actually? Like, so is there any option to view?
Yeah, that's fine. I think, yeah. So thank you guys for joining. I think you are almost there into the deep dive of the AI.
Hi, DP, can you take a picture? DP. Hi, DP, can you hear me? Durga Prasad.
You are taking into the gallery view, right, Ramji? Yeah.
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 So we will. Everybody come on video. We'll scroll through all the screens. Just want to make sure that everybody is recognized.
And Jyotiji, if DP cannot do it also, it's fine. So we can,
okay.
Ram can share, either Ram or me can share it.
Sure, that's fine.
Yeah, so Jyotiji, after this, we are going to start the live streaming. I think because it's going to be more intensive classroom training, and then we have recording for like our own purpose, but we can have parts of it be recorded. Yeah. Okay. Thank you, guys. So with that, I think now I will go back to speaker mode and let all the. Yeah, I think, yeah, so that should be fine. So Jyotiji, so now I think back to you. Thank you, and share your screen. Yeah.
All right, so can you all see my screen?
Yes, we can see it.
Curriculum is designed in such a way it goes along with their academic program. For example, we offer BE, BTech, BSc, ME, MTech, MSc, and BCA, MCA courses, correct? So this is the level of program we are offering. And these programs are offered in collaboration with universities, okay, across the globe. So that's our focus. So let me quickly run this through you so that you could understand. So what I'm trying to make you understand, I'm not selling my product here. I want you to understand how you could use artificial intelligence in real world application. Okay, in real world application, how do you use artificial intelligence? Correct? I'm just going to spend 5 minutes of your time to understand. So we have two websites. You can see this is our educational portal, and we also have another website which is called DeepSphere.ai. Right? So this is more of a platform for enterprise AI transformation. So we have two websites, you can get to know them. So this is our product website where you could see industry specific, like, solutions, correct? It's ready to go solutions. You can get to know this one. Okay. So what I'm talking about, the educational portal. So it is a public, anybody can access this one. If you could scroll down, you will see our platform. Our platform built on Google Cloud. We are a Google Cloud partner. Second, our platform is hosted on AWS, Amazon Web Services, and we use SAP for the backend. That means when you are working within a real systems, okay, you need data, you need business process. Otherwise, it's absolutely abstract. That's what I said, correct? What you see here in YouTube, in the social media, correct? So people talk some basic concept, then jump into Python coding, correct? So that is not really what's needed, correct? You have to understand the business process. So our platform built on 3 core technologies. It's currently built on Google Cloud technology. That means all the machine learning models, such as, for example, if I want to build a machine learning model, we use Google's services, correct, such as Vertex, okay, or AutoML, BigQuery, etc. So we use Google products, and it is built and hosted on AWS. We don't want to be in one vendor, so we host everything actually. And this is basically Litmus is the LMS that we use to customize, and SAP is the backend data that we pull this one. So if you want to access this one, click on demo. So this will take you to the actual demo. So here, basically, what I'm trying to say actually, so this is basically the login screen where you can log in actually. So in your case, you may have to request for a login. You won't be able to get the credentials. So once I logged in, it will take you to inside the platform. So this is, if you noticed, it changed. It's basically hosted platform. It's hosted in AWS. Okay, so now I can quickly show you how we use artificial intelligence, machine learning at the scale, correct? At the scale where it is automatically transforms the current education into full-scale digital platform. Okay, when I say full-scale digital platform, I'm not just talking about, one second. Okay, I'm not just talking about like, doing a digital transformation, content delivery. How do we build content using natural language processing? How do we create assessment using natural language processing based on this one? So I know somebody's raised a question, I'll get back to you. So once you go inside, so you can see different courses that has been offered, okay? So this is basically, tells me the courses that's been offered. Okay, so one second. So this is basically the courses that what we are offering for 6th grade, 7th grade, 8th grade, 9th grade, 12th grade. So once you go inside the course, okay, like I said, I don't want to get into too much into this one, then it will become a product demonstration. So here you could see, correct? So the course has a different units, correct? So unit 1, unit 2, etc. When you expand the unit, correct? So that unit basically like, so it has a, I'm just going to close this one second.
Welcome to Applied Artificial Intelligence course.
Okay, so the course has several things. That's now, if you look at, there is a unit 1, there is a unit 2. This entire content dynamically builds. Okay, so this content is built based on the learner's ability, how the learner is going to perform. So once you go inside the course, you see there's a study material, and you see there is like, learning resources. When I say external learning resources, this connects to things around GitHub, things around open source projects, Google Colab, everything, correct? So if you want to work with Google Colab, it will directly take you there. So this is our instance of Google Colab. You can work from here with the examples and everything, correct? So it's a full-scale integrated platform where education brought to a level, as I said, no one even come close to what we have done at this scale. All right, so the point, what I'm trying to make you understand, how does artificial intelligence applied in this kind of example? So, okay, so here if you notice, correct? So what we have, personalized assessment. And this is what I'm talking about. The questions here, correct? In a class of 100 students, not all 100 students will get the same question. These questions are random in nature. And these questions framed based on how well you understood the subject, okay? So when you launch this assessment, it's going to basically tell you, start the assessment. So these questions, what you're looking at, it's based on your ability, based on your speed. It is not all 100 students in a class getting the same question. And these questions are created using machine learning models, using natural language processing. And this is a scale you will be using artificial intelligence to build these things, correct? So this is one example that I'm talking about, like, how you can use artificial intelligence in education, correct? So let's say I'm done with assessment. I wanted to go back and do like, other activities such as recommendation and feedback, correct? So I want to provide some recommendation and feedback. So how can I do this one? So once you're done with the assessment, you can see this part one, progress and participation report. So the progress and participation report is basically, again, it's on a scale built on Google Cloud, okay? So this is uses the Google products, like, Google has different products, like we use something called Data Studio. We use something called Looker. So these products are basically brought in a real time. It tells you what is the student's participation. And this is created using machine learning models. Okay, so a teacher don't have to basically like, grade the student. The student's participation report, it's based on how well the student is participating, correct? So we understand students' facial expression. We understand students like an interaction with our system. We understand students like answers and questions and everything, correct? So this participation report, right now, I logged in as a demo user, you don't find anything actually. So that's the reason, correct? You say no data. So this particular report, what you're looking at, it's created based on the students' participation. And this is progress report. And the point, what I want you to understand, this is a scale of automation industries are expecting. Using artificial intelligence, do not involve human, build automation at a scale where things are working. So here I have student participation. You see this one on the top, it's going around. So that's basically a live report. So it goes to Google Cloud and because it's hosted in AWS. From AWS, it goes to Google Cloud, try to get the data. Since I logged in as a demo user, I don't have any progress or anything actually, okay? So point 2 to understand. So it gives you personalized participation report, a personalized progress report, teacher insights. If a teacher wanted to share any insights, correct? The student is performing well, yes or no, yes, doing well, no, the student is not doing well. So the teacher could provide some insights, correct? The teacher could, it's a live report, correct? You see this on the top, it's going around. It's a live report, it's trying to create this one. So this is basically one way to understand how you can use artificial intelligence to do automation, correct? So here you could see what I have done actually. So I looked at students' personalized information. Okay, so personalized assessment, okay, where the student can take assessment and quizzes. And then we can see students' participation. This is also built on machine learning models. And the next is recommendation. So when I say recommendation, how well the students are doing. So the students are doing okay, not doing okay. And this is also based on the students' behavior, based on the students' activity, we create these reports using machine learning models, correct? So here you could see students' progress report, participation report, then the recommendation. The recommendation goes by unit, correct? Like, you can see this one right now, there is no data. It's trying to populate, it tells you no data. So that's because I'm not a real user, I'm a demo user. So this is the recommendation report. So what I'm trying to make you understand, using artificial intelligence, we automated the entire educational system, okay? Starting from building content. So this is a learning resource, okay? This is a learning resource. So this content, unit 1, it gives all the things what the student wanted to know, correct? At this level, okay, this is for the 6th grader. This is for a 6th grader, correct? At this level, we have automated all the things, whatever the student need to learn, using completely machine learning models and other tools and technologies around that one. So what I'm trying to make you understand, so this is a scale of automation, what DeepSphere does. So DeepSphere is an educational platform which provides personalized learning management education. Okay, so when I say personalized, the education is completely personalized based on the learner's interest, ability, speed. Okay, so that is what we provide. So that's the reason I brought this one. So one is 2 things. I want you to understand, when people talk about applying artificial intelligence in real world, how does it look? So in this case, what you understood, the interaction between student and a teacher, correct, on a regular basis. Let's assume, okay, when a student goes to a school, the student's basically spending 8 hours in the school. In the 8 hours, the interaction between the student and teacher, let's say almost 6 hours. So this cuts down that interaction. And this also automates whatever the teacher has to do. The teacher has to conduct tests. The teacher has to grade the student. The teacher has to provide feedback. The teacher has to record all this activity. This entire process has been automated using artificial intelligence, no human, no manual work involved. And this is what you call an intelligent automation. An intelligent automation, which we are going to do. So I'm just trying to say, DeepSphere is the educational platform which brings education at a personalized level for cognitive learning. Okay, cognitive learning. How did we achieve this one? We achieved this one using full-scale artificial intelligence underlying machine learning models. That model could be natural language processing back focused, or it could be any other things, but that's in essence what we are doing. All right, so let's move on.
Yeah, there are 2 people raise the hand. So
sure.
One is Tata PR2. I don't know. Can you just put the real name? Like, we want to make sure the people who raise, like hand, they need to have a right name. So other one is Sai.
Yes, Sai. Can you ask your question, Sai? Hi, Sai. What's your question?
People who raise the hand, please speak. Oh, sorry, he is not unmute. Okay, let me unmute.
Yeah, can I speak, sir?
Yes, sir. Go ahead.
Yeah, hello, Jyoti. My name is Prasad Tata.
Yes, Prasad. How are you?
Yeah, I'm fine. I'm one of the novice guys in the artificial intelligence and computer programming in general.
Excellent, sir.
Yeah, I'm a pharmaceutical scientist. And,
awesome, yeah. Sir. Actually, so I work for
Merck.
Yes, sir. Go ahead.
My question to you is, most of the companies, they cannot afford SAP as a backend program. Big companies can afford, but for us to convince the management, are there any alternate platform to SAP, or the SAP is the only?
Sir, let me make you understand. The reason we are using SAP, because when we build models, we need data. We need business processes. For example, let's say, so I'm trying to build a particular model which understand the customer behavior. When I say customer behavior, let's say we have a retail company which is basically wanted to understand who are the target customer that I want to promote this product, correct? So that means I need to understand the customer profile. So in our case, we use SAP CRM to get to know the customer, correct? So it is not mandatory requirement for you to use SAP. The reason we are using SAP because we wanted to take real data. When I say real data, you could simulate the data and work on it. If you notice, a lot of places people use Excel spreadsheet, CSV files to load and train and test the model. In our case, that's not what we wanted. We want the real data. If it's a customer, yes, we can use SAP CRM. If it's supply chain, we can use SAP supply chain. If it's finance, we can use SAP finance. So there is a reason behind why we are using, because our requirement is to use live data, real data to simulate or teach the actual industry use cases. Correct? That's why we are going. But in your case, I don't think that you need to use SAP. It's all coming down to what type of use case or what kind of solution that you're trying to build. If that solution needs the data from SAP, answer is yes, you must have to use it. If that solution doesn't need SAP, then you don't need to use an SAP. SAP is not our runtime platform. Our runtime platform is Google Cloud, and runtime platform is AWS, Amazon Web Services. SAP is not our runtime platform. SAP is primarily for data and business processes. I hope this helps you.
Yeah, I think we have Sai Hitesh who raised his hand. Can you unmute and ask your question?
Yeah, I am able to unmute now. So as Jyoti sir said, just now, he was able to use artificial intelligence to completely computerize the education system, right?
Yes, so we automated the education system. It's an intelligent automation. And automation occurs without any involvement with the teacher. The teacher involvement is very minimal, correct? It creates a learning material, I will show you. It creates a question, I will show you. It grades and assesses everything, whatever a teacher does, it is done artificially using machine learning models. That's the reason I'm calling it's an intelligent automation of educational system.
So what's the thing I'm asking is let me take myself as an example.
Okay.
So I was very good at maths.
Okay.
But I was not so good at social.
Okay.
So if I am in the 6th standard,
okay,
so I will be able to go forward into the maths, but for social, it will take me time. So how does your automation make sure that he's getting both?
Okay. Okay. So first one, we are not offering all the courses. We are offering selective courses at this point. In the future, we will be. So that is point one to consider actually. Let's say so we are going on a specific 3 courses that we are offering. One is Applied Artificial Intelligence, second Data Engineering, third Advanced Computing. Only these are the courses we are offering. In these courses, we wanted to offer content at a personalized level. So that means all 100 students will not have the same content. Content will be personalized based on how you're learning. So going back to your point, let's say I have 5 courses I'm taking. Out of 5, I'm doing 2 well, 3 not. Okay, in that case, how do you balance between these 2? Answer is yes. So in that case, it's based on we find out where is the learning challenge. Is the learning challenge solving mathematical equation, or the learning challenging is understanding the concept? And based on that, content will be created. The content will be restructured based on which makes you more interesting to learn. And that is what we call participation rate. How you are participating. We ask questions. We ask intermediately when you are studying something, learning something. So like I said, we'll do facial expression. We'll do body, language, like how you are behaving, correct? All those things will be used and tracked. So in your case, out of 5 subjects, 2 you are doing really well, 3 you are not doing well. How do we understand which one you are not doing well and why you are not doing well? How do you increase the participation? So that we'll track and measure and come back and tell you, so because of this, and that is what our feedback and recommendation. So the feedback and the recommendation tells you, I don't think that you like to solve equations. I think you like to watch videos and answer questions when we are putting in a video on this one. And that is how the content will be built. So at this point, we are offering only 3 courses, which is basically Applied Artificial Intelligence, Data Engineering, Advanced Computing, 3 level, Foundation, Intermediate, Advanced, Foundation 6 to 8, Intermediate 8th and 9th, so 9th and 10th, and then Advanced 11th and 12th. So that's the 9 courses we are offering for schools from 6th to 12th. Any questions?
I think we are good to go, Jyotiji. That's
All right,
great.
let's move on. So this is all the things I talked about. I don't have to repeat actually. So the main idea behind, like, so why I wanted to basically understand this one. So I wanted to understand how artificial intelligence brought at a scale where you could see, like, the entire education system, it's completely automated. Okay, it's completely automated. All right. So our session is going to be focused fully on industry. I am not want to go out and talk about academic. You will get bored. You will lose interest, correct? So if I'm going to teach math, stats, probability, answer is yes, I can, but you will lose interest. So my focus today, okay, it's more on industry. How does this work in industry, which I feel it's lacking, which I feel is like people are not able to understand and connect the dots, correct? As I said, if you go out and watch YouTube videos or people talking presentation, there is so much abstract. But when you go in the real world, it's so messy. It's so messy. You wouldn't even be able to handle one single problem, correct? So that's the complexity that's involved. I can share some live examples so that you could understand, correct? So my focus today is going to be like, this is the industry focused solution. So we are going to learn more industry. We are going more real world application. We are going to more understand the technology that behind the scene to build all these things at a scale. All right. So what's our learning focus and key takeaway? Number one, deeply understand how artificial intelligence real world applications. Number one, correct? So that is most important. Number two, on what framework you operate. If you want to go ahead and implement in a company, let's say someone asked about pharmaceutical. If I want to implement this on a clinical trial, okay? If I want to implement artificial intelligence to build a clinical trial, correct? So in that case, what is the framework I want to operate? That's the number two key takeaway. Number three, what are the on-the-job learning skills, correct? So ultimate goals, I'm sure there is something drives you to come and sit down in this class, correct? Why? Either you want to transition your career, or you want to advance your career, or you want to find a new job, correct? Which you may not even thought about, correct? I want to explore something, correct? So the next three, the third point that what I wanted to highlight, okay? What is the on-the-job learning skills, okay? Number four, whether you like it, you don't like it, data plays an extremely stronger role in this space. What does that mean? Without data, all these things meaningless. All these things meaningless. So that is why, if you noticed in the examples what you see in the YouTube side and all these things, no one goes to a large enterprise system like SAP, Oracle, and all these things. Why? That is so complex to touch. Okay? Getting data out of SAP, getting data out of something that in enterprise systems like SAP, it's not a joke. Okay, so it's not a joke. It needs guts. It needs guts to deal with that kind of system. So understanding data engineering, in my view, it's one of the most key critical area. So at the end of the 2 days, what I wanted to make sure you understand the basic building blocks, terminologies, and overall how it applied in a business process. Second, framework. Third, on-the-job learning skills. Fourth, data engineering skills. This is basically what is needed in order for you to go on this one. All right, let's understand the core fundamental building blocks of artificial intelligence. Okay? So before we go there, okay? So I did talk about how this works in the real world. Okay? So give me one example. So this is the behind the scene example, what you looked at. Okay? So I demonstrated how we automated using artificial intelligence, how the education system is fully automated. This is the back end of what I told you. Okay, so what it means, I want to create content or I want a question. Okay, so that means I'm a faculty, I need assistant. I'm a student, I need reading material, I need study material, I need learning resource, I need lab. All right, or I'm a teacher, I want to conduct assessment quizzes. So how does this work using artificial intelligence? Understand, okay, this is full scale automation, completely built on machine learning models. Okay, so I'm going to choose what I need. I need content. Okay, I'm going to do content generation. So now it automatically changes what it is asking for. Enter the topic that you're interested in. So I'm going to say data science. Okay, I'm going to say data science. Okay, data science. So what I'm trying to do, I'm trying to basically get the most appropriate content I needed for data science. Okay, when I hit enter, so this is going to basically provide me the content that what I needed. Okay, so this is providing me the content what I needed. 1 second. So just a second. So here it extracts the most popular URL which has the data science content. This is behind the scene, right? So this is basically still extracting. So any topic you give, whatever topic you want content, you just give the topic. It found these URLs has most relevant actually. Okay, so this one, then it's going to extract the appropriate content. Okay, so whatever content we want. So behind the scene, we do a lot of things, correct? So we do content summarization. We remove the content, duplicate content which is basically talks similar things, we'll remove them, correct? All the things are done by using natural language processing. How do you process this one actually? So it's basically trying to create the content from this URL based on what we felt this has the more relevant content. Okay, so we felt most relevant content. It's doing this one behind the scene. So this is how every content is been created. Okay, so it's still loading. Okay, 1 second. So this is built on a app called Streamlit. Okay, so if you are familiar with what is Streamlit, you'll understand, correct? So 1 second. Since I clicked several times, it's just taking some time to understand. And finally, it will give the content. So if it's, let me see if I can pick up the question generation. So that will give me, okay, give me 1 minute. I will refresh this because I clicked several times. It's just taking some time. Okay, so let's say I'm a teacher. I wanted to have a question to be generated, correct? So I want to generate the questions. Okay, so now it's asking what type of question you want. Okay, this tells you I want to fill in the blanks, true or false, match the following multiple choice. Let's say I want to do a true or false. All right, so when I select this one, it's going to ask me, correct? So give me the content that you wanted to use for the true or false. So now you can give a content. It's going to take like, so whatever content that I have. So I'm just going to like, I don't know exactly what is in the file. I'm just going to put something here actually, correct? So I'm just going to put something here and see what it does. Okay, this may not give me a more appropriate content because I'm using some like file. So now it's basically summarize the input. So it's the steps that you can walk you through what it's doing. Tokenize, okay, word counts, all behind the scene, like so it's a model. Keep in mind, I'm just using some random content which I don't have it at this point actually. So this is the sentence formation. So it will take you through the entire step, and then it finds out an alternate sentence, and then it's going to let you see the question outcomes. Now you can see the question outcomes and everything. So the point is, behind the scene, there's a lot of activities that are happening, and this is basically how we build content. We generate questions based on 2 things. If you are looking for a content, you select this guy, it will ask the topic to be given. Okay, enter the topic, then it will give the content. If you are looking for a question, select the type of question you wanted, we'll give you this one. So I will get the real material so that you can get to see this one. Okay, so what I'm trying to say you to understand, in a real world, how you can build artificial intelligence type of application solutions. These are some of the examples, correct? These are some of the examples. So based on what you select, it triggers everything. So the 2 things, you give a topic, I'll give you a content. Second, you give me content, I will give you the questions. You give me the content, I will give you the questions. So this entire process, completely built on machine learning models, primarily using natural language processing. It solves 2 purposes. It automates what a teacher or a faculty student needed, and also it takes care of the assessment and its evaluation. Okay, so this is one of the best way to understand how you can use artificial intelligence to build these things. All right, let's go back. Okay, so in order for us to get to this level, there must be a starting point. There must be a starting point. Where do we start? The first thing is understand the basics. Okay, understand the basics. I'm very sure, okay, everybody in the class right now heard these names: artificial intelligence, machine learning, data science, intelligent automation, digital transformation. Okay, so your learning will evolve only these 5 words. Okay, rest all absolute nonsense, ignore. So if you want to master, if you want to be an expert, if you want to change your career, if you want to do something in this phase, you have to understand how these are all working. So these are all core building blocks. Okay, so as I said, You go out and talk to people, ask them, what is the difference between a deep learning and machine learning? The answer you get, deep learning is an extension of machine learning. In my view, absolutely wrong. Absolutely wrong. Why? I will explain. Why? I will explain. That is a state people are in industry at this point. As I said, I have nothing against anybody, whether they're from top schools or an industry professionals, or they're working for like big management consulting firms, it doesn't matter. If you ask them, go and ask them, what is the difference between a machine learning and a deep learning? The answer always going to be deep learning is an extension to machine learning. In my view, that's totally wrong. So let us understand the basics, the foundational building block, what is it? In the future, if you want to be an expert, if you want to be a subject matter resource, if you want to change your career to in the space, either a machine learning engineer or a data scientist or a data engineer, etc., you must have to learn and understand these 5 things. Okay? How does this work? How do you build this? How do you implement this one? And this is where everything will evolve. This is where everything will evolve. Let's understand. So I need someone from this group can give me your understanding of what is artificial intelligence, what you understood, what is machine learning, what you understood, what is data science, what you understood, what is deep learning, intelligent automation, and digital transformation. I just need one line for each of this. Okay, I think Kumar Veerappan. Okay, Kumar Veerappan, could you please unmute yourself and tell what you understood about each of this? Just one line, because we don't want to spend too much time on these things. This is for me to understand how much you audience understood. Please go ahead, Veerappan, Kumar. Hi, Kumar, can you hear me? Okay.
Oh, all right, Jyoti. Yeah,
yes.
So I was just able to unmute just now. See, somewhere I heard, okay, artificial intelligence is nothing but a bunch of if-else statements. And I thought for a moment, and it does make sense. Okay, if this happens, do this. If this happens, do this.
That is not artificial intelligence. Let's move on. That's not artificial intelligence. That's more of programming constraints, correct? So how do you instruct a machine to learn and do something, correct? Like, so you are trying to compare what a human does, what a machine does. So human does, if this do this, if this do this, how I want to teach the machine, correct? So that is the point you're trying to say. I understand, but that's not artificial intelligence. Move on. So do you want to say what machine learning means?
I don't know.
Okay, so that's fine. So any other things that you could think of? Data science, intelligent automation, digital transformation. All right, that's fine, Kumar. I appreciate you stepping forward and sharing what you learned. No questions. So like I said, you are not the only one, correct? I said, even if it picks students from top schools, they do also on the very similar level as you. The IQ could be different, but the understanding is different. IQ is different, understanding different. Getting to know something is deep is different, correct? All right. So there are 2 other participants raised the hands. Please go ahead, unmute yourself, answer this question. I just need one line for each of those. What's your understanding? I'm not asking definition. What's your understanding? Whether it's right or wrong, that's different. We are not here debating right or wrong. That we are going to learn. Our debate is not right or wrong. Our debate is your understanding. What's your point of view on all these things? Go ahead, please.
Also lower the hand once you guys are, answered. Yeah. Deepthi, you want to go ahead? First.
All right, so somebody else. So you could...
Hey, yeah, this is Srikanth. Basically, artificial intelligence is nothing but it's a chess programming.
Okay. So that is what you learned. Actually, I understand your objective or your understanding. That's fine. Let's move on. So chess programming. So instead of a human playing a chess, it's a machine is playing a chess. I think that's what you're highlighting. Understood. So that's all for go. So let's move on to the next points. What's your understanding about machine learning? Srikanth, anybody else? So we need a quick response, correct? Like, otherwise it's going to take a lot of time. So we need a quick response. Can anyone respond, please?
I think Bhupinder, you raised the hand. You may want to talk.
Yes. So thank you, Jyoti. So AI, in very simple term, what I understand is making a machine smarter, and machine learning is how machine make it smarter themselves by
Okay.
understanding data
Okay.
size is more of collecting the data and analyzing is as a raw input to the final output.
Okay.
Intelligence automation, I am not sure, and digital transformation is like how the physical entity is converting into the digital world scenario.
Okay, excellent. Like whatever you said, it's your point of view. Like I said, it's not a right or wrong answer. It's your view. I appreciate that. Okay, thank you, sir. Next one. One last participant, we'll move on. Okay, one more participant. Can you please share? So this is what I would encourage you to do. Correct. So knowing subject is second, coming and stepping forward, speaking is different. Correct. So we all really very smart, intelligence. We do a lot of hardcore work, like, but when it comes to speaking in public, when it comes to speaking in front of a group of audience, we all take a back seat. Why do I have to go and talk? Correct. That's what it is. I think that's a unique skill. You have to develop yourself. You have to teach your kids also to learn these skills, correct? And that is what makes you very, very valuable. Correct? When you go on a group of people, the people who speak more have more value than people who's not going to speak. Correct? Please speak. All right. So anybody else? One last participant. We'll move on.
Okay. If I may.
Yes, sir. Yes, sir. Yes, sir. It's an open forum. Please bring it up and talk.
I can jump. I'm known to jump off the gun. So, artificial intelligence is something that how quickly a machine can interpret the data based on the input provided.
Okay.
How quickly, and machine learning is training the machine.
Okay.
With the pre-existing data and human interpretation.
Okay.
So it can intelligently automate the digital transformation and existing data.
Nice. Okay.
Into interpretable results.
Okay. So what is the next one? Data science.
Data science is what how you structure and organize the data sets.
Okay.
So that machine can rapidly read and interpret.
Okay. Excellent. What's an intelligent automation?
That is how quickly the machine interpret the existing data and answers the questions that are posed to the machine.
Excellent. What is the digital transformation?
Yeah, my last question, digital transformation is there.
Okay, excellent. All right, thank you so much, Sarah. So like I said, so knowing one thing, stepping forward and speaking is another thing. So I appreciate you stepping forward, speaking with all the audience, appreciable. So this is the reason I call it mystery. This is the reason I call this as a mystery. These are all mystery. Why? We know what it is, but we are not able to express clearly. So that's the reason I said the majority of the population heard about these terms from an industry perspective. Okay, only 0.1 or 0.2% of the individual understand these terminology both from functional and technical level to develop real-world application beyond use cases. Correct? So that is the reason it is a mystery. Now let's understand what does each one means. Okay, as I said, without knowing this, it is absolutely impossible to go and code something in Python. So if you notice a lot of YouTube videos and a lot of articles, it jumps and goes into technical without knowing the foundation. Let's understand what is exactly this means. All right. I'm sure things you know what it means. Okay. So I don't have to teach you what is reading means, what is writing means, what is cooking means, okay, and what is driving a car, or what is hairdressing, what is a disease diagnosis. I don't have to tell any of these things. You know what exactly it means. So these are the things we do on our day-to-day basis, correct? On our life, okay, on our life. What we do, we speak, we read, we write. Imagine, okay, if you are not allowed to speak, read, write in a day, what happened to your life? Okay, well, it become miserable. It become miserable, correct? I'm not allowed to speak. I'm not allowed to read. I'm not allowed to write. Oh my God, what's going on? Correct? You will feel yourself like, in a very difficult spot. Correct? So things what we do on a day-to-day basis, basically, what is this? It is nothing but whatever we do on our day-to-day basis. I'm not saying this is the only thing we do. These are all some handful examples. So whatever we do on a day-to-day basis, basically, let's take that and understand how does this comes into artificial intelligence. Let's dive a little deeper. Let's take an example, driving a car. Okay, so driving a car. Who's driving? A driver. Okay, what do we call that? That we call a human driving a car. It became a human intelligence. How did this human get the knowledge? Without the driving lessons, it is impossible to go and drive a car, correct? Do you think, okay, no driving sessions or lessons, correct? Can you drive a car? Impossible. It is impossible. If some miracle happened, that's different things. You must have some, either a formal or an informal training, you must have to have, right? So what I'm trying to say, let's take an action that we do in our day-to-day life. Driving a car. Who's doing? A driver. And who's this driver? Human. How did the human get the knowledge, either through formal or an informal training? Let's take another example, medical diagnosis. You go to doctor's office, the doctor's asking you a question. What's the problem? Correct? So I'm having body pain, I'm having headache, I'm having severe, throat pain. All these things are happening. Okay, so the doctor is basically asking a series of questions. Okay, so who's this person? Is a doctor. What is the doctor doing? The doctor is asking a series of questions and diagnose the disease condition and giving you recommendation. What do you call that? That's a human intelligence. Why? It is done by a human. How did the doctor get this one? Through a formal or an informal training. That means the doctor went for a medical school. He or she graduated. He or she went for other practice and learning exercise. They learned this one. Let's say in our life, we do programming, we do coding. So someone must code in Python, somebody must be coding in Scala, somebody coding in Java, somebody is coding C, C++, etc. So what do we call these people? These people are programmers. Who these people? These people are programmers. How did these people gain knowledge, either through formal or training? Correct? Who these people? What kind of intelligence these people are carrying? And a human intelligence. Why? It's a human. So point is the things what we do on a life. Okay, whether it's driving a car or doing medical diagnosis or coding and programming. Correct? So all the things are who's doing right now. It's a human. Okay, what we call human intelligence. How did the human gain this knowledge? Either through formal or an informal training. Okay, formal or informal training. So the goal is what? Create this artificially. Create this artificially. That's what we want to understand. Okay, so when we say intelligence, what are we talking about? Reading is an intelligence, writing is an intelligence, decision making is intelligence, problem solving is an intelligence. All these are all an intelligence. I'm not saying this is the only thing is an intelligence. Things, whatever we do on a day-to-day basis, those are all intelligence. If these intelligence are done by human, then it becomes a human intelligence. Then it became a human intelligence. How did the human gain this kind of intelligence? Either through formal training or an informal training. Right? I want to become a truck driver. Do you think I can become a truck driver without a formal training? Impossible. I have to go for a driving school, learn the lessons, become a certified or a licensed. Okay, then I gain the knowledge. I gained enough skills to go and drive a truck. Okay, so I want to be a doctor. I have to go to medical school. I want to be a law professional. I want to go to law school. I want to go be an accountant. And I need to pass the CPA exam, correct? All these things basically a human-oriented knowledge, intelligence, which requires training, And that training could be formal training or an informal training. If it's a formal training, you go to a proper school where you have an instructor, where you have a defined schedule, where you have measurable outcomes. If it is informal training, I am going to go with my mom. My mom is going to teach me. My dad is going to teach me. My brother is going to teach me. Okay, that's fine. No problem. In an informal training, you don't have an instructor. Okay, a well-trained, certified instructor. And you don't have a properly defined schedule. You don't have properly defined training material and a measurable outcome. It happens over a period of time with your known resources. So those are all informal training. If a human gains these kind of intelligence through a formal or an informal training, that is called human intelligence. Emotional intelligence, when I say emotional intelligence, so you don't need a formal training, okay? Things that happen over a maturity, okay? So when you are 5-year-old, you could do certain things. When you are a 10-year-old, you could do certain things. When you are a 15-year-old, you can do certain things. When you are a 20-year-old, you see, when you grow, your skills, knowledge, expertise also automatically gains without any formal training. Example, when you see a snake in front of you, so what happens? Correct? So you will either go ahead and kill the snake, or you make noise, or you ran away, you do something. For that, you don't need a formal training. You don't need an informal training. Why? You learn over a period of time. You watch something, okay? Either somewhere you watched, somewhere you learned, you understood snake is poisonous. Okay, so either I have to kill, I have to run, I have to call, I have to do something. Let's assume that a baby is crying. Okay, so what happens? So you can't just watch the baby's crying and then go to sleep and laugh and all. No. So you're going to basically find a way to make the baby not to cry. So those are all emotions. You react based on what you learn, correct? So that reaction is basically called an emotional intelligence, correct? An emotional intelligence, correct? So the point what we are trying to understand what's an intelligence, understand what's an human intelligence, what's an emotional intelligence, correct? It is important. If you don't understand, then you don't understand what is artificial intelligence, correct? So intelligence, reading, writing, etc. Human intelligence, if a task is performed by a human, okay, and those tasks requires a formal and informal training, that's a human intelligence. Emotional intelligence, an intelligence that occurs without any formal training or informal training. So now this is basically what so far we learned. Now let's understand what is an artificial intelligence. An artificial intelligence, an alternate or a substitute, a replacement for all these things. Okay, it could replace a human, it could alternate a human intelligence, it could substitute a human intelligence. I'm a doctor. Okay, I'm a doctor. I need some assistance. Okay, I'm not saying that like, we want to replace the doctor. We need some assistance. What kind of assistance we are talking about? So the doctor basically needs someone who can come and create a medical transcript. Okay, the doctor done the patient. So the conversation that took place between the doctor and a patient done. So now the doctor has to move on to the next patient. Before the doctor has to go to the next patient, has to create a medical transcript. What is the medical transcript? It's a record, basically describes what kind of conversation took place between the doctor and the patient, what symptoms the patient has, what kind of medicine or what kind of treatment, what kind of next step has been recommended. So that has to be documented. That's basically a transcript. So that transcript, in our case, we build a model which basically listen to the conversation and transform the voice to text and text to medical transcript. Okay? So that became either a substitute or an alternate. Okay? So point is, by definition, artificial intelligence, it's an alternate substitute replacement for human emotional intelligence or any intelligence. This is what it is. Okay? So please understand, as I said, there is so many different definitions people talk about. Okay? Artificial intelligence means data, machine, this all are correct. But in a simple, plain language, okay? So whatever you do on a day-to-day basis, those are all intelligence. If that intelligence is performed by a human, it's a human intelligence. So human intelligence comes out of training, which is a formal or an informal. If there is an intelligence which doesn't need a training, but it happens over a period of time on your maturity, those are all things you react based on what happens in front of you or in around you. And that is more of an emotion. There is an emotion comes out of certain things when you watch. And that intelligence and emotional intelligence, by definition, artificial intelligence is an alternate substitute replacement for human emotional any intelligence. This is what you must have to tell when people ask what is artificial intelligence. Move on. All right. This is understood. Now, how do I apply in industry? Okay, how do I apply in my real world life? And how do we do things in my real world? Correct? And this is where an intelligent automation, data science comes into picture. Okay, an intelligent automation, data science comes into picture. What I'm trying to tell you, in a real world, how do I use artificially created intelligence? Correct? Goal is what? Goal is what? I want to read, I want to write, I want to make decisions, I want to solve problems, I want to basically respond to a question, etc. So these are the things I am doing on a day-to-day basis in my real world. When I go to office, I write something, I make decision, I solve problems. Correct? All these things I want artificially created. I want artificially created, not a human. I want artificially created. In what form I create that? You can create that in the form of an intelligent automation or in the form of a data science. Okay, let's understand what is this one. Okay, so keep the circle, it's kind of intersects. Okay, both intersects, correct? It will intersect each other. All right, so what is an intelligent automation? What is a data science? An intelligent automation occurs without a human, any manual work. Okay, there is no human involved, there is no manual work involved. So I shown you in our educational platform, we create content automatically, we conduct quizzes automatically, we assess the quizzes, we make recommendations, we provide feedback. That is done without a teacher. That is an intelligent automation. An intelligent automation. The second best way to understand is self-driving autonomous car. Okay, a self-driving autonomous car. The autonomous car basically does not have a driver. Second, it functions by itself. That means when it sees a red light, it stops. When it sees a green light, it goes. When it sees yellow light, slows down. So those functions, it's not a manual task where somebody has to tell, do this, do that, correct? It does automatically. So that is the reason it is an intelligent automation. An intelligent automation occurs without a human intervention, any manual work. Without a human intervention, any manual work. All right. The next is data science. Okay. It is a mystery. It is a mystery. A lot of people say, oh, analyze data, big data, that data, this data, correct? Nothing. In a very simple plain English, you have data, you don't know what is inside, correct? When I say what is inside, example, we have roughly in the session about 80 students. Out of the 80 students, I don't know who's doing what because it's a remote virtual session. It's a remote virtual session. Somebody may be listening, somebody may not be listening, somebody may be doing something else. Correct? If I use the facial expression, if I understand how they're doing it based on the facial expression, then I can tell whether they're listening or not. Correct? How can I do? I can ask them to turn on the camera and read from the camera, understand what it is. So I'm trying to extract and hidden insights on the behavior of each of the participant, whether the participant is listening or doing something else. So that is basically extracting hidden insights on data. It's called data science. Apply science. What kind of science? Decision tree, random forest, logistic regression, neural nets, correct? So these kind of science I want to apply on data and extract hidden insights. That's why it's called data science. Otherwise, it's our traditional analytics, correct? The traditional reporting, traditional data analysis, correct? So we are not doing that one. We are using machine learning models. So when we say data science, what exactly we are talking? Apply science on data. Apply science on data. What kind of science? Decision tree, random forest, logistic regression, linear regression, neural net, etc. So these kind of science you apply on data and extract hidden insights. That insights of what you are trying to extract on data, you don't know. You don't know. You want to extract them. And that is why it's called data science. So what I'm trying to summarize here, bottom line, it doesn't matter where you learn, what you learn, how you learn. Using artificial intelligence, using artificially created intelligence, what can we do on our day-to-day life? What kind of problem we can solve? What kind of problem we can solve for industry? What kind of problem we can solve for business? Only two problems. An intelligent automation, a digital transformation. You build a solution at a scale to automate something. Okay, so that could be an industrial automation. So that's an intelligent automation. These are all examples. Second, you want to find hidden insights on data for a decision making, for analysis, for doing better things, correct? So that is basically data science. Applying science on data, extract hidden insights, that's a data science. So these are the two things you can do artificially created intelligence, by artificially created intelligence, such as alternate, substitute, replacement of human, emotional, any intelligence. Okay, so you can create these intelligence artificially. When you create that intelligence artificially, what can I do with this? I can do this in this two form, an intelligent automation, data science. So when I combine these two, an intelligent automation, data science, what happens? It creates a digital transformation. It creates a digital transformation. If you look at LinkedIn, okay, if you look at LinkedIn, I'm not criticizing anybody. I'm not saying the people doesn't know what the heck they're talking, right? They all know what they're talking. Okay, people simply put, I'm a digital leader. I have no clue heck what they do in the digital leader. If you don't understand the underlying intelligent automation data science, correct? The intelligent automation data science creates a digital transformation. Create a digital transformation. It's a byproduct of these two. It's a byproduct of these two. When you have these solutions in place, you can build digital transformation, correct? There are so many people live with the PowerPoint, correct? They create PowerPoint and talk, I'm a leader, I'm a this and that. Do digital transformation, it's nonsense, ignore that, correct? So to build a scale of digital transformation, you must have to understand how to build an intelligent automation in data science, correct? So that's what it is. So the best way to understand an intelligent automation, correct? You could imagine self-driving car. If you have seen Tesla, most of the Tesla cars self-driving car, correct? If you drove one of those, you can get the feel how it works, correct? If you have not, okay, you can also see if you are in the area in the Bay Area, you may have seen the Google cars which driving around, so with the with a sign that says it's an autonomous car. So this car is the best way to understand what's an intelligent automation. Okay, best way to understand an intelligent automation. The car fully functions without a driver. You don't need a driver. The car is functioning by itself. Second, the car actually automatically operates based on road condition. What is the road condition? Red light, stop. Green light, go. Yellow light, stop. correct? Slow, sorry. So this understands all the things. Such automation, it's called an intelligent automation. And why it is called an intelligent automation? Number one, no human. Number two, no manual work involved. And this is a type of intelligence you are creating artificially. Here, I'm creating intelligence, such as a driver artificially. There is no driver here. That driver artificially replaced. And that is what I'm saying, alternate substitute replacement. I am replacing a driver with an artificially created intelligence. With artificially created intelligence, it replaces a human intelligence, which is a driver. And that is the point I'm trying to make you understand, correct? So understand. So using artificially created intelligence, we can build an intelligent automation such as self-driving car. Let's move on. I have given one example. I want you to give me an example. Can anyone give an example? Correct? Can anyone give an example? So what I told you, what's an intelligent automation? I explained what it is. I gave you an example. Can you give me one example from your side? Anybody? Anyone? Can anyone? As I said, correct? So speaking, it's not good for me, correct? It's good for you. Step forward and speak, correct? You have to express your feeling. You have to express your knowledge, correct? Otherwise, you will not, correct? So this is not a right or wrong. It is not a forum for judging whether you know or you don't know. It is about collaboration, speaking. Please unmute yourself and speak and give me an example of another example of an intelligent automation. The one I gave is in a self-driving autonomous car. Anybody else? Anybody else? So I see there are 7 people raise their hands. So you're not able to speak. You are not able to unmute yourself. I have no idea what's going on here.
The robots that can help doctors in patient surgery.
Okay, so I agree. Anything else? Anything else?
The automated packing system where everything is packed without any human intervention.
Okay, so these are all generic examples. I can understand. Actually, that's fine. Actually, like, so all right. So anybody else? Any other examples? One more example.
Finding an optimized route from point A to point B.
Okay, so that's more of a navigation. It's like, trying to find out, like, what's the best possible option for me to reach from point A to point B. All right, so agreed.
And Amazon suggestions on below when we are trying to order any.
Okay. Okay. So yes, so I understand all the things what you're thinking about it. Like, so the goal, yes, the goal here is like, simulate yourself, understand how does it work in a real world, correct? Like, some of what you said is right, some of it's not right, correct? When we say automation, correct? Automation is different. Understanding, recommending, decision making is different, correct? In this case, when you turn the car on, okay, you tell where you want to go. So I am in San Jose, California. I want to go to Livermore, right? That's all I'm telling. It takes care of rest everything, okay? That's in a scale of automation. Of course, other things also in automation, but it may not at the scale. So, but think about it, understand how does it work on our day-to-day life. Let's move on. So now let's understand what's the data science. In a simple definition, apply science on data. So why does the science comes into picture? If you look at decision tree, random forest, logistic regression, neural net, correct, etc. So these are all falls under science and humanities. You study in math and stats, okay? In math and stats falls on science and humanity. So that's the reason you apply science on data. It becomes data science. It becomes data science. So data science is basically applying science on data and extract hidden insights. Okay? Let's take an example. I'm applying the science, which is either a decision tree or random forest logistic regression on a patient data. So I have patient demographic information, clinical information, fitness information, lifestyle information. I want to find out what is this patient's readmission rate? What is the patient's length of stay? How long this patient can stay in the hospital? Correct? I want to find this out. Okay, so now you can understand making a recommendation is different, automation is different. Okay, both are using machine learning models. Both are using artificially created intelligence, correct? When I say artificially created intelligence, there is no salesperson. The system automatically makes a recommendation. Why the system is making a recommendation? I want to sell this one. I want to create more transactions, correct? It recommends. So coming back here, when we say data science, what are we referring? Apply science on data. Please understand, as I said, it's a mystery. It is a mystery. A lot of people, they simply say, oh, collecting data, analyzing data, this, that. Nonsense. Okay, that is not really what it is. Correct? You apply science on data. What kind of science we are talking about? Applying decision tree. Otherwise, it is not a data science. Correct? It is not a. It's a research. It is a research. Okay, you apply different things. You will learn this one in the class. Correct? You apply. I'm going to try with the decision tree. It doesn't work. I'm going to try with the neural net. It doesn't work. I'm going to apply with random forest. It doesn't work. What I'm expecting. This is what I'm expecting, but it's not happening. It's not happening. I want to analyze. I want to dig deeper. I want to go and solve these problems. Correct? So in that case, you apply science on data, extract hidden insights. That's by definition what is data science. Okay, how does it work in the real world? Okay, as I said, I'm going to apply this on a patient clinical record, demographic information, personal information, fitness information, lifestyle information, financial information, and find out the length of stay, how long this patient can stay in the hospital, how soon this patient can be readmitted, when the patient is going to be discharged, what is the behavior of the patient, correct? So these are all hidden insights. You don't know this. You don't know this. You are trying to extract. How do you are trying to extract? Apply decision tree, apply random forest, apply logistic regression, neural nets, correct? So these kind of machine learning models you apply on data, you are not automating. Instead, you are getting to know certain insights, such as how long this patient can stay in the hospital, when this patient is going to be readmitted, when the patient is going to be discharged, correct? These things I wanted to basically get to know. To do this one, I am not in the need of a doctor. I don't need a doctor. You don't need a medical degree. Without a medical degree, with data, I can prove this is right. I can prove this is what it is, correct? And that is a scale data science getting into. That is a scale data science getting into. When you go to doctor's office, what happened? The doctor is asking series of questions. Okay, it's not asking about just the demographic information. The doctor is asking a lot of questions, correct? So how long you have been taking medication? What is the last time when you had this medication? So did you eat anything today? Okay. Do you have a body pain? Do you have a headache? Do you have these symptoms? Why? Ultimately, the doctor wants to make a recommendation. That recommendation is basically what the machine does right now. The machine is recommending the patient can stay 5 days. The patient should be discharged immediately. The patient will be readmitted next 2-3 days. Its condition is very bad. The patient is behaving abnormally. To tell these things, you no need medical degree. You no need a doctor. You can use data science to get an answer for these questions. Okay, so compare what is an intelligent automation does, compare what is a data science does. So here, I'm not automating, I'm not driving a car, I'm not making a decision based on certain things, correct? So here, I'm just getting deeper insights on data, okay? Deeper insights on data. So this is a real world example. So you can give many examples, okay? I'm not questioning. I'm absolutely confident you understand this well enough, okay? So you can answer this question. Somebody told recommendation system. So that could be one example you can say. It analyzes the data, understand the customer's buying pattern and previous purchase history. It makes a recommendation, okay? This is what the customer bought last time. They could buy this time as well. I can make a recommendation, right? So all these things are part of your data science. All these things part of your data science. Let's move on. The next is digital transformation. Okay, so it is a little challenging to explain, but what I'm going to say, between a buyer and seller, let's take a best example. Who's the buyer? Who's the seller? Right? Let's take an example. When we place an order in DoorDash, when we place an order in Uber Eats, right? So what happens? The entire process, correct? Placing an order all the way to food delivery, completely automated. That means you don't have to swipe your credit card. You don't have to pay tips. You don't have to tell anything. Everything that happened. The moment you place the order, you get an acknowledgement message saying your order has been accepted. Second, it's preparation. Third, waiting for driver to pick up. Fourth, driver's picked up. Fifth, the driver is arrive in 5 minutes. Once it's done, order is delivered. Next is transactions processed. Here is the receipt. If you notice the entire process, correct? The whole process, it's fully automated. So in this case, you have two things: an intelligent automation, data science working together. And that's exactly what I told, correct? So what I told here, actually, it's a combination of an intelligent automation, data science together. It's what makes digital transformation. As I said, people just putting title on LinkedIn saying I'm a digital transformation leader, it means nothing. It means nothing. You must have to understand these two. Without knowing this one, there is no way you can build digital transformation. So building digital transformation involves building an underlying platform using an intelligent automation, data science, correct? So the reason I picked buyer and seller, it's easy for you to connect all the dots, correct? You take an example, you are placing an order in Uber Eats or DoorDash or Postmate or a Grab Hub. So these platforms are food delivery platform, full-scale digital platform. What exactly it means, correct? So the time you place the order, the time you get the receipt, all automated, no human involved. Okay, entire process. Of course, I'm not talking about preparing food, correct? That is still, we will get to that level soon. Okay, we will get to that. People are talking about a cloud kitchen. People are talking about centralized kitchens, right? We will get to that level, right? Preparation also takes place at that scale, correct? At that scale. But at the moment, the best way to understand, you could imagine, correct? The platform where you can order food and food has been delivered, correct? Why does those platforms are a digital platform? As I said, it has two things. It automates the end-to-end process, which is an intelligent automation. During the process, it makes a decision, correct? What decision it makes? It basically tells you, correct? Example. Let's say you placed an order for an hour, correct? Sometimes I would be amazed to see how this works, correct? So the order is placed, and it's been almost an hour, nothing happens. So it depends on what app you use. Some app tells you, correct? Hey, it's taking time, we are going to give you discounts. Okay, it's taking time, we are going to give you a discount. So that is decision making. That's a data science, right? It understands the time is supposed to deliver in an hour, but it's more than an hour and 30 minutes. It takes a lot of time. I'm using data science to make a decision, right? So what decision I'm taking? The decision that I'm taking, actually, I want to give you a discount. How much discount I could give? It calculates and recommends based on the amount of order that what you placed. So all these points are best way to understand digital transformation. The other example, Uber. The car service, right? Like in a Uber travel service. So if you take Uber travel service, right? So you are here, your family is in India. You can book a taxi for your family. You can book a taxi for your family in India. You just tell the place to pick up, the place to drop off. The rest, everything magically works, right? So it doesn't care about what time zone you are in. It understands from the time where it needs to pick, where it's going to drop, the time zone, local, everything, currency, etc. It does the entire thing automatically. Such platform, what I'm talking about, digital platform, it is called digital transformation, where information flows from point A to B without any human involvement, without any manual work, right? So that's the best way. How do I build this one? How do I build this kind of platform? And that is the point I'm making. You have to have these two working together. And intelligent automation, decision-making data science need to work together. If you are in a particular route, the route is basically got traffic, accident, traffic. I want to find an alternate route. I have to do a reforecast. What is the reforecast? The time it's going to take and how much cost is involved. So what do you call data science? What do you call data science? The entire process that's automated. So taking your credit card, processing your credit card payment, giving you a receipt, everything is in an intelligent automation. So going back, what I'm trying to make you understand, when people talk about digital transformation, the best way to understand how DoorDash works, understand how Uber works, and then you can imagine what is digital transformation is. And this is what needed. So point is, without an intelligent automation, without data science working together, it is absolutely impossible to build digital transformation. And people put the name saying that I'm a digital transformation leader. I really don't know what they're talking about, but this is what ground reality is required. Ground reality is required. All right. Let me summarize. So what we understood artificial intelligence. By definition, alternate, substitute, replacement for human, emotional, any intelligence. What can we do this in industry? By creating artificial intelligence, okay? By creating intelligence artificially, what can we do for industry or on our day-to-day life? Two things, an intelligent automation and data science. What's an intelligent automation? Automation occurs at a scale without a human manual work. Data science, apply science on data, extract hidden insights, correct? So in this journey, you will deal with big data, IoT, all those things, but that's not what data science, correct? Data science purely, you must apply science. You must apply science. When we say science, what are we talking? Things like decision tree, random forest, logistic regression, linear regression. These are all science and humanities. You apply such scientific data analysis technique and extract hidden insights. That's why it's called data science. When you combine these two, you form a digital transformation. In a digital transformation, Transaction occurs without a human, any man will work. Transactions occurs without human, any man will work. Transaction means not only paying payment through a credit card, anything. A business transaction. A business transaction, correct? Things that occurs at a scale, correct? Without any human from point A to B, all digital, electronic, right? So that's a digital transformation. So this is what so far we learned. As I said, these are all mystery. Not having enough clarity on these things, it would make us to go nowhere. It would make us to go nowhere. So that is the reason my personal opinion, people need to understand these things to the deepest level, connect all the dots and get to know how does it works in real world is fundamentally most important. So once you understand, then we can start working towards implementation. How do I implement this? How do I build this one? How do I use this one? Etc. Correct? So that is the reason we spent some time to understand all the things. I hope this brought all of us on the same level. What is when people say artificial intelligence and intelligent automation, data science, digital transformation. All right, let's move on. How do I make this happen? Okay, now we are talking about how do we implement this? How do we build this one? And this is where machine learning comes into picture. Teach the machine. Teach the machine. Do not teach the human, correct? Don't make people to become a doctor. Don't make people to become a scientist. Don't make people to become an accountant. Instead, make the machine to do the same thing. Okay? So the goal is what? Replace human, alternate human, substitute to human. How? How? Teach the machine. How do you teach the machine? That's where machine learning comes into picture. That is where machine learning comes into picture. So if you ask people, what is machine learning? There's the millions of definition in a simple, plain English. My goal is to achieve and build or implement an intelligent automation, data science, digital transformation. In that context, I want to teach the machine, not a human, Okay, how can I teach the machine? That's basically what is our next steps. Okay, so that's basically what is our next steps. So I think we started at 9 o'clock. It's almost 11 o'clock for me. So why don't we take maybe a 10 minutes break, and then we will come back and continue the discussion. And then after maybe around 12:30, we'll take a break for lunch. Okay. So I'm going to stop here. And before we go for a break, 10 minutes break, if you have any questions so far, correct, please ask me. As I said, this is in my view. Okay. This is in my view. It's most critical terminology you must have to understand very clearly. If you don't understand, then it will be so difficult to follow anything further down. Anything further down, it's going to be a little technical, and it is some more advanced concepts. Okay, some more advanced concepts. So that is basically what I'm trying to make you understand. Any questions so far? Anybody? Any questions?
Sir, என் பேரு கிரு.
Yes sir, yes sir.
நம்ம இந்த ட்ரைனிங் ரொம்ப அருமையா போயிட்டு இருக்குங்க. இது நல்லா இருக்கு, இன்ட்ரெஸ்டிங்கா இருக்கு. இதுல என்னன்னா நம்ம என்ன சொல்ல வரோம்னா, நான் சேஃப்டில கொஞ்சம் ட்ரைனிங் எல்லாம் எடுக்கிறது.
Kiruji, if you can talk in English,
can you make
there are many from different states, right? It's across the US it's happening.
Okay.
You can talk in English so everybody can.
Yeah. Okay, so the training, the arrangement is very interesting and it's going very well. But the emotional intelligence and the intelligence automation, suppose the car goes, it understands red signal, green signal. If anything, children cross, how it detects, is it emotional intelligence?
It will understand everything, sir. Actually, I will cover that one. So
okay.
When a car goes, it's basically, there are many things working in the car engine. It's a piece of software advance. It understands on an image, whether it's a human or an animal or it's a toy, it understands. Okay. It's basically human recognition, object recognition, gender recognition. It understands everything, correct? So based on that, it behaves, correct? Let's say you are asking a question, the car is going on 100 miles speed.
Yeah.
All of a sudden, a human is crossing. What happened to the car? Does the car is going to hit? It will try to best to stop the car. Okay. It's like a driver. So you are in 100 miles per hour. You may lose control when you're applying sudden brake, right? Like, so I see a human is walking in front of me. I want to control, I want to stop the car. That's what the car is going to do because it sees an object. Okay, it recognizes the object as a human. Correct? As soon as recognized, correct? So it's same for everything. Even for an animal, it's not going to go and crash. Correct? It has to stop. It will start applying. But on the same speed, can the car stop? Okay, so that is basically based on how well the road condition is. Let's say the road is not that slippery. It can stop. If it is too slippery, it might not able to control. If it lose control, it can go. So that I cannot blame. Okay, the car doesn't understand a human. That's a different issue. Okay, so the issue, can a car understand? Correct? When a human walking in front of a car, when a dog is walking in front of a car, when a toy is in front of the road, can the car understand? Absolutely, it understands this. It understands that. That should be okay.
My other thing
I know
is
where you
they
are coming
also
from. It's people fall under ethical AI, human AI. So that's where this question comes in. I understand that part. Answer is yes, it understands.
Okay, excellent, very good. Thank you.
Okay. All right. Any other question? As I said, you won't be finding this level of information anywhere, whether you do Google, YouTube, at all. Correct. So this to the point, what is needed in our life when we go to work in projects in industry. Correct. So if you have any questions, please raise and understand. Without understanding this, going further deeper into the space will be very challenging. You have to connect all the dots. Okay. So the core building blocks, what we talked about, it's understanding this and utilizing that for further learning would be very highly beneficial to build your core skills and knowledge and expertise.
Hi, Jyotiji, this is Freddy. My question is only very specific to emotional intelligence.
Sure.
See, emotions are human. And yeah, a computer would understand when you look at a camera will see the feelings and understand, but it will not understand that is related to heart. Heart has feelings, right? Like brain has feelings, heart has feelings, face has feelings. So how far artificial intelligence can go to address?
So yes, I am going to address this one, but I will tell you quickly. So where we are right now, there are different type of intelligence we build. You take a problem, solve the problem, which is very narrow focused. Then you generalize, correct? So I don't want to be narrow based. I want to generalize, correct? So that means generalized means instead of solving many problems, building many solutions, how could I group similar problems together and build one solution? That is where industry is trying to lead towards. So when you do this one, as I said, my definition of maturity or emotion, it is not happen through a formal or an informal training. That means to kill a snake, I don't have to go and take a training because that happens when I grow and mature. When a model is growing and mature, it will pick up the emotions by itself. It's become like a human. That is a state we want to get to. We are not there yet. But that is where ultimately, that's what we want to achieve. So whether we like it, we don't like it, industry is leading to that way. Industry is getting towards how do we make the model to make more emotion like a human? When a human, like for example, when you throw a snake in front of a 1-year-old child, the child doesn't know why. The child doesn't have a maturity. When you put a snake in front of a 5-year-old boy, the boy will run away. Why? Somewhere the boy learned. Somewhere the boy heard, oh, snake is poisonous, it's going to kill me. I want to run away. Correct? You see the difference? So where we are in the baby level. So when we grow and mature, we understand. So that's what the type of intelligence we are building. We are right now building an intelligence very narrow focus. Then we want to generalize. Then we want to go for super intelligence, which is almost like a human. We are not there yet, but ultimate goal is to get there.
But with your understanding and knowledge and expertise, do you think that the humans will be replaced except the pocket full of air that is in your heart? And because the robots can do physical work, the machines can think logically and can analyze. So where will the human being be going forward?
Sir, I think there is two aspects to your questions. One is basically the human side of it. Second is an automation side of it. Correct? So the idea of sir, if we look at why do we have to go this far? Okay, I will tell you why do we have to go this far. Any company you take in the world, whether it's a small, medium, large enterprise. So if a company spends 100 million in a year on the company expense, out of 100 million, 60 million goes to payroll. 60 million goes to payroll, 60-40. Can you believe this? What am I getting out of the 60 million? Nothing. Some cases, nothing. Why? So people come morning, Okay, they go to break room, make coffee, come back, restroom, phone call, correct? No productivity. I want to get rid of those kind of people, correct? I want to create more productivity. It is not about replacing the humans. It's about increasing productivity, increasing automation. The capability of automation reached a point. If you notice so far, correct, we've done automation, mostly human-driven automation, okay? We hire people from Infosys, Wipro, TCS, they come and code and do stuff, correct? That automation is not what I wanted. I want to build an automation where it almost acts like a human, which has been challenges, which has been a limitation. Now technology enabled us. So that is where industry is leading, not replacing John, Mike, Lisa. So they are still there. But how do I replace humans' productivity using machine as a human to make the similar productivity much higher level, correct? Much higher level. So I think the need is not getting rid of people. The need is whatever task a human does, similar task the machine can do and increase productivity. I think that is the what needed, right? The need is increased productivity.
Thank you. Thank you for the understanding.
Sure. Any other questions?
You want to take a break, Jyotiji, and after that
Yes.
we can have this chat, you know?
Yes. So I have 2 minutes. We can take any questions because we stop exactly at 11:10. So 2 minutes. Any questions?
Yeah, I saw Raja Jekilinki. Are you able to unmute and ask your question?
Yes, sir. My question is that how the data is fed into the system to analyze. So it could be in a book format, text, Excel, or tables, different types of formats of data.
Sure. So data right now, as I said, correct? Data could be image, it could be text, it could be image, it could be voice, it could be video, it could be audio, it could be anything, right? And that is why our traditional data warehouse, ETL, it's not required anymore, okay? We reached at a point where we have been expected to work all type of data, not one type of data. So far, if you notice, we know how to read data from a table, select star from EMP, we know how to do it, correct? If it's an Excel spreadsheet, we know how to analyze this one, correct? Like, you know, creating VLOOKUP or pivot table, etc. So these are all things we learned on our day-to-day basis. Now data reached a point, correct? What data is right now? So data basically, like, you know, in any form you could imagine, it could be an image, it could be voice, it could be text, it could be anything. How do you work on all this data? How do you integrate? How do you do the same thing, extract, transform, load, correct? Similar things. So this is where the new skills that is required, which is, in my view, data engineering skills. Understanding what is lakehouse, understanding how do we work with, like, you know, data catalog, understanding building and a data virtualization. I don't want to move the data, correct? So my goal is how many times Trump tweeted in a day. So that means I have to go on Twitter and find out how many tweets he made. So in that context, do I have to read tweet data and store in my database? No. Why? I don't care what data it is, a public information. So my goal is number of tweets made by Trump today. So I can go ahead and search on this. I can find out this one. In that context, I don't have to store the data. All I need is, I need a data where I can analyze what I need. So the purpose of getting this data and storing, it's gone. It's no longer required, correct? So traditionally what we do, bring data from an operational system, store and process. Now that is completely gone, correct? Completely gone. So the need for data, it's different than what it was right now. Second, the type of data, what we work and process, it's changed. So that means we need a new skill. So using that skills, you can work with large complex data sets. And that is what we are going to talk about. And that is where the tools from Google's world, AWS world will help you, correct? So there are several tools that is available, correct? So we used to think, oh my God, Hadoop is the biggest platform where we can deal with all the things. Now that's gone, correct? That's gone. Hadoop is just primarily become a storage actually, correct? You can use it as storage, but the intelligence, which is going to be applied on data, okay? How do you connect? How do you integrate? How do you map? How do you transform? How do you extract insights? Pre-processing data, all these things, it's a very unique skill at the moment. Understanding those skills needed, correct? So going back to your point, how do you bring the data? That's the data engineering skill, which we are going to talk tomorrow. All right, at this point, let's take a break. I do need a break. Okay, so we will come back right now, 11:10. Okay, so we will meet at 11:20 PST, Pacific Standard Time. All right, so the session will be active. So I'm just going to come back again. We'll talk. Thank you. Take some break, drink some lot of water, move around. Bye.
You need badly, you need a break. Please have your break.
I think
thank you, guys.
we need to take 15 minutes, Jyotiji. If you want 11:25, we can join if you want, right? So because you're talking a lot.
Yeah, definitely. I think he needs good break. Yeah. So
And
thank
also
you,
we
guys.
have
I will.
Prasanna Ramji, like at 1:30, he is coming to speak, right? So he is going to join at 1:30. He's
Yeah.
going to share his experiences. Like he is a chief AI architect, and he has a lot of experience, and he is going to share his real-time experiences at 1:30 to all the participants. Yeah.
That will be great. Yeah. So hold on to your questions, and after the break, we'll have again a great continuation of the session. Thank you all.
Ram, do we need to pause the recording or? Hello.
You can pass it there if you want. Will it come back again as soon as we pause it?
No, no, we have to pass it, and then once the session starts, we need to start.
Okay.
Yeah, it's only 15 minutes now. There may be a issue with pause and start. Let it be.
Okay.
People know that
Okay.
it's break time now.
Okay.
We'll put this screen. So whatever gallery view, that should be good. Or any slide we can do.
All right, I'm back now, so we can start.
Thank you, Jyotiji, for joining back. Is everyone? Hope all are back from the break, and I think we can start now.
Okay. All right. So what we learned so far, right? Like, so before I jump in, somebody was asking about how do we deal with data? So this is my real project right now. Okay. So this is a real project. So the solution that what we are trying to build, a financial model for hourly forecasting. Then ultimately we want to get into more of minute level forecasting. But right now, so we want to start with an hourly forecasting. So if you look at here, data flows from Google Cloud into Amazon Clouds. Okay. So there is so much of data coming from various sources. Example, the data that what we get from Google Cloud to Amazon Cloud. So Amazon Cloud, it's where we running the model right now. The models are running in Amazon Cloud. So if you see here, there are two platforms, AWS SageMaker and Google Vertex AI. Okay, so in both the places we have model, both the places we have data, but the main platform where we host all the data, what we needed, it's AWS Redshift. But we get location information, weather information. The location information, it's more of an image, correct? It gets that one plus some other text data as well. So we get that kind of data. So what is the goal? So the goal is to do a financial forecast. Okay, how much money somebody can spend in this location. Okay, yeah, prediction on sales as well as sales means I'm talking about revenue and the quantity, how much money they spend, what product they buy. So going back to answer to your question, to deal with data, there are several technologies involved. Okay, and that's basically what I'm trying to highlight here. It is not a technology or just a one platform. It's a combination of platform that will be involved. Okay, so if you notice, there is a pull method where we pull the data. There is the push method, it push the data in a live stream. Okay, in a live stream. So the skill set, what I see is changing. Okay, not the underlying data. The underlying data still remain the same. All right, let's move on. I will cover all these things in a live example so that we'll get to know.
I guess Bhupinder Singh raised and Jyotiji, if he wants to ask anything.
Okay, yes, go ahead. Mr. Bhupinder Singh, can you go ahead? What's your question?
Okay. And Kumar, you wanted to ask anything?
Hello, Kumar.
Yeah, maybe once if you guys don't want to ask, please lower your hand so that we won't know that, so that we know that you are not asking. I think we are good.
Okay. All right. Let's move on. So we'll go for another 1 hour, then we'll take a break. Okay. So where we stopped? How do we do all the things? Kind of like, so whatever we talked about, like, building an intelligent automation, data science, digital transformation, how can you do all the things? So the only way you achieve is teach the machine. Now the question is, how do we teach the machine? There are two approaches. A statistical based learning approach, neuron based learning approach. All right. That is how the machine is learning. And what the machine learns, it learns about a language, it learns about a process, vision, and then a process. Can anyone tell, current, based on your experience, you as a human, is there anything else you learn? Language, vision, and process. Okay, so language means what you speak and write. Vision, what you see and do something. Process, things what you do. Cooking a rice, it's a process. Cooking a biryani, it's a process, correct? You as a human, do you feel you are learning other than these three? Okay, other than these three. So what I'm talking, while speaking, writing, you are doing something, you are learning something. Vision, when you see something, okay, you learn something. Process, things we do, like I said, cleaning garage, making biryani, correct? Washing clothes. These are all kind of processes, correct? When I say washing clothes, you can't just like that go and wash the clothes, correct? There is a process to be followed. So what I'm asking, we as a human, is there anything else that in our learning process involves? Yes, someone raised their hands. Can you tell me? Okay, so there is a reason for me to ask the question. Okay, if you understand this, then you can understand what is coming in machine learning. Can anyone please? Yes, you raised your hands. You can unmute yourself and answer the questions. The question is, we as a human, we learn from language. When I say language, so when you read something, we learn. When we speak something, we learn. Vision, when we see something, we learn. Based on the vision, we act something. Based on the language, we act something. So those are all learning process. Same thing, when we do something, we learn. The something is the question. We don't define what something is. Something could be anything. Something could be anything. We do that. We learn this. Okay? So I'm asking, is there any other learning pattern that you could see as a human? Don't worry about the machine. Yes, please answer the question. I'm not getting any response, so probably you are on mute. So can you please speak? All right, so I may have to move, so I'm not getting any response from anybody.
Yeah, we are not sure. There are so many people raise hand. I don't know whether they are accidentally raising the hand or.
Okay, all right. So let's move on. Actually, so that's fine. So how does the machine learn, correct? So that's basically what we are trying to understand and what the machine is learning. So the machine is learning two aspects: a statistical-based learning approach, neuron-based learning approach. Okay, that is how the machine is learning. These are the learning approaches. What the machine is learning, it learns the language, learns the vision, it learns the processes. Let's understand, correct? So there is a how part and there is a what part. How the machine is learning, I told you statistical learning approach, supervised, unsupervised reinforcement learning. Okay, so that is one type of technique. Second type of technique, deep learning. That is another way the machine is learning. That's a neuron-based learning approach. Okay, as I told you, machine learning, how the machine is learning, what the machine is learning, how statistical neuron, and that is basically called in these categories. Okay, why the underlying architecture, how the machine is learning in a supervised is different than a deep learning. Under an unsupervised is different than a deep learning. Under reinforcement is different than deep learning. The underlying architecture for these things are different, and that is why I told. Okay, that is why I told, if people says deep learning is an extension to machine learning, I would not agree. I would argue with them. Why? Machine learning does not dictate any underlying architecture, but deep learning does. What deep learning tells you, how the machine is learning. There's an input layer, there's an output layer, there's a hidden layer, there's a weight, there's a bias, there's a sigmoid function, etc., etc., etc. So these are all architectural components which does not have the word machine learning. Okay, so the word machine learning, it basically tells how and what the machine is learning. It doesn't dictate any architectural. So do not compare the word machine learning with the deep learning. Understand how and what, how the machine is learning, what the machine is learning, what you must have to understand. How the machine is learning, either a statistical based learning approach or a neuron based learning approach. If it is neuron based, deep learning. If it is statistical based and a supervised, unsupervised reinforcement. I'll cover this more in detail later. Let's move on. What the machine is learning. As I explained, you as a human, what you do, you see something, that's your vision. You speak something, that's a language. You do something, that's a process. Okay, you as a human, vision, language, process. Okay, vision, language, process. It doesn't matter what else involved. That's all you do. Okay, you see something, you speak something, you do something. How do you teach this to machine? And that is what computer vision, natural language processing, robotic process automation. Okay, computer vision, natural language processing, robotic process automation. If you are trying to teach the machine to understand the vision, example, okay, so take an action or respond based on what you see, and that is what I want a machine to learn. Somebody asked me, right? Like, so when a car is on a constant speed, it sees a human is walking in front of me. What am I do? Take an action. Stop the car. Stop the car. That's the vision. How do you teach this to the machine? That falls under computer vision. That falls under computer vision. All right. You speak something, okay? Whether you could speak Tamil, Telugu, Hindi, Urdu, whatever language you speak. I want to make the machine to understand those things. So I develop conversation, speaking, writing, okay? So it could be anything, okay? So it could be reading, it could be writing, it could be speaking and respond to this, correct? So how can I do? That's a language. So how do we teach the machine to learn the languages, both spoken and written? That's natural language processing. That is natural language processing, NLP. I'm a human. I want to make some decision. I want to solve some problem. I want to automate certain things. How can I do? Okay. So those are all processes. How do we teach the machine? That's a robotic process automation. It is absolutely critical if you want to be in the space. Okay. If you want to be in this space, understanding this deeper, it's most important. Building application using this most important. Okay. If you don't understand, if you go with abstract concepts, you will not have any value to people, correct? Especially when it comes to this implementation, okay? So, goal, what we are trying to understand, how do we teach the machine, what the machine is learning, how do we make it clear, okay? So here, there are two learning approach, a statistical-based learning approach, neuron-based learning approach. So the architecture, the underlying architecture of how the machine is learning, what the machine is learning, how the machine is learning in each technique is different. Okay, the architecture for supervised machine learning is different than a deep learning. As an example, I told you, under a deep learning, the machine learns using several architectural components such as input layer, hidden layer, output layer, weight, bias, sigmoid function, forward propagation, backward propagation, etc. So these are all core building block, right? How the machine is learning. If I go and look at a supervised machine learning, I don't have any of those things. In a supervised machine learning, I don't have basic things such as an input layer, hidden layer, output layer. What would be the best way to get started? Learn the simple supervised machine learning. Then you can go from one by one, right? If you directly jump in, then it will be so difficult to understand. So let's understand the basics. The basic for the simple, most easy way to get started to your learning process. Start from a simple supervised learning. So we are going to do a lab. Okay, so we are going to do a lab. So I'm just going to take you to the lab and then teach you on how to implement this one. Kind of like, so this is basically, I think I closed it. So I built some examples to go over in this one. So that's on a Google Colabs. I will walk you through. Okay, from ground up. Okay, from ground up. So how we can build a simple supervised machine learning model? How do you basically work with various models, like different models that's involved? Okay? I'm just going to teach you this one. So we'll cover this in the actual lab. Okay? So scroll down. So I built some examples. Okay. Okay, so if you can see here, there are different models I want to implement. Okay, starting from a decision tree. Okay, so I want to implement different models, k-neighbors, logistic regression. So the three model we want to implement, understand very simple things, easy to follow and implement by yourself. So point is, when you do something in a simple way, understand the concept, it makes you very valuable. Okay, you don't have to learn too many things and say I'm an expert. Even if you learn some simple things, understand the concepts really very well, that makes you understandable or valuable. Sorry. So what we are trying to understand. Okay, so the goal we learned, if I want to create intelligence artificially in the form of an intelligent automation data science digital transformation, the goal is to teach the machine. How do we teach the machine? Use statistical based learning approach or a neuron based learning approach. What is that? We'll see in a minute. Okay, that is how the machine is going to learn. What the machine will learn, it learn a language, it learn a vision, it learn a process. So how does this apply in the machine learning world? In the machine learning world, based on how the machine is learning, if it's learned from a statistical, such machine learning is called supervised, unsupervised reinforcement. We will see that. If we are going on a neuron-based learning approach, that falls under deep learning. Okay, that falls under deep learning. The architecture under each one of this is different, and that is why it's grouped in a different way. All right, second, how does the machine is going to learn? Understood. What the machine is learned? Computer vision, natural language processing, robotic process automation. So these are all industry applications. When you go on a project, when you work on a client project, what exactly the problem you're going to solve for the client. So it could be any one of these areas. It could be any one of these areas. It could be vision-based, it could be process-based, it could be language-based, correct? It could be any one of these areas, correct? So it's going to be something around this. So this is what it is. Under vision, the machine learns about a vision, okay? It understands object recognition, general image detection, gender detection, etc. So that's basically like, so understand the images and tells what it is. Understand the videos, it tells what it is. Understand the object, it tells what it is, or it takes an action, etc. So that's the type of application we built. Typically, you noticed actually. So facial recognition, it's kind of an application. So you can look at your smartphones. There are many different functions in this one. There's a biometric authentication, there's a voice recognition, etc. Okay, so that is one type of application you can build. Second is a language-based application. So what the language-based application is, like, when you speak something, the machine understands, it builds a conversation. When write something, the machine understands, builds a conversation, correct? The next is process automation. So what do I automate actually? So I'm going to automate tasks that what I do. So what kind of task I'm going to do, correct? So keep in mind, in all these places, you have analyzing data comes into picture, extracting hidden insights into picture. For example, correct? So I want to analyze and understand whether the given data belongs to male or female, correct? Simple example. So I want to analyze this one, correct? So goal is basically what? I want to analyze the data, understand what it is, correct? So all the things will come into picture. So from industry perspective, what kind of application you can build? You can build an vision-based application, language-based application, process-oriented application. So this is where you basically come into picture to learn and build applications, So to understand this, I just put this visual, right? We as a human see, that's a vision. We as a human speak, that's a language. We as a human do something, that's a process. Okay, so it's basically coming back, computer vision, natural language processing, robotic process automation. Okay, robotic process automation. So basically, whatever we do, it's just done by through machine. Okay, so you see something, do something, that's the computer vision. You speak something, build something, okay, do something, okay, all this done by process or language, correct? So you may heard about CV, computer vision, NLP, natural language processing, RPA, robotic process automation. There are companies out there, okay? So when I say there are companies out there, example, you have heard about company like UiPath, Automation Anywhere, Blue Prism. So these companies are heavily focused on robotic process automation. There are two ways to look at it, correct? A robotic process automation, a process automation occurs based on an instruction or a rules or self-learning. If it is self-learning, that falls under artificial intelligence. If it is rule-based, correct, hard-coded rules or programmatically controlled rules, then that is not a self-learning model. That's still robotic process automation done without a human, but still there is an underlying instruction has been given. So I see these companies are doing at that scale of automation, taking out human, building automation using instructions. So that I would not call intelligent automation. I would not call an automation created based on artificially created intelligence, right? So understand the difference between, there are companies out there such as UiPath, Blue Prism, Automation Anywhere, etc. Okay, so these companies are saying that they do RPA, robotic process automation. That automation, I'm not saying they're not using artificial intelligence. If those automations are self-learning, when I say self-learning, the machine learns and automates by itself. If such, yes, then it's an intelligent automation. If it is not, if it is an instruction driven, why they call RPA? Robotic means there's no human involved. Okay, there's no human involved, but it doesn't mean it's artificially created intelligence. There's a difference. Not involving human is different than artificially created intelligence, correct? So I could still do instruction driven. Okay, I could still do instruction driven. So that doesn't mean it is artificially created intelligence. It could be instruction driven. So this is basically what you need to understand. Okay, so what we understood, how to make a machine to learn, teach the machine. How to teach the machine, train the machine. How to train the machine, that is where we need to come up with supervised, unsupervised reinforcement, deep learning type of application that what we are going to build, computer vision, natural language processing, robotic process automation. Okay, if you want to master, okay, if you want to be a data scientist, or if you want to be an automation engineer, okay, using artificial intelligence, using machine learning, then you must have to understand, correct? You must have to understand all the things, okay? This is basically a summary of what we discussed. So this I will touch little later. So this is basically the building blocks of what is involved in building machine learning models. I will cover this one. Okay. So the ultimate goal to teach the machine and create intelligence artificially in the form of an intelligent automation data science. Now, what is machine learning? Understand the fundamentals. So once I'm done with this, I will do a lab. Okay. I will do a lab means how do we implement or get started with building some very basic, simple machine learning models. Once you do on your hand, then you will become an expert, or at least you can connect the dots what you learned. If it is not, I would say it would be so difficult to understand all the concepts. Okay, it would be so difficult to understand the concepts. So there will be a lab that I wanted to do it. Okay, in that lab, we will cover all the things. Okay, and also I want you to do the lab by yourself by doing what I'm doing, or if you need some time, we can do that as well. So let's understand what is machine learning from in-depth learning perspective. Okay, so let's assume when you
one question, if you can go to the building blocks of machine learning, please.
Okay.
No, the one before this, the pictorial. The one before this.
Okay.
No, before this. There are diagrams, right? Natural in this one, the computer vision, natural learning processing, and robotic process automation are again become the part of the statistical and neuron based, or are they separate?
You could use both. You could use both. These are all applications. You could call these are all applications. For example, somebody asked me, "Hey, the car is going on a constant speed. Now there's a human coming in the mix. So how does the car understand? So the car understands. You have to make the car to understand the recognize an image or recognize a human. So how do we make the machine to learn? That's part of computer vision. It's an application you are building. That application, it's basically a vision-based application where the machine, the car looks at an object or an image in front of it and understand it's a human. How do you tell that one? So that application is computer vision. How do you implement? It could be using deep learning. It could be using statistical based learning approach. So these are all applications. How you build this application, it could be both, it could be one, it could be combination of all.
Thank you.
Okay, Jyoti, this is Prasad Tata.
Yes, sir.
If I can ask you a quick question.
Yes, sir.
The way I understood is statistical learning approach is a sequential process or structured process.
Yes, sir.
And how it is different from the neuron-based learning. I'm a little bit confused about what is.
Yes, sir. So I will tell you neuron-based. When a simple example, let's say in a statistical based, I define the hypothesis. Do this, do this, do this, do this. Correct? Okay. If this happens, this. If this happens, this like this. I define the rules. I define the hypothesis. In a deep learning, I don't have to define. It's like a human. You figure out by yourself. I teach you 2 + 2 4, 4 + 4 8, 8 + 6 16. That's it. Done deal. Now I don't tell anything else. Right? You go ahead and figure out what is 3 + 3, what is 6 + 6, what is 12 + 12. You figured out. How did that happen? That's basically there is a hypothesis to develop. You tell this is how you follow it. Otherwise, you expect the machine to build the hypothesis itself. Right? So under this condition, this is what happens. Under this condition, this is what happens. Here I tell this is what it is. Here I don't tell anything. Right? So in a statistical base, I define the hypothesis. I build the hypothesis. In deep learning, I don't do this one. In a nutshell, in a simple one-line example, correct? In a supervised learning, you tell these are the features to arrive at a conclusion. Okay, is it male or female? Is it boy or girl? Is it pass or fail? Is it live or dead? There is a hypothesis. So that hypothesis in the machine learning world is kind of features. You tell if these features are there, yes, it's live. If these features are there, it's a boy. If these features are there, it's a girl. Here, I don't tell those features. I myself don't know heck what the features are. You go and find out. So that's kind of deep learning.
So is this like an artificial neural network or something?
Yes, it's artificial neural network.
Thank you.
Hi. So what do you mean by hypothesis, first of all? And
so
then,
hypothesis is very simple, correct? Like, to arrive, correct? Is this patient going to live or die? Correct? So I'm going to say this person is going to die. Why? This is my hypothesis. Because all these conditions, correct? I don't see more than 10 days for the patient lifetime, correct? So that's the hypothesis to arrive something, okay? So hypothesis is a generic term I'm using to arrive a state, correct? So my goal is to arrive something. To arrive something, I need
a set of rules to be followed or something to be achieved. So that's something, the rules, what I'm calling hypothesis, correct? If this happens, for sure, the patient is not going to there more than 10 days, correct? So my goal is what? Tell me whether the patient is going to live or die. Answer is die. Why? Because of this. Because of that, what I'm calling hypothesis.
So are you saying that we can't do supervised learning using deep learning techniques?
No. I don't think that the question is relevant actually. Like, so what I'm trying to say, you can use both to solve a problem. To solve a problem, you can use both, or you can use any one of them, or you can use combination of. In a real world, you do combination of all. Okay, it is not just supervised. It's not just simple deep learning, but what you need to understand how the machine is learning, the underlying architecture. This is the clarity industry is lacking. Okay, the clarity of how the machine is learning, it's what lacking. Okay, so I'm just trying to say. So if you have a hypothesis, this is what I want the machine to learn, then I will go on a statistical based learning approach, which is much easier. I don't know what the hypothesis is. The patient is going to live or die. I really don't know. Okay, I really don't know what condition makes the patient to live or die. That condition itself I want to discover. How can I do? That's when I go to deep learning.
So if I want to build a face recognition system, so what do I use?
I can use both. You can use both. Okay, depends on the data. Okay, depends on the data. Let's say facial expression, correct? Let's take an example. In the face,
face recognition system.
Yes,
which is used in a mobile phones. Like
that is what I'm telling you. Facial recognition is what I'm talking about. So understand the face. Like, look at the face features such as face size, ear, nose, mouth, color, etc. These are all features. So if this happens, it's a male, or it's a John, or it's a Smith, or it's a Mike. I want to teach the machine. If the data that what I need in more of an image form, I would go with the deep learning. If the data what I need more of a structured picture form, then I'll go to supervised machine learning.
So from what I know, from what I have read, like even what Andrew Ng says that, so even if you are using deep learning there, the definition of supervised learning and unsupervised learning is different from what deep learning and machine learning is. Because
okay, hold on one second. First of all, do not use the word machine learning. It's just a concept. Okay. First of all, do not use the word machine learning. That is just a concept. It will not dictate any underlying architecture. Point one to consider. Don't repeat that. So machine learning, it means nothing. Whether it's by Andrew Ng or anybody else, tell them, correct? Machine learning means nothing. So now between supervised or deep learning, which one I can use for facial recognition? You can use both, or you can use any one of them. It depends on how much data you have, what type of data you have. Okay, so based on that.
So if we have label data, we use supervised learning.
It doesn't matter label data or not. Like, so label data could be an image, correct? So learning an image is slightly different than learning a table-based data sets, correct? So if you are learning
label, sorry, I'm not saying table. I'm saying labeled data.
I'm saying label as well. So label could be image. Like, for example, I'm taking an actual face of a person and then classifying this is a male. I'm taking an actual person of a female, it's a female. The other side, I'm not have the actual image, but I have the actual data. How the nose, the size of the nose is 2 centimeters. The ear size of this one. So that is not an actual image. That's a table which describes the face of a male and female.
So you are saying about the features, right? The nose, the face. So these are the features. So what is a label is like for every row of data, we have both the features as well as a label. The label says whether the particular.
You don't have to go that far. I already have a data sets for you to understand. Let's take the same example what you're talking about. So this is what I'm going to teach you right now. So take an example. So this data that what you see actually, it's in the form of a table. And it has a label, correct? It tells me male or female, correct? So this is basically not an actual image, correct? Not an actual image, correct?
So even an image can have a label, right? Even for an image, we can label it as
yes. Answer is yes. But you need to understand, reading an image and identifying all the things is different than you explicitly telling what is height, weight, color, correct? That's different, correct? That's different.
Yes.
So that's different. So let's simplify this one. We have to move on. Let's simplify this one, correct? So
so what I was saying is, so when we have the label data, we do supervised learning. And when we have label data,
no, that decision is absolutely wrong, correct? So I'm talking in a real world, correct? So using the decision of whether user supervised deep learning based on whether I have label or not, that is a wrong decision. It's purely
Okay, so
based
you're
on
saying that supervised learning is not based on whether we have labeled data or not. So it is something else.
No. Supervised learning needs a label data. But what I'm trying to say, whether to use a supervised or a deep learning, the question is different, correct? That's the supervised machine learning.
We never have a question about whether to use supervised or deep learning. So fundamentally, the question is, if we do supervised learning, then we can either do deep learning or some other statistical models, right? So
I am not getting the questions. Maybe we can take it offline. We will move on actually. So my answer to your question, if I understood rightly, correct? Let's take a real, let's talk practical problem solving technique, correct? Not abstract concepts, correct? Let's have, you have an image. Let's hold on.
Trying to understand the.
I am also trying to explain to you the same thing, correct? Let's take an image. The image is basically like, you know, in the, I need to classify the image. The image is basically a male and female image, a set of male and female image. That is one thing. It's a live image. The second point, I have a data like this, which is not an image, which basically describes how the image is looking, correct? So now I have this data. Under this condition, what model to use, correct? What model to use? Let's go that approach. Instead of making a statement, supervised deep learning with lack of clarity, I have a problem. Problem is, I want to classify whether this image is a male or female. How does that image data is given? Is it given in this form, okay? In a table form where it describes, and I do have a label. Or it is not given the table form, it is given the image, but it also has a label for that, okay? So the label classifies, this image is male, this image is a female, correct? In this condition, which model to use? Can I use a supervised machine learning model? Can I use unsupervised machine learning model? That's what the arguments that we can explore, okay? So,
so for this table, we can, so since we have the label data, we are doing supervised learning.
Excellent, yes, answer is yes, that's what I'm going to teach.
We can even do deep learning on the same data as well.
The answer is yes. I can do deep learning as well. Correct? I can do deep learning.
The question is not about supervised learning versus deep learning. It's that we can do supervised learning using deep learning or using other statistical models as well.
Okay.
Am I right?
So, I don't think you're right. As I said, this is lacking some conceptual clarity. So that's why we are coming into this one. The architecture of deep learning is completely different. The architecture of supervised machine learning is completely different, correct? So we cannot interconnect these two. As I said, a deep learning model.
So what is the architecture of supervised learning that you're talking about?
Okay, the architecture of supervised machine learning, there are two key elements. The supervised machine learning must have to have a goal to achieve. Second, there is a target variable. And third, the training data has to have a label. Correct? The training data has to have a label, correct? So the supervised machine learning does not have an input layer, hidden layer, output layer, weight, bias, sigmoid function, etc. So that it's not required. If you are going on a deep learning, you must have to specify all of those. You must have to explicitly tell how many number of hidden layers, how many number of input layers, etc., etc. You have to specify this one. If you are going on a deep learning approach, you don't have to specify any of those things. All you just need is labels and target variable. That's it, goal to achieve. Okay, so if you need further discussion, I would encourage call me, we'll talk more. I don't want to spend time on this one, so I have to cover many other topics. Let's move on. So I would simply say you are lacking conceptual clarity. I would encourage you to understand the concept, then it will make more valuable discussion. Before you go anything further, define what problem you are solving. That's fundamentally most important. Okay, this is a problem I'm solving. In this, what model to use and which model would be a best model. Okay, so that makes more sense. So let's move
I
on.
don't think I'm lacking conceptual clarity here anyways, but okay, we will take it offline.
Yes, so call me, we can talk about it and then discuss further, okay? That's not an issue. Let's move on. So let's understand what is a machine learning means, correct? As I said, the word machine learning means nothing, okay? Please don't get confused. And this is what I've been telling. So whether people from any top schools or any industry, the word, they may say different things in real practical problem solving skills, correct? As I said, so this is my current project, correct? It's a massive scale, okay? At a massive scale. So when you will look at here, correct? So we are building something called, in AWS SageMaker, something called future state. So the future state is basically, it doesn't matter what model I'm going to build, I'm going to define a future state for across my business. Okay, and these are the features I'm going to use in a centralized place. Then use when I implement model. Okay, so point is, concept is different. Applying this in a real world is completely different. Okay, completely different. Conceptual clarity is most important. If we don't understand, we wouldn't know how to apply all these things. Here, if you notice, in a centralized place, the place that what I call future state, I define, take the data sets and define these features. Okay, it's a very simple supervised machine learning. Then I apply this here, correct? So how this works in a real world, it's most important to understand. From that perspective, getting more deeper knowledge on how this works is important, and that's what I would like to achieve here. Okay, so you can take in such a way, right? So what such a way means, let's take an example. When you go to class, what happens? The teacher teaches you. What happens? You gain skills. What happens? You become a human intelligence. Now you take the human out. I want to train a machine in the same way. So you teach the machine. How do we teach the machine? We'll get to that point. And how the machine is gaining the skills and knowledge, we'll get to that point. But ultimate goal is what? So it's become a human, it's become a machine intelligence instead of a human intelligence, correct? Instead of a human intelligence. This is the point I wanted to make you understand, correct? So when you go to school, you become a doctor, you become a scientist, you become an engineer, you become XYZ, whatever you want, correct? That is what I want to achieve. That is what I want to teach the machine, correct? So make sure you understand, you are teaching machine to become, the machine become a scientist, the machine become an engineer, the machine become an architect, the machine become like, a lawyer, an accountant, a doctor, correct? That's the goal. Okay, that is the goal. So that is why we want to ultimately create alternate substitute for a human intelligence. Okay, create alternate substitute for human intelligence, correct? So either it could be an alternate intelligence to the human, or a substitute to the human, or it could be in a complete replacement. So you could imagine the best way to understand teaching machine. You go to school, you study, you become a doctor. You teach the machine, make the machine to learn, and once the machine is learned, it could become a doctor, it could become a scientist, it could become an accountant, it could become anything. Okay, so in summary, the goal is to make the machine to learn and become alternate substitute, replace for a human intelligence. And that is what we want to understand. How do we learn when we go to school? Very simple. You have a textbook, you have a learning material. It could be a lab work, it could be video, audio, etc. You learn from there. It could be formal, it could be informal. So all those things we talk. But machine is not going to learn that way. The only way the machine is going to learn, data. The only way machine is going to learn, it's data. So what kind of data? And this is where the other skills which is coming together, it's big data, IoT, right? So most cases that I am involved in industry projects, you will deal with big data, you will deal IoTs, okay? Whether it's an industrial Internet of Things or an Internet of Things, it depends on what project you are involved. In most cases, I'm involved in an industrial Internet of Things, okay? So point is, how the machine is learning, it's learning based on the data sets, okay? It is important. So not having enough data, like understanding about data and working with the data, if you don't have that skills, this is meaningless, okay? It is again become an abstract terms, correct? Like academic professors who can come and teach these things, correct? Because academic people don't go deeper into all these areas, correct? They will just talk concept and let you figure out the rest of the things, correct? So that will not happen here. So coming back, how the machine is learning, in what form the machine is learning, it learns from the data. It learns from the data. So that means there are two other key skills also you need to understand, which is big data, IoT, based on my experience. All right. So I'm going to skip all these things. This is not really important at this point. Just one slide to cover. Okay. Again, I'm not saying this is the industry standard. This is based on my experience. Okay. This is based on my experience, how the machine is learning. As I told to the other gentleman, always start from a problem statement. Okay. Do not go and select a model, whether this model is best fit, that model is best fit, will not work. Go logical approach. The logical approach is first define what problem you're solving, which is fundamentally most important. Okay. If I don't understand what the problem I'm solving, then I won't be able to select the model that what I want to implement. Okay. So whether it could be a simple supervised machine learning, or it could be a deep learning, such as neural net or artificial neural net or a recurring neural net or CNN, etc. It could be any of those models. Who cares? The first step is define the problem. Defining problem comes industry knowledge. No matter how good you are, what you've done, okay, irrelevant. Irrelevant. You may be a superstar in dealing with the deep learning, but if you don't understand the problem, your model selection, feature selection, and making the model learn, it's going to be so difficult. You will see that. You will see that, correct? So the number one problem, implementing machine learning model or learning a machine learning model, start with defining a problem statement. What is the problem I'm going to solve? That is most important. Understanding that comes only from industry knowledge. Why? That is the driving factor for rest of everything. Based on the problem and the problem type. Okay, I'm sure you heard about classification problem, regression problem, clustering problem, association problem, etc. So those are all problem type. Based on that, you select model. For the given problem type, what would be the machine learning model that I want to implement? Okay, you will see that in action. Once that is done, collect the data. What kind of data I need to train the model? I need to collect the data. So that is, again, it's coming back from the business knowledge. Keep in mind, building use case is different. Going out and working in a real project and solving real problems, it needs deeper skills, correct? It needs deeper skills. So what happens most cases when you bring people call themselves a data scientist, when people call themselves as like, I'm a guru in AI, they don't have any knowledge on these things. Okay, any knowledge on these things. They have any knowledge on these things. They may know some knowledge about this one based on their academic background, but this needs industry deeper knowledge. So this will drive all the way to number 3. The rest all technical details, correct? So now the next step is teach the machine. When you teach the machine is learning. How the machine is learning, correct? And what the machine is producing, it creates an algorithm. And what we call that algorithm, it's a learning algorithm. Once it's created, correct? So then I'm going to do a test of the machine. How well the machine is performing based on what you learned. Yes, it performs, it meets my expectation. That's a very fine outcome. I'm checking the machine outcome. Yes, it performs what I'm expecting. How do we know, correct? So I have a desired outcome. So that's basically what I expect the machine to do. Yes, it's meeting. If it is meeting, then definitely I am agreeing. I'll go for the deploying model into the production. Then I continue to build based on how the model is structured. I can do retrain, retest, redeploy. This process evolves. Okay. So take an example. I want to teach the students simple mathematics. In mathematics, I want to teach arithmetic operation. That is my problem statement. I want to teach the students arithmetic operations. I want to teach students arithmetic operation. All right. So the second is model selection. Okay? So the problem could be, okay, I'm just giving you a hypothetical example, so don't compare with what I'm saying. I wanted to make you understand how the steps involve. So I want to teach mathematics. I want to teach arithmetic operation. I'm collecting the textbook, assignment, quizzes, everything that is involved. So now I'm teaching the students 2 + 2 = 4, 4 + 4 = 8, 8 + 6 = 16. The student understood. They built their knowledge. That knowledge is invisible. That's sitting in their minds. That's sitting in their mind. That's invisible. I cannot see this knowledge. So now the student understood. The next day I'm conducting tests. So what I thought, 2 + 2, 4 + 4, 8 + 6, 16 + 16, done. Now I'm not going to give the same question. I'm giving a different question. I'm giving 3 + 3. I'm giving 6 + 6. I'm giving 9 + 9, etc. So this time, what I thought, it makes the students to understand. So did I get the desired outcome from the student? Yes, I get. Then I go down. No, I did not. In that case, I'm going to look at, is problem in my data? That means the material that what I gave the student to learn, is that right? Is that wrong? Oh my God, I'm supposed to give a material for the student to learn about arithmetic operation, but I gave a material to learn about multiplication and subtraction. So this material is wrong. I have to fix it. Correct? So I go back and check the data. If it is right, then continue this one. Yes, my material is right, but still the students are not learning. Maybe my teaching is the problem. The way I teach is problem. I will try to fine tune my teaching. That's basically what we call hyperparameter tuning. You tune the model will become more efficient. So you continue this process until you reach your desired outcome. Once you reach the desired outcome, then you go for the deployment. So the point is, the best way to understand, if you already know basics, that's fine. If it is not, you could imagine you are a teacher. You could imagine you are a teacher, either for you are teaching your son or a daughter or whoever you are teaching. What are you teaching? Mathematics. In mathematics, what am I teaching? Simple arithmetic operation. What my first steps? I'm going to collect some material. You cannot just sit down and do this one, okay? Either if you're doing on a whiteboard or on a paper and a pencil, you have to collect some material. So collect some data points. This is what I'm going to teach. I'm teaching my son or a daughter or my students. They are learning. The learning is invisible. How do you know whether they learned or not? Conduct a test. Okay, so the test is based on what you thought. Okay, so here I thought 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16. Done deal. So the test is going to be based on 3 plus 3, 6 plus 6, 9 plus 9, etc. So it's completely different, correct? So that is how I'm testing whether my son or daughters learned. Yes, they learned. I have the desired outcome. My desired outcome and acceptance is 99.9. I met this one. Then I'm going further down. So I'm done with arithmetic operation. I'm taking different data sets. I'm going to train this one. I'm going to continue this process. So similarly, you could teach the machine. Okay, so this is what we want to learn. Taking a simple supervised machine learning and understand that how it works. And then how do you change this one? As I said, in this cyclic process, there could be problem in the data. We need to fix this. There could be problem in the way that like what we are teaching, like giving some parameters, hyperparameters to tune and understand. So we need to find out what it is and how to tune it. Correct? And there could be some problem in the model selection itself. Correct? Like what we selected as a model, that could be a problem. Correct? So basically, there's a logical way to learn. Correct? So without knowing arithmetic operation, if I jump on solving some quadratic equation, the student may not be able to understand. So my model selection itself wrong, what I'm trying to teach, correct? So that could be wrong. So point is, all the things matters, correct? So this is what we want to learn and understand in a lab so that you can connect all the dots, get your hands dirty, correct? So this is just a simple example, what I want you to understand, okay? In a layman term, why the industry needs machine learning and what it does for your business, correct? So ask yourself in a layman term, correct? So don't go like, it does this, it does this. Just simply ask this question, correct? So you understand, So number one, it modernizes the software engineering, correct? So it doesn't matter what people thought. The real need at this point, reinvent the software engineering. What software engineering we are using right now, correct? It is absolutely hard-coded rules, okay? Absolute hard-coded rules. I don't want to do the hard-coded rules. There must be some better way to do that one. So that is basically modernized software engineering or reinvent business application development and maintenance. This is the driving factor. Ladies and gentlemen, understand. Rest all abstract concept, please ignore. That has nothing to do with all the things what we're learning. When you go on a real world, correct? When you go on a real world, correct? The expectation is, how do you rebuild the software engineering? Right? That is what they need. Okay. So if you look at Google, if you look at Facebook, if you look at any company, what they're looking for software engineers who can use like machine learning to build software, who can use artificial intelligence to create like business application. That's all they need looking for. Correct? Okay, so going deeper into mathematics, going deeper into statistics, understanding this is needed, but it is not the top skill that what industry is looking for. As I said, correct? So the project that right now I'm in, it's a global air industry, correct? They operate worldwide. What they ask us to do, or what they ask me to do, two things. Do a forecast on booking and revenue. Due to COVID, it is unpredictable. I don't know whether I want to operate this flight. There are situations. The flight was traveling from Singapore to San Francisco for 4 people. Can you believe? And an aircraft flying for 14.5 hours just for 4 people. You could imagine why. It's a legal requirement. You cannot cancel the last minutes. Correct? If they would have known, they would have canceled this one. They would have done something. They want us to forecast. They want to do this one. Correct? It's a time series analysis. In that complex landscape, correct? In that complex landscape, all we are doing, we are re-implementing the forecasting process using machine learning. Okay, that is basically modernizing the software engineering, reinventing the business application. That is the need. Okay, rest, as I said, you can talk many things. Like so they said this, they told this, all good, nice to hear, but the real need is different than what industries like. So what the concepts, the things are happening and around. Okay, so in a layman term, why do we need machine learning? What it does for business, 2 things. It modernizes the software engineering, reinvents the business application development, okay? And that's basically how I see this one. Okay, so let's do a deep dive session. Let's cover some ground later. Okay, so what does this mean? I want to take it to the lab. So for this, I want to introduce the Google Colabs. If anybody want to practice, learn, you can. Okay, you can. So now what we wanted to understand, as I said, there are some concepts we learned. Now we want to apply these concepts in the real world. So for this, I'm taking the same example, what we just discussed. Let's take a basic example. I want to classify, okay? I want to classify whether the given image is male or female. This is not the only problem. It could be any problem, a problem, it doesn't matter. Once we understand the foundation, once we understand how this works, you can tackle any problem. You don't have to be this kind of problem. Okay, so going back, what is our first thing when we do machine learning? Understand the problem statements. Understand the problem statements. So what is the problem that we are trying to solve? The problem that what we are trying to solve. Understand whether the given image, okay, the data, how it is being given, it could be an actual image, or it could be a data set like this, which describes the image. Okay, here I don't have an actual image. So what I'm talking about when I say actual image, okay, so you could Google. So for example, okay, so when you go to Google, you can type male image, okay, so you will get to see. So this is the actual image, correct? So I'm talking about these images, okay? I don't know who these people are, I'm just saying. So these are all actual male images, okay? So this is the actual image. Either I could use this as a data. Okay, this is the actual image. I expect the machine to understand which is male, which is female, which is like, you know, unknown, correct? So I expect the machine to, this is one type of problem we could solve. In my case, I'm not going that approach since that is little harder to implement, difficult to follow. Something very simple, easy to understand. So what I did, there are 3 features I'm taking. Okay, so what is feature? I will explain. So these features basically describes this is male, height is this, weight is this, color is this, that appears to be a male. This is the data I have. So in this, what I have basically like, you know, the training data. So the other point I wanted to say, okay, this terms what your training data could be represented in different forms. Okay, the training data has the features. Sometimes people also call source data. Sometimes people also have an input data. Okay, so this is basically all in terms of what it represents. Okay, when I get to this point, I'll explain what is this X train, Y train. You might have seen some, like, you know, some demos and stuff. So I'll explain this one. So point is, the training data has features. People also say it's a source data. People also say it's training data. People also say input data. The labels basically, what is basically the target? Okay, what is the target? The target in this case, the people represent this as a labels. So I want to predict whether it's a male or female. Then this could be a combination of test data and output, etc. So I'm just trying to say there is a misleading label. This diagram doesn't have more clarity. I will explain this later. But all I wanted to make sure you understand, when we say training data, sometimes people also call source. People also call input. Okay, so this training data has 2 things, features and labels. Understand what is features? This is features. And this is labels. Okay, this is the training data. What is features? What is labels? Let's understand. Right? So the features basically, if these are all there, then it is female. If height is this, weight is this, color is this, then it's female. If height is this, weight is this, color is this, then it's a male. I'm just telling the machine to learn these things. All right. What I will do, the next thing, I'm not going to give the labels. This is what I expect the machine to do. It is a very simple, basic machine learning, which falls under supervised machine learning. So here I'm trying to classify whether the classification is classifying male or female, because it has 2 values, binary, 0 or 1. So it's a binary classification. It is a binary classification. So this is the problem I want to solve. What I'm saying, I will teach you. Once you learn, I will give you. You tell me what is the desired outcome. So I expect the machine to give the desired outcome. So the desired outcome is what the label the machine is going to predict. So this is the target. This is the target. So this is what we want the machine Same thing what I told, I teach you. What I teach you, I will tell you. So I'm going to say my son or daughter, 2 plus 2. So they will say 4. Got it. Okay. So I will say 4 plus 4. They will say, okay, 8. Got it. Okay. So this is 8. They got it. So basically, I'm telling them this is how it works. Right? So this is how I'm teaching them. So now I'm going to give. All right. You learn these things. Now you tell me what is 3 plus 3. Okay. Tell me this one. What is 6 plus 6? Tell me this one. What is 12 plus 12? So I ask them to predict the desired outcome. So this is what I expect them to predict. So I teach them and then I train, I ask them to do this exercise. Correct? So this is basically what we want to achieve here. So we want to teach the machine this things. Once the machine learned and understood, then the next step, basically what I want to do, I want the machine predict the last column, in this case, the label, the target, which is not given. So this is my training data, which has the label. This is my test data, which doesn't have the label. How do I build this one? Okay, to build this one, I need a classifier, correct? So to build this one, I need a classifier. So what the classifier that's going to supposed to do, 1 second. So here, it's like, you could imagine it like a function, okay? The classifier, which I have to build, okay? So how do we train the machine? I'm going to walk you through everything so you can understand, right? So it's like a function you could imagine, a predefined function which takes the features, which give you the labels, correct? It takes the features as an input and gives the label as an output. So when I say def, it's a Python syntax, we'll come to the point. So in a logical way, what you have to understand, when I say, how do I teach the machine? I need a classifier, okay? Where the classifier is nothing but a predefined function, or you could call technically a model to be implemented. Okay, a model to be, machine learning model to be implemented. In this one, I'm going to give the features. I expect the labels, correct? So what I'm going to do, I'm going to give these features, and I expect the label, the last column. So that is what I'm going to do right now, correct? So summarize. So the problem what we are trying to solve, we are going to give a set of data, which is basically a training data. In the training data, I have features and labels. So features and labels are nothing but the features in this case. So height, weight, color. The label is gender. Okay, the label is gender. So this is what the machine will learn. And I expect machine to predict this one. I expect machine to use this data to predict the labels, correct? So that is the concept I'm trying to implement. In order to implement, I need a model. I need a classifier. What is a model and classifier? For all practical purpose, learning purpose, you could imagine it is a function. It is a predefined function. So this predefined, you can also write your own function. Don't think that you have to only use the predefined function. That's a good starting point. That is the best place to get started. That's the best place to learn these things, correct? So it's a predefined function. It comes from a particular library or a machine learning framework. It comes there. So you take the function and implement this one. What this function does, it takes feature as an input, gives the labels an output, and then it has a set of rules. Okay. So height is this, weight is this, then that's a rule number 1. Then it's a male. Height is this, weight is this, color is this, then it's a female. Height is this, weight is this, then color is this well. So etc. So when you give the features such as height, weight, color, it applies the rules and gives you back the label, which is a gender. The label is the gender, correct? So I'm going to give height, weight, color, then I expect the gender. So that is basically what is necessary, right? All right. So again, there is more into it. I will cover after this one. So I'm just trying to connect all the dots, correct? So point 1 to understand, I could have used these images as a data. Okay, I did not use this actual images. Instead, I am using a table-based data, a table which describes how a male image is looking, how a female image is looking. This is simple sample data. Do not take this as a real data. It is not at all. And again, it is primarily for learning purpose, not what I am working in projects, correct? What I work in projects is completely different. Okay, what I work in projects is completely different. Let's understand this one. So in order to implement this one, so we are going to use Google Colabs. Okay, we are going to use Google Colabs. Let's just take quickly covers. We are going to stop in 5 minutes for lunch. Okay, so I'm sure some of you, most of you may have heard, in case if you have not. So understand Google Colabs, just type colab.research.google.com. You will get to this one. It's the best collaborative development platform. when I say best collaborative development platform, there could be many things. You could install Anaconda, Jupyter Notebook, do all kind of things, no question, right? So this is the best place to get started. If your goal, like I said, want to be a hands-on expert, if you want to do some kind of like a learning by using this type of an approach, okay, what is the best way to get started? Actually, to build very basic, simple machine learning model, understand the concepts. Those concepts is really important. So the best place to start is Colabs. Okay, type the URL. It is asking, do you want to work with an existing Colab notebooks, which is you most recently worked, or do you want to start something from the scratch? Click on new notebook. Okay, so I'm just going to click new notebook. It's going to take me to any notebook actually. Okay, so this is basically free. You don't have to pay anything. Okay, so where you are right now, you are in notebooks. Okay, even if you want to go to Google Cloud or Amazon Cloud, you see notebook services. Okay, in both the cases, you see a notebook services. Okay, so for example, you can see the option connect. Okay, on the right hand side, the first thing what you do once you launch this one. So if you want to give a title, you can see it, give a title. So this is basically Jupyter Notebook. I'm going to give so a event. Okay, a event demo. So you can give anything. I'm just going to put some date 12, 18, 20, 21. Okay, so that's fine. So that's the name. So the next thing what you need to do, click on connect. Understand this first. What it says, hosted runtime. The runtime right now given by Google, it's already hosted, it's on the cloud. That is what it means. This is if you want to connect to a notebook services, which is running in GCE platform. Okay, VM instance. So this is a cloud instance you can connect. And this is a local instance you can connect. Okay, understand these three. The first one, default hosted instance. That means it's a cloud solution. Second, it's already hosted. I have a Google Cloud account. Okay, I have a Google Cloud account. I want to connect to that instance notebook. Okay, it's a VM I have. I want to connect this one, and I have a local. I can connect. You can do the research later. For us right now, understand. Click on host and runtime. Now you see it connecting and allocating resources. What resources it allocates? RAM, random access memory, disk storage. Right? How much disk is being given to you? Okay, so this instance, okay, you can also connect to cloud. You see, it is asking in Google Cloud what project you have, what zone of the resource you have, correct? What instance you have. So we don't have to go that far. If we want to advance your learning, then you can go. And this is where we work right now. So this is our platforms built on these things, correct? So if you want to work on these things, you can go. So let's say you have Jupyter Notebook, Anaconda installed local, you can select local instance. You can select a local instance, we don't need to go. So the best way to get started, go with the hosted runtime. So that will give you a allocation of resources just for instance. Once this instance is done, when you close, this will reallocate it back to somebody else. Okay, so point one, when you select, make sure actually you give some meaningful name for this. Point two, connect and ensure the resources are allocated. There are many other options, correct? So for example, if you want to go and set up a few things, you can do this too. So you can go to tools and settings. Here you have option to set up, correct? So how do you want the editor to be looked at? Okay, in terms of font size and etc. I'm sure if you're a software engineer, you can figure this out, correct? So then you can see Colab Pro, it's a paid instance. If you want to use GPUs and extra, you could use that. And if you want to connect to GitHub, okay, which is basically a repository where you can get data, where you have a source code already saved. If you want to pull them into here, you can do that as well. And there are other things you could configure, correct? Like if you want to create some kind of goodie mode, these are all just fun things for you to do. So I would encourage to play around. You will get to know all the different things, correct? So this is basically settings. So you can go to tools and settings, or I can see on the right hand side, you can click on settings, correct? So you can click on settings. So I told one point, you can share this one. So whatever file I selected, if I want to share this one, I can click on share. So this will allow, okay, this file to be shared to many different users. Okay, so for example, I want to send this to Durga Prasad. I can select his name. I can send this one. When I send, I can select as a viewer, commenter, editor. Correct? So different options. You see this one. I can send a message. It will send a notification. So that means he or she can able to access this one. You can copy the link, do this one. Correct? So these are all different options which comes along with the Colab notebooks. Correct? So point what I'm trying to make you understand. If you wanted to share your Colab Colab notebook, let's say you ran into problem. Okay, you are not able to troubleshoot. You are not able to troubleshoot. So if you want to basically like somebody else look at this one, you can do share. You can do share. You can do share. So this will allow you to share your Colab notebook to somebody else so that they can look at it, correct? They can look at it. So when you click this one, so you ensure you type the username and password. So this is the username. Once you select the username, it will ask you, what do you want to share? Do you want to share in the viewer mode or a commenter or editor? Edit means they can make change to the code. Okay, then click on send, it will send them. Okay, click on send, it will send them. So they will notify through email that this notebook has been shared. Okay, notebook has been shared. So other point to consider, let's say you have data sitting in Google Drive. So that is the reason this becomes so valuable. You see right click here actually, like, so click files. When you click files, you see you could upload files either from the local drive, like, so I have files sitting in my local, I can do it from here. It allows you to bring the file. Or if the file is sitting in Google Drive, okay, so for example, the file is in Google Drive, click on Mount Drive. When you click Mount Drive, it will ask you this message, connect to Google Drive, say yes. Okay, so connect the Google Drive, say yes. Okay, so this will automatically mount your Google Drive. Sometimes it will ask you a piece of code to be written. Depends on what version it is. Like now, so you could see this one, it is mounted. You see this one, refresh, click refresh. When you click refresh, this is basically like, allow you to get the drive mounted here. When you expand, so this is my drive, this is my G drive, so this is my Google Drive. So whatever you have in Google Drive, you can bring them. So this is for how do you bring the data into the drive. So this is basically all the files that in my drive, it's coming here. Okay, so this is coming here. So point is, in case if you wanted to bring your Google Drive files into Colab notebooks, you could do that too. If you have files sitting in local, you could do that too. Okay, so this is basically like a unmount. If you don't want this one, you can unmount this one. Same, it revoke this access, it's done deal, correct? So when you go back to file, so when you go back to file, this is the file. So now you see it is not mounted anymore. You can refresh, you can see it's a sample data that's given by Google. So there are some sample CSV file that's there given for you to work around. That's what this is, correct? So I would strongly encourage to okay, play around. Okay, it is not you will learn everything overnight. Just play around, okay? Just play around. So this is the best place to get started your learning. Okay, if your goal is to become a hands-on data scientist or an engineer, model engineer, or an automation engineer, whatever the way you want to promote yourself, if this is what the goal you have, then I would strongly recommend best place to get started. Okay, best place to get started, play around. So there are two things you see on the top, code and text. Code is for where you could write code. Text is for documentation, right? So if you want to create any documentation, you could add. So this is basically tells a documentation you see. So this has a different styles, right? So this has basically tells, this is, I can put, so it is not executable. So this is a sample document. Okay, this is a sample doc. So this is not an executable code. This is basically a sample documentation. You won't be able to execute this one. So for example, so here I can say print. Okay, so okay, so this is a Python code that I'm trying to say this one actually. So when I run this one, it tells me what it is. Here I won't be able to run. So you can run this one by pressing Control Enter. Okay, so it runs. Here I won't be able to enter anything because it's a text, it's not a code. Okay, on the top you see there are two things you can do in a Colab. You can create a document. That means if you want someone to share their interest, if they want to send you some documentation, some notes, they can type here. Okay, hey, I look at the program, I found some issues, do this one. Okay, or if you ask them to run the program and see what the outcomes, they can see. You see this one, it's a run cell or all cells. So you can see runtime. You can set the runtime as well actually. So you can run all, run default, run etc. You can just play around, understand this one. So one thing you can also understand so you can see this one actually. There's the you can insert different codes and the text and etc. Okay, so you can play around this one too. So all these are all different options you can understand by looking at this one. Actually, guys, by looking at this one, you can understand this. So anything around this one, I would encourage you to strongly practice. Okay, strongly practice. You will get to know more of this one. Okay, you will get to know more of these things. Okay. All right. So I would suggest we will take a break for a lunch break, and we'll come back and continue this exercise, and then we will go back to other topics that what we wanted to cover for the day. I'm going to stop here and see if there's any questions that I could answer. So what we are trying to understand, how the machine is learning, right? How the machine is learning. There are steps we need to follow. That is a step we are going to do right now. All right, that we are going to do in the lab. And what we concluded in a layman term, why we need machine learning, what it does for business. Two things. It reinvents the software. How we have been building software, that it fundamentally reinvents. Okay, as I said, many things people can talk. Where does it coming down to? It's coming down to the software engineering, whether it's SAP configuration or writing above code or writing C program, writing C++ program, whatever Java code, whatever you write, that software engineering fundamentally changes. Why? We do hard-coded rules, which is not required anymore. We want to use different approach. And that approach reinvents business application development and maintenance. How we maintain, how do we develop business application, okay? So these are the two things it does, okay? All right, so I will just iterate one more point so that you could understand, right? So there are two aspects what we looked at. How the machine is learned, what the machine is learning, right? So there are two aspects what we just, how the machine is learning, either a simple statistical based learning approach or a deeper neuron based learning approach. Why? The underlying architecture, each one of them is different. So as we talked about, many different people, many different ways to represent. In a real world, internally how it works, the underlying architecture, that's what I go with. Rest for me, meaningless, I don't care. Okay, rest for me, meaningless. The underlying architecture for each of this type of learning is different. Okay, each of the type of learning is different. As I explained, under deep learning, the architectures are different. Under supervised, the architectures are different. Right? So that dictates how the machine is going to learn, what it's going to learn. In terms of what application, what we can teach the machine, either you can teach the machine to learn the vision, you can teach the machine to learn the process or a language. Why? We as a human, that's what we do. Okay, so we as a human, that's what we do. Whether we look at something, take an action, speak something, read something, write something, take an action, solve problems, do something, or we do something as a process. Right? So vision, language, process, that is what we as a human. Now, how do we teach the same thing for a machine? So this is where computer vision, natural language processing, robotic process automation comes into picture. Okay, how to teach the machine, train the machine. Okay, how to make the machine to learn, teach the machine. How to teach the machine, train the machine. How to train the machine, follow the machine learning technique and choose the application. Okay, choose the application. So this is basically how the machine is learning being looked at, right? How the machine is learning looked at. So take a problem, select the model, collect the data, train, test, verify. If everything goes well, deploy. If it is not, reiterate the process, repeat the process until you accept the model outcome to be done. All right. So this is what we want to implement with a simple example so that we can understand. So with that said, I'm going to stop and take, if we have any questions for 2 minutes, then we'll take a break at that point. Any questions?
Yeah, great, Jyotiji. So far, there is a tremendous positive response from attendees. I was checking on. Okay. And definitely, I think we have questions too. I think Surendra, go ahead.
Sure. Again, one more point. I may be wrong. I may be right. What I speak, what I do here, what problem I'm solving. Correct. I'm not an abstract guy. Correct. I'm not an abstract. I never live with the concept. I hate concepts. Correct. Like I do wanted to understand, but what I speak, what I do, it's practically how things works in my world, what I'm doing. Correct. So you may not connect sometimes what I'm teaching with what you heard from YouTube or what you heard from somebody else. That's their view. My view, solve practical problem. To solve practical problem, this is what we need. I go deeper on the technical aspects, how really things works, not really abstract steps. Okay. All right. I may be wrong. I may be right, but that's how it is. Please go ahead.
Yeah, definitely. That's a great way to put in. Yeah, go ahead, Surendra. Hello. You cannot unmute.
Yes, I was not able to unmute. Now I was able to unmute Ramji. And Jyotiji, I have one question. And
Yes,
you
sir.
mentioned data comes from the big data or IoT, but in here we are taking Excel. Is there any reason, or in the real world also we are taking Excel only, or
No,
what
no,
is?
no, no. So real world, you don't take Excel at all, correct? Like, as I told you, so if you look at the example that I gave you, correct? So the one project that currently we are involved doing in a forecasting, so that data comes from a real world example of cloud infrastructure, correct? So how does the data comes? It comes from BigQuery and the cloud storage. From there, it goes to S3 bucket, Redshift and all. So this is a completely different approach. I don't have that infrastructure to show you, run you that demo. So that's going to cost me money, correct? So when I use a cloud resource, it's going to cost money. So the reason I took this Excel spreadsheet, number one, easy to learn. Number one, I don't have to pay anything. So number two, it's the much faster, easiest way to understand working with this kind of infrastructure. So in the real world, absolutely no Excel spreadsheet. There are Excel spreadsheet, but you don't take that to the model. Okay, either it's going to come from a cloud storage or it's going to come from a different storage, right? So in terms of framework.
Okay, got it. But in the whatever in the 2 days demo, are we going to talk about that one also?
I can talk. I really don't, like I said, any cloud resources that I'm going to use to build model, train model, and things like that, it's going to cost some money, right? Okay. So I can share how it looks and open and show you. But in terms of running models and doing things on a cloud infrastructure, I don't have one. I wouldn't be able to do it.
Okay, not a problem. Yeah, maybe you can show it. Thank you very much.
Yes, I can definitely try to show you.
Thank you. Thank you.
Hi, Jyotiji. This is Bhupinder.
Yes, sir.
Three things, like whenever you ask a question, we are unable to mute ourselves. So if possible, can you see your chat? In that chat, we can respond. Second thing is, while call lab, can you share the call lab so that we don't have to type to speed up the process? Because in one day we have to do everything. And third thing is like, what I understand so far is like AI is still in a limited box. Is it right? Like, it cannot go beyond the boundaries, whatever we set. Like, let's say AI cannot go for the serendipity or invent itself, invent new thing which human can do but AI cannot do. Is it true?
Answer is no, correct? It is basically can do. Where is the limitation? Where is the challenges? It's going to come down to the actual data, what needs to be trained, number one. Number two, the technical landscape, how this is going to take place. Let's say you and I want to build a self-driving car, correct? To build a self-driving car, I need a learning environment. What is the learning environment which simulates a road condition? Do you think we can do that? It is impossible. Why? It costs a lot of money. It costs a lot of money, correct? So point is, the implementation of artificial intelligence, it's coming down to data and the actual landscape on which how this is going to take place, correct? So that is basically requires an investment cost and building that out. So that is where we are lacking. That is where we have challenges. If that is freely available, sky is the limit. Sky is the limit. Anybody can do anything. Okay, anybody can do anything. Like Bhupender, let me ask you this one. Let me say I have data coming in the form of image, video, voice, and text. I'll give you 3 months. Can you integrate these three together? I have data coming in the form of image, voice, text, video, as well as a semi-structured form. Okay. So I'll give you 3 months time. Can you integrate this data? This is needed for sentiment analysis, how a customer feels about the product and service that what I sell. Okay. A customer goes to YouTube, they take the picture of the picture and then post it there and write bad reviews. The customer record a video and put it on YouTube. Don't buy this product. It's a very bad product. They're cheating. The customer records the voice and put it on a YouTube and saying this is a bad product, correct? So the customer writes a bad review. They sends an email. So now you take all, analyze and come back and tell what is the sentiment written in this product, correct? About the product. I'll give you 3 months time. Just integrate these three. Is it possible, Bhupender?
No.
Why?
No.
Why?
Yeah, I don't know the answer, but
that is the answer. That is the answer to your first question. That is the answer to your first question. Right? Okay. It is coming down to that level. How many? See, talking is different. Having a guts to deal this kind of problem is different. Correct? You need guts to touch this kind of problem. I think that's where the issue. It is coming down to skill issues, not an AI issue. Correct? It is a skill issue. How many people have a guts to deal these kind of data sets? I think that's the real issue. Because we don't have a skill to deal that kind of data, and we won't be able to train the model. We won't be able to get what we want, right? So going back to answer your question, it's a skill issue, not a model issue.
Understood. Thank you. Thank you, Jyotiji, very much.
Yeah, I think we have another question before we take a break. Hari Karangula. Okay, please go ahead and unmute. Yes, sir.
Yes, Hari, go ahead.
One question. So coming to the real world problems like the global climate change. So how far AI is equipped in meeting this huge challenge that the world is facing and the coming generations that is going to face? So is there any predictive analysis already being provided somewhere to the governments and all those things? If you could throw some light on that.
So if you are talking about something like COVID pandemic situations, correct? If that is the global issues or challenges that you are trying to address, or if that's what you're trying to answer. So there are two ways to look at it. Can AI solve this kind of problem? Answer is yes. Do we have a pre-built ready-made solution which can solve this one? Example. So let's say the COVID is spreading around. We want to run a predictive model which predicts which location is going to have huge impact in the next 3 months, 9 months, 6 months. Okay. Some extent, there are models people build, they're able to do it. But what level that is working, what level of depth it goes, I don't know answer to that question. Correct? So I'm going to repeat the same thing. Do we have capability to build such solution on a global scale? Correct? For example, like, in India, we had like few months back, it's very massive impact, correct? So if you would have known in advance, you would have proactively done. Politics is different. I'm not talking about the politics, correct? So politics could be different, correct? If you would have known this one, this is how it's going to be. There's supply, oxygen supply demand, correct? There's no enough oxygen supply demand. So because India is producing all oxygens, correct? They're exporting oxygens. If they known, they could have stocked, they could have saved, they could have done something, correct? So can I know these kind of global problems in advance and predict and run this one? Answer is yes. Can AI do this one? Yes. So for that, do we have an infrastructure? Do we have data to be trained and built? That could be challenging. That I don't know at this point whether we have that scale, correct? So there are two ways to look at it. Do we have artificial intelligence capability in the artificial intelligence side to solve such global problem? Answer is yes. Do we have a landscape, technical landscape, data infrastructure where we can skill expertise, correct? Where we can solve this kind of massive problem? That I'm not convinced. I don't think so.
That's great. I think we got one more question. Do you want to take it now or after the break?
Yeah, we will take one question and we'll stop that point.
Okay, so Lucky Dev, can you go ahead and unmute?
Okay, hello sir, my name is Dave.
Hi Dave, your voice is echoing.
I hope you remember me. We had a telephone call a few months ago. I had a quick question about your programming course. I remember you mentioned that this course was only accessible for students through
universities and colleges, schools. Yes.
Yes, from 6th to 12th.
Yes.
But I am homeschooled and studying my 3rd grade, and I am also doing my associate degree in a community college. So how can kids like me access this programming course, and what are the options?
Okay, so two things. What I'm teaching, it's not a course. It's just basically what I felt I need to teach for the community. This is not a structured course, correct? So the demo that I did in the morning, where you are able to see, like, 6th grade, 7th grade, that's an academic structure, correct? So that's based on an academic program. So I will share my email, or if you have already in my email, you can send an email. We will go from there, okay? So this is more of a personalized level than a common question where anybody can understand. Everybody needs to understand. So you can mail me, I will respond to you. So if you have my email, that's great. If it is not, I will give you my email. You can send an email, I will respond to you. But what I'm teaching here, it's not any of our course, what we offer for schools and colleges. It is different.
Okay. May I know the email?
Yes, I will put it in the chat window.
Okay.
Yeah, so look into the chat window. He's going to put his email. And I think with that, we conclude questions for now before we take break.
Yes, so we can take a break and we will meet right now. It's 12:50. Let's meet 1:45. Okay, so
1:30, we asked Prasanna to join for a speech.
Sure, no problem. Then that's fine. So we'll meet at 1:30. So that's fine.
He may spend around 30 minutes, I think, Jyotiji,
No, so
his experiences.
more time is better for me.
You can join later, Jyotiji. You can join later and take more rest. Till he finishes.
You can join a little bit and take some rest. That's all.
It's fine. Thank you. Thank you very much. So I appreciate the encouragement. This is what we needed. I appreciate all the questions. So I look forward to the next session. So please take a break, drink a lot of water, move around, take some rest. Talk to you soon. Bye.
Let's join at 1:30 and let's listen to what Prasanna says. I mean Jyotiji may join a little late, but we can listen to the real-time experiences other than what Jyoti is sharing,
Absolutely. So yes, we need real-time exposure, correct? So that is really important.
So we have 40 minutes break and then come back at 1:30 and Jyoti sir will be available at 1:45. Yeah.
Yes, sir.
Great.
Thank you very much.
Yeah. So I think we'll try to pause the streaming and recording. Thank you, guys.
Thank you.
Thank you, Jyotiji, and thank you, Ramji.
Thank you, sir. Thank you all. Bye.
We will make you as a, can you make him as a co-host, Ramji?
Yeah. Prasanna, no?
Yeah, Prasanna. Yeah, PK Prasanna Kumar.
Whatever works for you.
Yeah, I made it. Go ahead and unmute and come on video.
Good to see you, Jyoti, after a long time.
Same here, sir. Good to see you, sir. Thank you.
And good to see you, Prasanna. Hi, everyone. So probably I will give a quick intro to, Prasanna, so that, you can take it from there. And as Jyotiji said, he knows Prasanna very well. They're both in the same expertise. So
no, Jyoti has a different expertise and I can't match that.
Yeah, of course. Yeah, that is true. Yeah. So Prasanna is a chief data scientist at Business Optima. And he has almost more than 10 years of experience, in different verticals like banking, healthcare, and energy sectors, and he has also completed various leadership programs in data science and artificial intelligence. He did it in Harvard, Stanford, MIT, and Berkeley and Cornell. And he is topper in in the postgraduate program in artificial intelligence from the University of Texas and Austin. Apart from his work, he enjoys writing and mentoring. He also wrote a couple of books who are nation's best-selling, for example, Project Management, Comedy of Errors, and The Creativity Simplified, a handbook on creativity and innovation. Those are all written and they are all nation's bestseller. And he has a lot of expertise and in the area of artificial intelligence and the machine learning. And also he has served B School, visiting professor at BITS Pilani and SMART and Great Lakes Institute of Management. So he is happy to share, whatever he has it in the real time. And thank you, Prasanna ji, for joining as we requested. And the stage is yours. And please go ahead and share or whatever you have. Thank you.
Yeah, let me share my screen.
Yeah, we can see your screen. We just lost it. Yeah.
Okay, just a second. Can you see my screen now?
Yep, we can see it now. Yeah.
Okay, perfect. First of all, thank you so much for Ramesh ji and Jyoti ji and Karthik ji and Ram ji. So I joined a couple of minutes earlier in the last session just to get the connect and with the previous session so that I can segue it back as well. So what we're going to be covering in this discussion is in terms of having AI in action. This is essentially the applied AI part, because many times one of the key challenges is clarity in terms of, yes, these are important technologies, but where to use it and how to apply that. So there are a lot of questions. So I'm going to give a lot of examples of projects that I've executed, most of the projects that I have executed, and some of the projects which I've been on an advisory role. So I will share a lot of that during this discussion. If that's okay with you, we can continue.
Absolutely. That would be great help, Prasanna, like for the people who are here, you know. They will...
Okay.
Yes. So the more, Prasanna, the more practical view on these things would be beneficial, because there's a lot of abstract concept people understand. So if you're bringing a lot of practical examples, real world situations, that things that what you have done would really helpful and beneficial.
Sure, Jyoti, sure. So this broadly the agenda in terms of, so I'll be sharing with you the Pulse engine, a little bit of, which is used for sentiment calculation. A lot of folks who use social media would be knowing about positives, negatives, and neutrals, correct? These sentiments. That's actually a very key component, which basically made organizations to be able to understand what the feelings of your customers are or the users are. So I was a co-innovator of that Pulse engine. So I'll be able to share some insights of how we were able to do it, taking it beyond those three, the called ternary classifications, from just pure positive, negative, neutral into upset, mildly upset, madly upset, antagonistic, and so on and so forth. That's a very successful product as well that's used globally. Then there are CNN-based, how you could use convoluted neural networks to be able to identify weeds while you are actually fumigating, fitting this equipment, IoT equipments on tractors, which can actually identify weeds and then spray those pesticides onto the weeds and kill them, rather than spraying it on all the plants and killing the plant. And also spray or drip irrigate water onto the plants, which you require, rather than scattering the water everywhere. It's very interesting again how AI is used in that. And then for world's largest telecom company, two of the world's largest telecom company, AT&T and Tata, how we were able to work on using AI for customer identification as well as attrition management. Then for the world's largest retailer, on context-based object recognition. So how to use, while the largest retailers have also faced a lot of problems in terms of processing invoices that are coming in from all the different parts of the world. So how we were able to solve it, what usually took 21 days, we were able to get it processed in 2 hours using artificial intelligence on steroid. And then there is also a little bit of on ML. I'm using this word AI and ML kind of distinctly. There's a reason why I'll be able to share that. And there's the reverse parking solution that most of you would be using it in your car, whether it's BMW or Mercedes. This actually comes from Video Manasman, which is actually a German company. So I've worked with my team back in my HCL days in the innovation process. We use ML to be able to, when you do a reverse park, every time you do a reverse parking system, you're using the IP that my team at HCL did 15 to 18 years ago. It was a 3-year project. So I'll be sharing a little bit of that as well. And then the glucose meter for Johnson & Johnson, how anybody who's diabetic, who's using their insulin glucose meter, are actually using the machine learning component of what we developed back again, like 20 years ago. Again, from a machine learning, now we have graduated and moved on to the artificial intelligence space. So I'll be also sharing how we used AI to identify at what point in time, especially in the energy sector, to move an oil rig from one point of the installation to move it on to another location where oil is available. So a very interesting case, because if you move the oil, because the oil rig costs $1 million, if you move the oil rig too early, you're missing out on all the oil. If you move it too late, you're getting a lot of slug, which is going to destroy your equipment. So very interesting solution there as well. And then I helped them protect that IP for that project as well. I'm getting the patent. Then early warning systems in terms of banks, which most of the banks in Asia Pacific, they use risk management solutions, because if you're giving money to somebody, you got to be very careful, right, whom you're giving your money to. Because if they default 3% of defaulting is acceptable, right? I mean, not 3%, maybe 2 to 3% But if the defaulting goes 6%, the bank will go bankrupt. So we got to be very careful about what point what are the chances that customer would not pay that money back. So those creditworthiness calculations are also predominant Asia Pacific. In the US market, especially whenever you're using this FICO score, the implementation of that FICO score for the credit bureau, because if you're applying for a home loan, you'll be pulling out a credit pool, right, from the TransUnion, Equifax, and TransUnion and Equifax. So you essentially it should take only 20 seconds to retrieve all the data and then compute if Karthik is eligible for a loan, and what is the level of eligibility, what is the APR that can be assigned for Karthik. All of this needs to be computed within a 20-second time window that they give you to pull it and compute it, and then generate the report, which you can take it to a bank and get your loan. So that's also something that very interesting. So if you have time, we can cover that as well. So then the whole gamut of stuff that we can talk about. Another interesting thing is in terms of power line production. So while I was a CEO of Seattle-based company, we were able to work on projects where helicopters would go, and late subsequently drones were sent to capture images of power lines and then see if these vegetations are growing and touching the power line, because most of this fire gets started because of dry vegetation or even wet vegetation falling onto the power line and creating sparks and combustion and then catching fire. So how we were able to identify the vegetation, type of vegetation, how much it will grow in the next 30 days, 60 days, 90 days time frame, and then be able to send in the crew to cut them down or trim them down so that it can be of safety, avoid safety. But the input for that is essentially the feed and then analyzing the feed, because these are huge files that runs into several hours of footages. So you need to be able to identify the right frames and then also identify the vegetation properly. And then it's a very interesting project that we were able to do. So that's the agenda for one. If you have time, then you can go through swarm intelligence and a few other very interesting cutting edge, and also how Amazon you can order toilet papers using AI. Now you're actually currently using AI to order toilet papers.
Oh, very interesting.
Yeah, so that's a very good coverage. It will give you a lot of real world understanding of how I could take this AI. You'll be learning a lot from Jyothi, right? So how are we going to take that and apply it into a real world industry grade solution? So it kind of will fit beautifully into your most probably, hopefully, your expectations. Yeah, is it okay?
Yep. Thank you, Prasanna ji. And others, if you have any questions, feel free to jump in. So I made it available for you guys to speak so that it can be an interactive session. And if you have any questions, feel free to ask Prasanna ji. Yeah.
Sure.
Prasanna, take your time, and then no rush. Take your time.
Okay.
Okay.
Super.
Help them to understand, based on your experience, things that what you've done. So help them to understand the real world examples. That's the key.
Yeah. Okay. Perfect. So then I'll slow down a bit.
Yeah, I guess Tata has raised his question, Tata Prasad. So
yeah, thank you for noticing that, Prasanna. That is a very good introduction. Layman like
Prasanna
me.
ji, one question. Yeah, Prasanna ji, maybe you can remove your sharing so that you can be brought in limelight.
Yeah. Your face is like, yeah.
Okay. What I can do is perhaps I finish up these two slides, then we can take questions, because then you can circle back.
No need, Prasanna ji. Everybody can switch their view mode to side by side speaker. Then they can see you as well as the presentation. That's very good thing. So everybody.
I thought you are done with you are done with the presentation. No, you are in the middle. Then continue. Sorry.
Okay,
yeah,
so you want to see you want to see my screen? Yes, but how do we? Let me see if I can share my.
No, I just wanted to make it like speaker so that they can see you when you are answering.
Got it. So let me try and see if I can share my other screen.
Yeah, we can see you now, Prasanna.
Okay, perfect. So, but are you able to see my screen, my presentation?
Yes, We can see you and we can also see the screen.
Okay, perfect. So let's, but before we do that, let's understand AI. We all know why AI, right? I mean, we need to understand why AI now. See, whatever it was that took us where we are here today is no longer sufficient to keep us here. And needless to say, to take us to the next level, right? So it's important. That's essentially the grounding. That's the need. Let's also understand the grounding truth. So what is intelligence? Quick question. What is natural intelligence? What is artificial intelligence? What is applied intelligence? Can any one of you unmute yourself and then answer this? Just one person, so that there's not many.
The intelligence of a human being that is naturally, logically used is the human intelligence. And then if you have, as Jyotiji mentioned in the morning, how it becomes artificial because the intelligence used by machines is artificially intelligence. And the third question was what, Prasannaji?
Applied
intelligence. Applying the intelligence using machines is applied intelligence. I believe so.
Okay,
maybe I not be correct.
So you get 4 marks, right? So let's let's give you a quiz, a little bit more depth. That was the ground zero, right? So intelligence is, let's try and answer this. Intelligence is what makes you look smarter and, can you see my screen? Smarter and cleverer, right? So that's intelligence. So we have agreement there, right? So if intelligence happens naturally to its natural intelligence, right? We have agreement there as well. So what is artificial intelligence? Anything that comes artificially or incorporated into your system artificially, like a university degree, right? We artificially makes us look smarter and cleverer. Then appropriately applying this intelligence principles and components into real world applications is applied intelligence. So that's broadly kind of textbook definition of it, right? But let's also look at some examples. If you use image processing for face detection, or that's an applied AI. So you're using a technology like image processing and applying it onto face detection. Similarly, if you're doing natural language generation, if it's applied for topic modeling or grammar correction. So grammar correction is something that you will know when you're typing in your email. You have used autocomplete, right? So Grammarly, right? The Grammarly AI component is the one that's used to complete your sentences. Just imagine, it's able to predict what is the next, not just the word. It's able to predict an entire sentence or a phrase and help you compute it. That's based on AI. So then there is CNN, which is not the news media. This is the convoluted neural network, which is currently used in radiology related work, identifying cancer cells, non-cancerous, identifying cysts and all that. So that's the kind of a broadly what AI from a definition point of view and where it is used. So let me also give you another quick quiz. So if you're looking for this, is just to jog yourself, because usually the lunch session is a difficult session right after your post-lunch session. So right after that you're going to be feeling a little heavy, right? So this will help you kind of come back to jog you back into learning mode, right? So if you're looking for a backup camera and park, it's natural intelligence, right? So you're using a car, using your reverse parking system, you look at what's happening in the back and park, that's natural intelligence or assisted intelligence. If the car itself parks, auto parks, that's artificial intelligence. So this is important for you to kind of understand the difference between natural machine learning and artificial intelligence. Then if image processing is used for face detection, right? So face detection was also existed in the pre-AI era, especially on the using machine learning. But then if it can be used to generate smile, that's AI. So I'm going to be showing a demo as well at the end of it in terms of how it was used to generate a smile on a face which was not smiling. So if you drive a car listening to a GPS and avoid the traffic, that's smart driving. If the GPS tells us to drive, that's or tells us where to drive, that's artificial intelligence. So that's essentially, so AI unleashes unlimited amount of possibilities. There were limitations in terms of hardware and data. Now it's kind of opening up the possibility that exists beyond the limitations of the hardware. So in summary, if data is a new oil, AI is a new oil rig, because you need an oil rig to get the oil. And the more theoretical definition of this is of AI is essentially to be able to use computer system to perform tasks that are requiring human intelligence, especially on visual perception, decision making, translation between languages, and speech recognition. Okay, so in short, if somebody asks you, if you went through a session, what is AI or applied AI, is essentially the clever use of technology to replicate smart human activities. That's AI. It's a clever use of technology to replicate smart human activities. You're not going to replicate dumb human activities and call it AI. It has to be smart. So, and specifically in these following areas: judgment, sentiments, and synthesis of information. Because ultimately, human beings, the assumption is we are all intelligent people, right? Why? Because we can make judgment. So we have to judge correct. So that's essentially the underpinning definition of what an AI is. We will skip the ML part of it for now. And and what is applied AI? So we kind of had a pretty decent grounding on definitions of that, right? So what is applied AI is bringing this technology out of a lab into the real world to replicate smart human activities cleverly is applied AI.
Prasanna ji, sorry to interrupt. So
your slides are not moving, Prasanna ji.
Yeah, it's on the first page still.
First screen.
Can you see me? Oh, okay, got it. So I was moving here.
Okay. Now we can.
Now it's moving. Yeah.
Okay, got it. My apologies, because I'm sharing the other screen. Okay. Can you see this now better?
Yes.
Oh, that's why there were no answers for the quizzes.
Sorry, actually, we thought like we didn't want to interrupt while you were talking, so we wanted to give a pass.
Oh, my apologies. Please accept my apologies. Okay, so I was wondering why there was no answers for the quizzes. My mistake. All right, so applied AI, right? I mean, essentially what applied AI stands for is bringing this technology out of a lab into the real world. Again, I'm repeating the word, because most of what we are consuming actually comes out of 4 areas of harvest. One, it comes from dedicated R&D labs. For example, the Turing labs in UK, or the FAIR lab, which is Facebook's AI research lab, and similarly Microsoft research. So a lot of this dedicated research labs bring out this technology out. And there is also universities also create a lot of these papers, which basically they do research and implement these algorithms and test it out. And that also they make it available. And third is large organizations also internally have open innovation that make these innovations available. And then fourth most important part is the developer community. I think Jyoti would have also covered in terms of how GitHub is a major repository for
Kaggle also.
Yeah. So this is where actually these people harvest this technology from this and then bring it into the real world. That's what is applied AI. So I've kind of defined you in 3 different dimensions, but it is the same thing. Okay. Am I clear so far? Is it clear so far? Okay. So but in a lot more simpler term, what is AI is applying AI, applying a technology to make a lot of money is applied AI, or applying AI to make tons of money is applied AI. So that's the bottom line. Right? Today, one of the most highly paid professionals are in the AI space, and there's a huge gold rush that's happening. So whoever could take advantage of it, learn these technology, will be able to make full use of it, both intellectually very fulfilling, also financially very rewarding. Okay, the next one is also in terms of justification for this is all the list of AI companies with growth valuation opportunities: Instabase, Data Robots, Databricks, Data IQ. If you see one thing that's common, most of the ways, Facebook, PyTorch, and Grammarly and all that. So most of them are actually companies which are one thing that's common. Guess what is common among all these companies? They are all small, started very quickly. Yeah, Pradeep.
Hey, the common thing is the data, right? So
yeah, the common thing is they all are unicorns.
Yeah.
Say it again. They are all $1 billion in valuation, and they are hiring people left, right, and center. And these are all usually run by very young, smart young people. And then they were able to manage to make a huge impact to the economy as well using the technology. Okay, now just to give you clarity, we've talked about different terminology definitions. Let's also understand where these things are, right? So what is AI? What is ML? What is deep learning, right? So deep learning is machine learning is a smaller subset of AI, and deep learning is an even smaller subset of ML. So that's our part of the AI Venn diagram. And data analytics sits on the data science part of the Venn diagram. And what is data science? Science by definition is essentially learning through observation and experiments. So you take a lot of data that's coming in from your operations or field, and you analyze the data, like how how the mining industry works, right? So if you take a lot of you're not mining for dirt, you're mining for gold, but the gold is hidden in between those ore and dirt, and so other materials of non-interest. So the mining person will bring it all the way to the if you bring it all the way to the processing plant, and then it turns out to be that its quality of that mine is not good, or it's not gold, it's something else, then you're wasting a lot of this energy, right? Energy, time, and money. So what data science does is looks at the data at a very early stage, work in progress, and also moving towards the finishing goods, and analyze this and see whether this quality of the data is good or not. So that's what is data science is. And then a specific field within the data science is data analytics, which is you take and get meaningful information and present it to different users, whether senior management or other field executives or your customer engagement team, to be able to act upon it. Because the data by itself is large, and data science is a lot of complex things that goes on, and you want something that's much more actionable, so use data analytics. So this is the understanding. So if you have any doubts, just memorize this picture, so you'll be able to figure it out next time when you have a question on what AI, ML, data science, data analytics, and so on and so forth. Okay, now with that, let's get to the much more dive deeper into it, right? So if you wanted to kind of understand how a car works, the best way to understand is to open up the hood of the car and see what the different components of the engine and the carburetors and batteries, and then the chains and all so on and so forth. Similarly, inside the AI, this is all that's there. If you can see my screen, are you able to see my screen?
Yes, Prasanna, we can see your screen.
Yes, so this is all that is there inside the AI. The first part of it is the algorithms. Then there is so algorithms actually comes in different states, which is a reflex-based algorithms, state-based, variable-based. Then there are also this Q-learning, temporal learnings, then model-free learning, then reinforcement learning, which is again you learn by feeding data back into the system with the time difference. So it's actually very similar to TD learning, but an more advanced concept. Then there's adversarial learning. Adversarial learning is essentially now used for generation of images. Somebody was talking about AI AI can be used to generate image, characters, colors. The Avatar movie is using AI to kind of use the right colors, color palettes for the characters as well. And there's a lot of use in terms of generation of passage of information. It's called natural language generation. You can generate an entire para, and AI can write stories, poems, haiku, and there are a lot of cases where it's being used to, apart from grammar. Grammarly is a very early stage of that, but there's a lot more that's going on in the research world, and that can be used for generation of an entire para. So it can write a story itself without human intervention. Okay, so these algorithms are available, and you take the algorithms and use PyTorch or any of the Scikit or Hugging Face or any of the Python libraries, and then implement this algorithm. So that's the second part. So you need to have both the capacity to handle a large amount of data and large amount of complexity, but all of them are under the hood. So when you, for actual users, you don't have to necessarily worry about it. You can just drive the car, right? Like if you're asking the question, hey, is this too much? Yeah, it is too much, but you don't have to worry about it. If you want to be, the question is on whether you want to be an AI car owner or AI driver or an AI mechanic or an AI design engineer. So it depends upon the level of detailing that you want to do or level of depth you can achieve. You can operate at that level. So AI gives you the space to operate across the entire spectrum. For a bootcamp like this, you don't have to really worry about it, but that's a huge set of opportunity that exists. So you can generate content itself. That's how a poet would be, right? You can see the AI can now sing a song. There's clustering, there's Bayesian. So you have any specific question on this, I can go deeper into it. Otherwise, we can come back to this slide again to pull information or knowledge out of this. Anyone interested in knowing any particular topic in this? Yeah, so this must be a little too much, but trust me, we are using it every time we use a product. We are using a part of this technology. Okay, but in simple terms, this is what you would require. You would require reasonably good coding, and then Python or R, and good statistics, especially chi-square, preferably good in statistics, and then Anaconda, Jupyter, or Google Colab, and all that. Okay, so which you would have covered it in Ms. Jyothi's session. Then there's a lot of advanced research that's going on in the AI part of the world, especially labs, universities, and dev communities. These are some of those. So I am associated with several of these entities as well. So then this is one of the classic case of how research that exists out there gets translated into the real world. This is from a paper on Electra. They can generate, for example, on the left side, you'll find the chef cooked the meal, right? So on the right side, even if you adversarially change it, it will discriminate and then generate which one was replaced, which one was not replaced. This is completely unbelievable, right? So you don't have the access to the actual answer, but it will be able to figure out what all you have changed. So this is a very interesting model. So when you have time, you do more research on it. Just to give you how the paper would look like, I will show you one of the papers that I wrote, where it's used from a applied AI point of view. This might give you good okay. So this is how the paper looks like, because if you have to apply, the technology, right? So this is where the original source of it that comes from. So you take these papers like this, and this is on dark side of AI and sentiment polarization. So these papers will do a lot of study on other peer work, and then they will actually provide you we'll provide the post the code on the GitHub, build models and post those models onto GitHub, and so that users can take it and take advantage of it. In simple terms, what it basically tells you, this one in particular is, if a lot of sentiments, if you take even a balanced sentiment, right? Any conversations on social media, even if you take a balanced sentiment of negative, neutral, and positive, if you run it through a transformer, it generates negative. Can you see the negative bar? It generates a lot of negative sentiments. That is a model which is supposed to be neutral. Can you see now?
Yes, we do. Yeah.
Yeah. So you take this is all the input data, which is balanced, right? The class, there are equal amount of negative statements in that conversation. There's equal amount of neutral statements in the conversation, equal amount of positive statement in the conversation. You feed that to a transformer, which you are asking, please compute the sentiment based on which I will act upon it. For example, if the customer service CSR database, right, where we call up and give complaints, usually people, the majority of them are complaints, right? It's going to be negative. Now, what happens is when these AI products, when they're trained on it, they'll show them as negatives. But even if you balance them and give, it still shows them as negatives. That is, they are trained because they are trained on pre-trained models, pre-trained data sets, which actually have a lot of negatives. So because of it, any new data that comes in, it's able to identify them as negative, classify them as more negatives than positives. This is across Dilbert, Roberto, Bert, except Vader does a pretty good job. So this is what one of our finding, and then was appreciated. I mean, for Stanford, I did that. And so what happens is after this, you take this implementation of the model or the paper, and sometimes the code, and then you convert this into applied AI products or libraries. Now we can use it to do simple classification of emails or regressions, price calculation or stock predictions, or age detections, sentiment classification, like I told you, or weather predictions, or intrusion detections if there's any vulnerable, any hacking attempt, or search engine optimization or search engine itself. Then conversational bots. Today, if you go to Amazon, if you want to return some stuff, you can go to Amazon chat and then talk about with the product that you're returning, or not happy with the service, or you want the refund, you can actually talk to a bot. You're not talking to a person. So there are a lot of conversation bots. There are a lot of game bots. I've also developed some game agents as well, which can play Pac-Man. Very interesting one. Then also use it for bank check processing. Today, most of your checks are processed without any human intervention itself. So you can use your mobile app and then scan your check and it gets processed. Again, AI. From ML world, it's moved to AI. So now with that context set, now let's dive even more deeper into any of these topics. Now I'll put a pause here and take a kind of feedback, see which one is of interest to you, which one is not of interest to you. Karthik or anyone, if you can guide me in the process, then we can channelize our time and energy into those areas of applied and dive deep into it.
Prasanna, this is Prasad Tata. Can I ask a question?
Sure.
Okay. I'm from the health sector, so I'm more interested to know how you applied this AI in that glucose monitoring and BP monitoring devices.
Got it. So it's an interesting, very interesting question, and very close to my heart as well. So this was a company based out of Milpitas, LifeScan. So they had a glucose meter. It was a large contraption. So we helped them with the miniaturization of that particular product into a much smaller form factor. At the time we used ML. So because if in those days, if you have to go to measure your hypoglycemic index or blood sugar level, you have to go to a diabetologist. You got to fix an appointment with the doctor, diabetologist, travel, and then wait. And there's a waiting period. Then they will take your appointment, and there even the doctor there would require to capture your blood sugar level by drawing blood. And there's a process to it, right? Usually, I mean, they would actually delegate that work to a staff nurse who would do that, and then come back with the results, or go take it to a lab and come back with the results. This whole process, we simplified it by making that into a very, very small device, which you can take it home, put in your pocket, take it home, or wherever you are. That's the one-touch device that you would see globally. So I was the co-innovator of that particular product. This is again close to 19 years ago. That was the ML world. So how we were able to convert that into a much smaller. There we used good amount of algorithms and lookup algorithms to be able to translate a blood that is drawn does not indicate sugar alone, right? It has a lot of other chemicals. So there are layers of wafers of thin papers that is used in a test strip. The test strip draws down, converts your blood sugar into gluconic acid. The gluconic acid is very, very sensitive. So it also increases the conductivity of a ferry layer. So you're able to conduct that. So it's like similar to an IoT device, very, very small. If any of your family members or no one use this glucose device, that was developed. So there, the capturing of the data is one part of the problem. But what do you do with the data in terms of the ML, right? So the machine was made to learn, to figure out that the conductivity of that additional conductivity of the test strip, because if you have a lot of glucose in your body or sugar in your body, your blood that you draw will have sugar, and that blood, when it reacts with the test strip, it's going to react and convert itself into a gluconic acid. The acid converts the ferro into ferry. which increases the conductivity. That increase in conductivity of the test strips is a data, right? It's a signal data. So converting the signal data into data signal and calculating the hypoglycemic index. That was basically the algorithm that we used to be able to apply that. It's a lot of details, but one of the key challenges to be able to use algorithms and convert what you read as a increase in current reading, right? Similar to an energy meter reading, converting an energy meter into a glucose meter. That was basically the innovation of that particular solution. It's very interesting. And then localizing that for internationalization, localization of that for about 28 languages. So that's why that's what made because diabetic is not just an US based challenge. It's a challenge that the whole population is facing. So we got it translated to Hindi, Bengali, and all the languages, and Far East Thai, Malay, and all the languages.
So is this a real-time data that get transmitted to the physician's office and they make a decision?
No, the device makes a decision. So you're making the machine learn and will give you whether you are 80, 90, 180, because if 140, whether your sugar level is, see, diabetes is not a disease, it's a disorder of the body. If you are able to be within the upper control limit and lower control limit, you can manage it. But in order to be able to manage, you need to have a device that it tells you, when should I take my metformin, that's my tablet. If I don't want to take my metformin, or anybody shouldn't take a medication without when the blood sugar level is normal, because it then will depress the sugar level further by activating insulin, right? So you need a device. Earlier, it used to be doctors and diabetologists and GPs with a large contraption. They had to, and you have to physically go there and do it. Now that all changed by adding more intelligence and capability into a small device, which you can carry it and put it in your pocket. Most of you won't be diabetic, so you may not understand. But for a diabetic patient, that device changed life. It made them move because whenever they're feeling a little tired or a little out of normal, they can just measure it immediately, and then it tells you whether they are within the limits or not.
Even though these days you have the patches also, not even a machine. You have a patch. It's remotely controlled through your apps on the mobiles. Yeah.
That's correct. So
that's IoT.
Patch. Yeah, that's a patch. And we also worked, when I was in the CA of Apollo Hospital, we also worked with one of a product, a US-based products, which basically where you can consume a small tablet. It's very, very small. It will have a chip inside, which goes into your stomach. It basically reacts with the acid and then becomes a battery, or like it has effect of a battery, and then powers up the small chip. The chip will measure the insulin level in the body, and then it will send you a Bluetooth message to your mobile. So
nanotechnology.
So just imagine, you pop it in, you get real feedback of what's happening inside your body. That's an AI. The capsule is pharma, the chip is semiconductor, but the Wi-Fi is networking, Bluetooth technology, but the data processing is using AI. So the possibilities of applying technology is it's not the technology by itself. High tech does not mean high cost. It should mean highly affordable, at high quality products and technology at affordable prices, and making it available for as many people as possible. So that's essentially applied AI. So if you guys are interested, this is a great space to be in.
Could you also explain on the CBOR, please, for the 21 days, 2 hours?
Yeah, so this is actually, you guys would have known about this character recognition, right? Character recognition. So
yes, please. Yeah.
And handwriting recognition.
Yes, right? Handwritten, yeah.
Yeah, but the problem is that if in checks, we developed this for a leading retailer, and also State Bank, even most of the banks in India and Asia Pacific and Middle East are using it. To recognize it, a lot of people, when they write 7, they will write 7 and then put a stroke also in the middle. Correct?
Yes, some people do, yes.
Yeah, 4, the same person will, another place will just write 7. It depends upon where they originate. And so there are a lot of complexity that was involved. Now, this was a retailer who actually had a challenge in terms of, look, I want to be able to squeeze more from my vendor, right? And during the survey, they figured out that the vendor is willing to give you more discounts, but retailers squeeze vendors. That's how they make money. So they said, if you are willing to give me payments quickly, I'm willing to give you an extra 5% or 10% discounts. Right?
True. Yeah.
So that was a case. So we came up with the solution, and the regular character recognition was a problem because the invoices comes in, millions of invoices comes in from all parts of the world.
Right.
Okay, this is for a Midwest company, a large, very large one. They have like 5-mile supply chain. So it comes from all parts of the world. It's difficult to process, and so much of data, and then a lot of irregularities and noise data. How to process them accurately, because you don't want to make extra payments or wrong payments. There'll be a problem. And and invoices also carry invoice numbers on different parts of the invoices, right? Sometimes some people's invoices have numbers on the top, some people invoices numbers at the bottom.
Nomenclature is different, yeah.
Bills, yeah, even our home's bills comes in different shapes and sizes. So we built the ability to do how a human being, when he watches a bill, they can decipher it. Correct? So regular character recognition failed. So we were able to do that, focusing of it, how we were able to shift. If you're not able to find the bill in top corner, move it to a different part of it. So like it zoomed back into that area and then picked out the invoicing data. And then we were able to process it within 2 hours. Okay. Massive scaling of that. This was a phenomenal project. So
what was the error allowance, please?
We were able to get 95% accuracy, 95.7 or something like that at that time. And then it moved on to 99% accuracy. 99.
You learn over a period. You learn more.
It remarkably learned, because at 0.03 it was much more accurate than a manual process.
Thank you.
Okay, and to conclude it, because of it, they saved 21 days of payroll costs. Got it? It was huge, and then they were able to squeeze more discounts from the vendor because they were making the payments. 2 weeks.
That's the applied intelligence, right?
Applied intelligence. You're right. Applied intelligence. Okay. So similarly, you have any questions, you can ask me, so that way there's more context. So you have your specific needs are also addressed.
Thank you, Prasanna ji. And we are planning to wrap it up by 2:30 so that, like Jyotiji, like he can continue his session. So if anybody has any other questions in real time, like how Reddy Garu was asking, so feel free to jump in. And
Mr. Kumar, I'm fine. If Mr. PK needs more time, I'm okay. I'm fine. I have another day. I can cover, not a problem.
Okay. Yeah, Prasanna ji, hello. This is Bhupinder.
Yeah, Bhupinder.
Yes. So let's say I am a very FOB, like new guy in the field, and if I have to start my career in this area, then what are your suggestions? Like what are the things I should be, involved?
The first step is you should take a course with Jothi. which you're already doing. That's the first step, because you need to be able to anybody can go to YouTube or learn stuff.
Understand, right? Practically, yeah.
Yeah, and you have to learn this very structuredly. Okay, so anybody today, access to information is not a problem. Information is available. In fact, too much information is available. The key is to be able to structure that. Either we should have the discipline and the comprehension capability, or it should be a forced discipline. So if you're taking up a course with Jothi or any of the very good, doesn't have to be very expensive, but something that can give you the discipline, structured knowledge in a disciplined environment, that would be the number 2 step, number 1 and number 2 steps. The next part of it is you have to know what you want out of it, because you don't want to get too challenged, because AI can be quite challenging as well. It's easy. It's like a spectrum. There are parts which are easy. There are parts which are difficult. So you have to choose which one works best for you, for which an exposure like this will help, and then gradually work your way up, right? Like a Peter principle. People get promoted to the highest level of incompetency, right? So we have to get ourselves, promote our knowledge and our learning into the highest level of incompetency. Okay, so you have to choose that, and then climb gradient descent, or you'll climb yourself into the peak position where you'll be the best in that space. So you can choose on there in AI. There are a lot of, whether if you want to be in research, then you associate yourself with research labs. If you want to be in billing, then get into consulting, because you learn a lot in consulting, AI-based consulting, and also cloud. And if you want to be a developer, then focus on Python, because be very good in Python and a little bit of knowledge on AI, that also will go very well. Or if you're good in platform-based solutions where you're using, like, for example, product like Amazon SageMaker, you don't have to have a lot of under the hood knowledge. You don't even have to know anything about algorithms. AWS or PyTorch basically does a lot of things. In 10 lines of code, you can write your own full sentiment analyzer. What took us closer to 500,000 lines of code, it was 1 million lines of code, but then we shrunk it to 500,000 lines of code before I sold that IP, which now is available in in 10 lines of code. So you don't have to break your head. So there are a lot of products on, you have to choose, of course, whether it has to be Azure or GCP or AWS. You can choose the platform, and then the products are also available. So AI is like a la carte, so you can choose whatever works for you.
Okay, thank you. Hi, Prasanna Kumar. This is Rama.
Hi, Rama.
Can I ask a question? Yeah, my name is Rama. I just calling from Boston area. So from this slide, I work in an insurance company. Is it something that, can you briefly talk about that ICD-9 10 coding assistant, something where ML can be used?
Yeah, so this is so essentially what happens. One of the key challenges is billing, right? So all the physicians use ICD-9 or ICD-10 coding because that's what the insurance company accepts. So they have this MSDRG grouping, and that if you're coding ICD code falls within that grouping, you will be paid. If it doesn't fall, or if it has error, insurance companies have reason to reject your claim. So so this coding assist will pre-warn the physician when they type in their ICD codes, seeing if there is any conflict, if there are inconsistency. For example, if somebody goes in for a chest pain, if they give some other medication, or if the diagnosis basically has another ICD code which is not in the MSDRG grouping, then it'll warn them. So that's what this basically this product is. Very, very interesting because ICD-9-10 is very complicated. And also even at create, for example, heart patients, right? Thrombosis. It's a very, very critical part. If a patient goes in and then they are actually indicating chest pain, and then your lab results comes with thrombo-related warning, if the physician or the cardiologist doesn't pick up, you need to have the system pick it up, because otherwise the patient dies. Then the hospital and physicians carry in huge liability. And then
so this is trying to help the doctors or insurance company?
Yeah, the solution right now is actually helping the doctors and hospitals and physicians. However, we have actually also had a counter solution, which is we work on both sides, right? I mean, it's like it's in a way, AI is in a way a monkey business, right? So you have to basically give technology to both sides. So we have provided for insurance companies as well to be able to catch this if they missed it.
Right. Okay.
And then manage.
Catch me if you can. Yeah.
Right.
Yeah. So it's basically a good race condition. It's similar to a defense. If you're a defense country or company producing defense, you sell it to both parties.
Okay. Yeah. So thank you very much.
Yeah. Did I answer your question?
Yes, Prasanna. Thank you so much. Yeah. So now,
Prasanna ji and Karthik ji, kindly share your email ID so whoever was interested, wanted to touch base with you later on, they would be able to reach you, please.
Sure. It's strategypk@gmail.com. I can put it on the chat as well.
Thank you.
Hi, Prasanna. This is Pradeep. Could you please explain the applied AI on the telecom domain?
Yeah. So very interesting question. This is from I can share the name of one company, Tata Telecom. So the other company is a very large, even much larger, the world's largest telecom. I can't name it, but you will figure it out. What it also has alphabetically, it's in the top.
You already disclosed it earlier, Prasanna ji.
Oh, I did.
You did.
Okay, so I'll be very guarded in the details that I shared. So one of the key challenges I can share with the Tata Telecom. One of the challenges. This is directly from Mistry at the time. Cyrus Mistry was the chairman. So they had a challenge in terms of customers leaving their network, right? Because no company wants to lose customers, especially these are each one of these clients were like $10 million, $5 million customers who are actually running a pipe with a telecom operator. So And many times when you lose his account, it's difficult to recover them back. Are you with me so far?
Yes, yes.
Right. So it's important to catch them before they leave, or they show early indication that they're not happy. Now, the regular sentiment analyzer engines were providing only like, dislike, and neutral, right? Positive, negative, neutral, right? But what are you going to do with that? So, I mean, that's not an actionable, it's not an applied AI, right? You can't apply that into solving the problem. So that problem was given to my team, and we developed I did the innovation part of it. I didn't do any coding, but I did the innovation part of it, working with the senior management. What we have done, we have figured out a way to classify the sentiments into not just 3, but take it beyond into 5, 7, 9, and then we moved it on to 10. For example, if the customer is upset, mildly upset, madly upset, antagonistic, happy, unhappy. So we were able to kind of give an entire spectrum of it. Then additional dimension, these customers do they have influencers? That is, can they talk to other guys and influence the brand negatively, or what kind of impact that they can have? Or are they connected to media or any of the other forums and create a hangama? The other dimension is, how likely will they move in the next 30 days, 60 days, 90 days? Because I built the innovation, the model that helped them narrow down, because even the largest of companies, the resources on call center resources are limited, because they don't spend usually a lot of money on cost centers. Right? Call center is a cost center, so they don't spend. So how to manage this unlimited amount of complaints that are coming with limited resources is what the AI solution that we did. The way we did it was spread these emotions in a much wider spectrum, taking it beyond the ternary classification into much larger classifications of sensitivities of emotions, influence, impact of, and then time dimension. That is how likely. So those customers who are most likely to leave in the next 30 days, who are really upset and can cause a lot of damage to the brand and influence other people, were taken in, and that list was provided to the existing call center, customer service and customer relationship management folks to fix those relationships. Thereby, they were able to significantly bring down the attrition of this telecom. This is for large accounts and relationship management.
Okay, so basically it's a churn reduction.
Yes,
kind of thing, right? So yeah.
Reduction
so one of the factors.
Churn reduction.
Yeah, one of the factors is.
We also did another one on switch management, which is essentially switch management. This is on the backhauling of data, because the data comes from antennas, right? So there are a lot of backhauling systems that we used, in which AI was also implemented. But that again, I have to go through an entire presentation in terms of how we made that impact, in terms of asset cost of managing those assets using AI, how we were able to bring it down. That I can discuss if you have time at the end.
Sure. Thank you, Prasanna.
Did I answer your question?
Yes, definitely.
Okay.
Thank you.
So you can be both domain-based solution as well as because attrition is not a telecom-based problem, right? But we're also able to solve telecom-based problems. AI is, you can use it, is like a kitchen knife, right? I mean, it's like a army Swiss knife. You can use it for any purposes, as long as somebody is willing to pay for you.
Right. Yeah. Thank you.
Next question. Any questions? So one thing, if you have time, I can cover this social media work that we did for leading bank, Standard Chartered Bank. So this is a very interesting problem statement that came to us to be able to identify, because on social, these days a lot of social media presence, right? But like 10 years ago, there wasn't much of that. And at an early stage, when Standard Chartered was a pioneer in that space. So we did a lot of work for them in terms of identifying customers if they're upset with which particular product of banking product, whether they're upset with the ATM or bank, retail bank, or any of the other commercial trade finance bank. So what are they upset about? We were able to bucket them into different categories, and then we were able to send this data out to the field to be able to fix it and collect feedback from them real time. Very interesting banking. We were the first to create that social media based ticketing solution, which is engagement. That is, if these days we hear about airlines reply, if you tweet, airlines respond back, right? So this was the very original product or solution that we implemented, where the banks were responsive to customers who were going online, whether it's customer company, whether it's website or social media platforms, ability to pick up those conversations, listen to 100,000 plus source systems, millions of conversations, and then bucket those conversations that is relevant to you as Standard Chartered, and then within that, which product line and which geography, and then present that to the necessary people to take action. So very interesting. So that the customer also happy because he was getting responded back. The team also knew that if my people in my, for example, if they are in Hyderabad and one particular area of Hyderabad, the particular branch needs to know if any of their customers are actually complaining, right? So they will get that information to their branch. A very interesting, exciting pioneering.
It's all around the common man. So never underestimate the power of a common man.
Never underestimate the power of a common man. So I'm a more a common man guy. I'm an engineer at heart. So I like. So if you sit in the ivory tower, you're not going to see what's happening in the real world and what's happened in the world. You got to get your.
So this is Rama again, Prasanna Kumarji. So the data from social media, is it something are you collecting from Reddit or something, or from Twitter? Or
100,000 source systems, YouTube, you name it, because we had built the connectors, heavy duty, lightweight, RSS reads, knowledge graphs that we were able to build from the data. Semantic web analytic engine that we built. So any source system that you give, whether it's enterprise or social media, it will be able to take that information and then it will do data cleansing, data mapping, and data transformation. And then we have done the early stage convolution of data and then provide you.
This is part of your solutions, like you already.
Yeah, I've so successfully was able to sell. That was one of my venture.
But is it a platform or I was trying to answer, if I have an idea, supposed to access some social media, Reddit,
today there are so many of them are available now.
I see.
Yeah, you can just go to github.com and then pick up. There's so much that's currently available.
So is this automatic population of the ads you see on the Facebook and Google?
Yeah, this is different.
This can be cited as an applied artificial intelligence.
Yes and no. The yes part of it is because there is it basically reads your cookies and your folders, files, and history, and then makes intelligent analysis of that data and see the co-occurrences. That is, for a person who's looking for XYZ, what are the ABC that will have a good match? And based on which a recommender engine basically recommends, first is the co-occurrences, then the recommendation engine. Similar to a Netflix, right? It recommends those products. And then there's an ad engine that basically, these ad engines are embedded by the website companies. Like if you go to any website, they can embed because they get money out of the placing those widgets. They call it widgets. And then the widgets basically shows those pictures or videos. The reason why I'm saying yes and no, yes, it is AI and ML, but it is dumb because it's sometimes irrelevant information also do come in. And there is no privacy. So your privacy is compromised. So that way it's not a great.
There is no privacy. There is no privacy. Everything is an open book now. Thank you.
Every conversation of what you make in USA has been recorded by the.
Everything can be recorded.
Yes.
I will not say is recorded. Everything can be recorded, analyzed. So even your emails are being read, right? I mean, that's how promotion. If you're using Gmail, right? How are you able to tag them as inboxes into mails, promotions, and so on and so forth? It's reading. So I agree that privacy does exist, but privacy is also the space for privacy is shrinking. Let me put it that. That's much more accurate way of. You still can live off the grid, turn off the camera, and your mic, there are chances that you can still have experience privacy. Okay, so I can cover.
Even Ring got into problem because of these issues of cameras being used and hacked and all.
Correct. That's a more hacking intrusion detection. So if there's vulnerability that exists in the product like Ring, and somebody can actually take advantage of it by hacking into it, by finding out which port access ports are vulnerable and which apps. It's not just the ports, right? You can use the denial of services and then compromise the device, or you can actually look for applications that are written and listening to the ports, and then you can smurf it, and then you can overload it, and then find out you can do a session hack. And then once the device is compromised, it's not to you can't blame the AI in privacy. It has to do with those guys who built those products should take those additional measures. And it's a cat and mouse game, right? I mean, sometimes the hackers are smart, sometimes the security networks infosec guys are smart. So it depends on who outsmarts who. So it's like a game theory. So one has to catch up with by coming up with better, smarter, harder solutions to break, layered solution to break. AI is also used on classification of intrusions, because once you teach it, subsequently you don't have to tell the signature. It will come up with newer and newer signature because you will try to learn which vulnerabilities, and that's how these days most of the antiviruses, not just antiviruses but also intrusion detection IDS systems, PIDSs, network intrusion detection systems are all built on AI, so that it basically checks on its own vulnerability. This is called GAN. It's based on an idea of generative adversarial networking. That is, it basically acts itself or tries to act itself and see if I can be hacked. If I cannot be hacked by myself, then I'm at least okay. I'm strong. That's what it's like exercising. The AI exercises itself without you adding new signatures to it. Okay, did I answer your question? Okay.
Thank you very much for everything, Prasanna. Please share your email ID. Don't forget. Thank you.
Sure. So let's now quickly jump into there are the other very interesting stuff, but let's look at the future trends. So tomorrow your car will go and pick up the groceries. This is what I'm foreseeing. It'll drop off your Amazon returns. Yeah, that's the car. Yeah, you can plan and prepare your daily schedules. You can read and respond to emails. Sense and manage your mood. Talking about sense and manage your mood, we did a solution for Dubai lifestyle city. I'm back in there in terms of being able to sense the mood of high net worth individuals and change the wall colors, come up with soothing voices, tell them their day schedule and so on. So very interesting. Now we are seeing that also getting implemented many of those malls as well. Then tomorrow, metaverse is also now out there. There's a lot of emphasis on it because there's something called twining. Twining is actually each one of you will also have an avatar online, which will be doing this work while you are sleeping, right? You can check your stocks, check on your cryptocurrencies and see if they are safe, and you can do a lot of stuff. Okay.
How do you do that, Prasannaji?
Metaverse. Facebook has now introduced the metaverse. If you have time.
Yes. Yeah. Change the name to Meta.
Yeah, this is called twining. That is, you create your own avatar, which is working based on your profile and needs continuously. Okay.
But decisions are not made, right? It's only tracks and analyzes.
Decisions are also made. Judgments are made. Decisions are made. Again, some of it is not out there in the public domain. So you will get to. I can share. I'm not privy to that. But what I can talk to you about twining as a concept. And I worked with one smart entrepreneur startup way back 7-8 years ago. And at the time they built the early stage of avatars, and also they were very good and big in gaming. So they try to use it for public domain function. So you will also have avatars. That is, these are virtual characters which replicates you.
Yes,
and then you can come back and, for example, if you tell you, hey, I'm not happy with this employer, it'll go and search a job for you, do a matching, talk to them, and even discuss, negotiate range of salary, and come back and give you that as a lead. Okay.
Wow.
So there are possibilities are enormous, and
say if I am in US and the stocks are being going up and down in India while I'm sleeping, the avatar can go and buy shares and sell shares in India on my behalf?
It can handle all your short positions. You can do a lot of that as well, and you can put in some fail safety as well.
Wow! Thank you.
Yeah, and book and cancel your tickets also something that it's already been doing, many of them.
What do you call all this? This is called metaverse of avatars. This is what is
metaverse is metaverse is one of that. It's actually called twining.
Twining. Okay, thank you.
Twin. It comes from the twin, right? Digital twins.
Two times. Dual. Yeah, twin.
Yeah, digital twins. So, and my prediction is that it might even pray for you. Okay, because we are all too busy.
Yeah.
So I'm just joking. Okay. Okay. So just a recap, and so what we saw what is intelligence, what is natural intelligence. We saw why AI, why now, because of the opportunities that are it's very highly paid, a lot of companies getting good valuation. Then we looked at the list of tools and technologies, fairly large toolkit, but predominantly data sets are very, very important because you need to have the right data to learn from it. If you feed the wrong data, you learn the wrong things. We also saw the example of how if you give pre-trained data which learned on wrong customer service database, AI itself becomes negative. That is, it starts looking at even balanced data as negative data, negative sentiments. And then we looked at the development environment like Anaconda and Jupyter. You guys are already using that from Mr. Jyothi's given you a good overview, saw that. And then you're going to do some hands-on, I believe, as well, which is so keep at that. Then we looked at some of those projects and we picked up, not all, we didn't go through all of them. We picked up one or two, whichever were relevant, and then some trends. And then this is a good segue to the 2-day workshop. Back to Mr. Jothi. One thing last time I want to conclude again is whatever it was that got us where we are here today is now no longer going to be sufficient to keep us here. Needless to say, to take us to the next level. So you need to have a learning mindset, and the journey of 1,000 miles starts with the first step. And attending a advanced AI workshop or AA workshop is a good first step. So happy learning, and thank you for you guys.
Thank you so much, Prasanna ji. And I think it's really helpful. It kind of helped a lot of things. Yeah.
Karthik, one last slide I want to show is how AI can be used to put a smile on the customer's face. So this is basically Thomas Alva Edison. Okay. So I have to bring this up. Let me.
You should do to MPEG side, movie side. Motion.
Yeah. Let me share this with you.
Jyotiji, probably next time we expect you also to share your knowledge.
No, nothing.
So it's like giving to the community, right? So whatever we all learn, so we just share it.
Definitely. Anytime. Thank you.
So this is basically a smile generator. Yeah. So if you see the difference, it basically automatically generates a smile. Okay. Yeah, that's it. Happy learning. And thank you so much to Ramesh ji, Karthik ji, Jyoti ji, and Ram ji for the opportunity to.
Thank you, Prasanna. My daughter says this is available in Instagram. It will create like what you created.
Yeah. This is developed way back, and we made it all available, open sourced it.
Wow.
Thank you, sir.
Yeah.
Thank you.
Thank you so much.
Yeah.
So it's really like very deep learning for so many of us, and we appreciate from bottom of our heart. Yeah. Thank you from TANA leadership and everybody.
Thank you, Ji. Thank you. Appreciate
it. Thank you, Prasanna. I have one question. Okay. This is more for employment perspective, correct? So we have roughly around 64, 70 participants, correct?
Yeah.
I'm sure each one has their own goals or objectives. So I'm here to learn more deeper. I'm currently in a project. I need to get to know this. I'm here to get another opinion on something. I'm here to understand certain basic things. There are so many different ways of looking at this one, right?
Got it.
But on the surface, I feel there's a lot of us here for a career transition or advancements, or how the future is going to be, correct? Like, so in terms of employment perspective, right?
So what I'm going to get into, where I'm going to get into, how I'm going to get into, right? These are all unknown questions a lot of people have that in their minds.
Correct.
But if you look at products and solutions out there, it doesn't talk about how someone can start and where they can go and how they can step into this field.
Absolutely.
It's too broad, number one. There is no structured methodical learning system at this point. Yes, we do have Coursera, Udacity. I myself teach in many institutions, myself offer a lot of courses, but there is no starting point and then it evolves from there. Right? There is no structured methodical way of learning and gaining skills on practical problem solving areas. Okay?
Correct,
when I say practical problem solving areas. So currently I'm on a project with it's one of the leading airline. They are trying to build this particular financial model for across world, okay? All sectors they operate. In the same team, I have people from McKinsey, I have people from IBM, I have people from Cognition, I have people from Wipro. Okay? It's 150 people. I lead the team from the client side.
Got it.
So these people all have titles: data scientist, data engineer, machine learning engineer, XYZ.
Got it.
But when we put them on the real world projects, correct, like real applications, we build this part, correct? For example, correct. So I want to understand the location and the weather. When I say location and weather, actually, like now, so how does, because that changes based on geography, right? Like how things happen in Singapore could be different, and India could be different. Like US, it's all different.
Correct.
So how do we bring all these things together so that
beautiful question. In fact, it's actually three. I look at that three questions, but there's a beauty in all the three that you asked. One is here are some 60 plus folks.
Give me 1 minute. I'll finish this and then you can take it. So I'm trying to ask this question. I can sense based on the audience interest, commitment. Why they see somebody is sitting for 2 days in a session, right? There has to be some serious commitment. Otherwise, they're not going to sit here. This is not sitting and watching a movie, right? It is not that. It's a very in-depth technical discussion, in-depth topic on certain areas we are trying to address as well. So what I'm trying to ask on behalf of the audience, correct? I'm a newcomer to this field. Okay, so point one, what is my starting point? Point two, from there, how do I go? Okay, point three, what's the destination? Where do I land? Correct. So, like, there are several areas I can focus on. Correct. Like now, as I told in the class, correct, I told there are so much misleading information out there. Okay, just an example. If you ask people the difference between machine learning and deep learning, 99.9% you get an answer saying that deep learning is an extension of machine learning. In my world, it's wrong. Okay, why? So machine learning doesn't have any underlying architecture. It's just a concept, it's just a terminology. But deep learning has its own architectural framework. Okay, it has how it learns, the machine learns, and how it works, correct? So there is so much misleading information from your industry point of view based on what you told. So he's been in industry for 19 years, so you build a lot of companies and sold companies, correct? So you have seen ups and downs in life and ups and downs in career transition, correct? So what is the best advice you could give for this audience? Right, from a career transition perspective, where to start, how to go, where to land.
Got it. Okay, so I've taken note of those questions. First, I'll start with the audience, right? So one thing that you mentioned is that many actually also have title. Today, actually, titles are freely available. Okay, so the issue is not the reason is I'm saying this with the positive on the positive note as well. There's a negative note and a positive note. The reason is one is guys have earned it, right? Earned it not because currently they are good data scientists. It's because they have earned it the last 10 years or 15 years. They spent and worked hard to got into a position. Now the company is willing to give that, try them out, or they themselves are assigning those titles. So that's the first part. So you've earned it, but in order to be able to do very well in that, right now the weather is not that bad in terms of you're not going to be rushed into it, but eventually there's going to be a lot of pressure that's going to come from top management or from the customer asking you in different things. So this is, in a way, I think you have picked it up that this is a important, what this gives you time to prepare yourself, because when there is pressure or demand, it is difficult to learn or acquire a new skill, because every skill building process takes a runway time. So think of this as a runway time, and you can have all the titles that you want, but build the skill so that when the onslaught of demand comes from, you are ready, and then you are able to do it nonchalantly. That's my first part of it. From I know it's a broad career transformation thing, but those who don't have title and don't have opportunities, you have to build skill, because this is where all the traffic is moving. I mean, if AI is the freeway that all the other streets are actually is merging. People are not aware of it. The sooner we realize, the better it is, right? So those who have title, congratulations, you earned it. Those who don't have it, work towards it. We will have to get it. That's like oxygen. That's my first part. Second part of it, did I answer that part of the question, Jyoti?
Yes.
Okay. The second part of it is the steps that one has to do. I would use the word innovation. Again, innovation is the most used, misused, and abused word. I will use the word innovation. So you have to figure out a way to innovate ourselves, because that's what I did. I went to Stanford, Harvard, MIT. Luckily, I got admitted because I had a lot of years of experience, and I didn't have to go through the regular rigmarole. But I was able to. I spent like 75 grand on this. I learned a lot of this across. But hindsight, if you look at it, yes, these are great, but I could have definitely also cost optimized it, right? The question is on now what do you want, and I wanted to learn everything. I'm suddenly with the COVID, I realized that there was a time that's available. I wanted to use this in a positive, constructive fashion. So I invested myself into learning it from all the great minds, right? So while doing it, but you have to also be innovative in terms of taking. Now the technology is available. Everything's available on GitHub or research papers. Everything is published in public domain. But to be able to use it in the most appropriate fashion will require you to actually, preferably you take an innovation workshop. That actually will help in terms of how to apply that. That is to get the mindset and then the innovation process. If these two, if you're able to get it, you'll be very confident, because by the time you finish off your AI knowledge skill set building, when you are faced with the problem of solving the weather challenge, right? Or traffic, or self-driving car, or recommendation system, because your case will be not technology. They will give you a case which is, hey, help me increase, do an outreach, come up with a solution that will help me outreach, because most of the guys are sitting at remotely. I need to have an online or online, how to have an outreach program, come up with an AI engine, a recommendation. Or they will come up with ways by which they tell you, look, I want to be able to build something similar to Zoom, but for my corporate intranet. Or I want to have a knowledge graph where my organization is sitting on top of a lot of digital data, but I'm not able to search through, and I need to be able to have an AI engine that tells me what is relevant. So that would require you to, in a simple term, you have a pencil, you have an eraser. Putting the eraser on top of the pencil and selling them as eraser pencil, that's what we need to do. You don't have to reinvent the pencil or reinvent the eraser, but you have to smartly put them together. Smartly put together, technology. Yeah. And see, another thing is, the first guy who invented the wheel did not make all the money. It's the other guy who put all the remaining 3 wheels. He made all the money. So that's just the applied part that requires you to think like a businessman, right? You have to think like what's the right word? You have to be
entrepreneur.
Yeah, you think like an entrepreneur, exactly. Think like an entrepreneur, because this is the age and time. Don't miss this. You don't have to take entrepreneurial risk, but think like that. Thinking is not expensive, right? Think like that. Have that mindset. So you'll be able to go into a meeting and then you'll have the confidence to deal with that requirement, because the requirement is going to be on the business. Because there is business. Business is run by processes. Processes are built by systems. Systems are developed by technology. And that's how it goes. So if you're on the technology side of things, you're not going to be able to understand the business part of it. So go into think like an entrepreneur, then you'll understand business. But then you have the innovation process, which drives the business. So you have to, and that has to have innovation just to make sure you are different from anybody else in the marketplace. That's the part I thought I'll share that. From a destination point of view, I think the there is no limit to what you can do. I don't want to be self-bragging, but I'm saying it helped me a lot, and there's no reason why it can't help anybody else. So you see the wealth of knowledge that I gained across different verticals, aerospace or healthcare or banking, BFSI, especially risk space.
Domain functionality.
Yeah, I was able to combine that primarily because I've had CTO level, CIO and CTO level roles for 10 plus years. But it's also because I had that mindset of, hey, let's learn and then solve the customer's problem rather than just looking at that as a technology. Sure. But I'm not holding anything against the technology, folks. You can still be very happy. I mean, be very good at one of the technology like AWS or Python or Azure. Just choose one. Be the very best in that space. You don't have to now worry about think like a businessman. No, that may not be for everybody, right? But what technology do you choose? Be very, very good at it, because everybody else will come for you. Because ultimately that's what I also do, right? I go to a client. I'm a jack of many trades, may not be master of everything, but where I am not good at, I will basically surrender. And I tell the customer and say, hey, let's work with your any other team guys who are better than me. If I see them, then I'll tell them I will not take that portion of the work. I will take the rest of the work. And then, but together work, have a good attitude.
Team. Yeah,
have a good attitude. And then see, we have trained, but also we have to treat others and us well. And once you do it, I think everybody will be, everything will work out. It's a journey that you're starting, right? And that's my answers to the three questions that in terms of
destiny. So it is also applicable to the youngsters. There's a lot of youngsters and students in this forum. So is it applicable to the youngsters who are going to make a career?
I am most scared of the youngsters because they can learn things faster. Today they
very
might
fast,
be, today they might be at the knowledge level, but they are like a sponge. They can learn things faster and code faster. See, ultimately, one of the limiting factor in this is comprehension and time. Comprehension in terms of, hey, can we understand it? Okay. And then second part of it is, and then at one point in time it will become difficult to understand, right? That's the boundary of our comprehension, our ability. Second part of it is time, because at one point in we'll run out of time. So if we are able to manage these two, youngsters can do because they have time and they have comprehension. And so they can compete with us much better than, yes, Ari, you're right. So.
Sure, sir. Thank you.
Anything else, Prasanna?
Yeah, so this is good. Unless you have any questions or.
No, I don't have any specific questions. Like, if the audience has any questions, certainly we can take it. If it's not, like, so we could definitely wrap this up.
Prasannaji, actually, Jyotiji read the mind of all 64 people who are attending the session, and he put it together in one summary and gave it to you.
Yes, yes, tons of these handling audiences, reading pulses. So he's very good at. Yeah, this is not the first time he's doing.
Yes, so I just want to thank you, Prasanna. Actually, so since the audience asked a question about there's a lot of youngster and how this program would help, actually. So I'm currently conducting an international hackathon for the American High School Fremont, correct? So this hackathon primarily focused on these areas, correct? So understanding students' ability in STEM, robotics, artificial intelligence, correct? So if anybody interested, they can contact me. I will get them connected. It's a deeper level learning, correct? So this is a team. So you could see this team. So this team is primarily focused on building robotics. And in terms of what level they want to go, like Prasanna said, sky is the limit. You can go any extent, any level, and I'm coaching them right now. So I'm the mentor for them, so I'm coaching them. And I also have another program right now going on. So this is with Northwell High School, Mexican, correct? So this is basically for the school students. So I coach them, teach them on how to build robots and how to deal with these kind of complex problems, either it's a STEM or working on some, environmental issues or something that what they want to solve, correct? Whatever problem they want to solve, so we help them to do this one. So for example, this the school student right now building a robot, correct? So I'm just trying to see the slides 1 second. So this is what I have given them, okay? So it's a conversation based. So what they were supposed to do as part of the hackathon, so they have to build in a chatbot, which is more on 3 types. One is a text-based, second is voice-based, third is knowledge graph. Right? So you give an image, I will respond to you. You talk to me, I'll respond to you. You write something, I'll respond to you. Okay? So this is basically provides the guideline for them to build, so which is we created. Correct? So we created and gave it to them. So in terms of school student, if anybody wanted to understand, if anybody wanted to go more deeper, get involved, so please feel free to contact me. I will get you connected with the right team. So you will know more about these things. Okay. All right.
Hi, Jyoti. This is Bhupinder. Hello. Can I ask you?
Yes. Please.
So that's wonderful. That's really good. But again, this is for the students. So do you have something like which is for the much more like professional, like, you know, who are like cross that student level? So if like I want to participate in those kind of courses, then is there anything?
Sure. As a company, our primary focus, as I told you, providing academic educational platform from schools.
You told me. Yes, you told me. But this kind of bootcamp or this kind of
Jyoti, Bhupinder, I think this is something an interesting opportunity because see, I work on that space, but I work with completely on the applied side of things, which is solving it for the industry. So there could be some area of synergy that we can explore and see how. Say, for example, senior managers, directors, or even senior engineers who are in the learning process of AI, but they are given a project at work and they have to fix that. You know, and it has to be industry grade. Right? That's the important part, right? They can't say I'm learning, so I'll come up with something of lower standard. So that's an area that I think there's a lot of demand that I'm also seeing. But you can work out the model where if any of them who are currently working on a product and they want to make sure there is this gap that exists between their skill set or the team skill set and then the project requirement, that's a skill that we can actually help them fix it. Because that's monetarily also will be very interesting, and also from a different problems. I'm good at solving problems, Tenali Raman style. So we can solve those problems, and then anybody can develop. Today, coding is not the challenge. Today, the key will be to come up with the most efficient. It's not about the resources, it's about being resourceful. So you come up with the most resourceful solution, an industry grade solution for a problem, and add that innovation element aspects to it. That's why I'm thinking like out of the box, but there's a possibility there.
That's the reason I asked you about your email ID, Prasanna. I sensed that in the first conversation of yours.
Oh, okay. So yeah, so when Jothi, I mean, we can see if we can all collaborate and in that way.
Sure, Prasanna. So, like, you know, so I personally don't have any time, correct? Like, you know, so I'm heavily involved in many other things. I don't have time to do such things, but certainly if there is anything that you think I could add value, I can help or I can support as needed. Sure. So there are certain commitments that I already have. So like I'm involved in UC, I'm involved in many other universities. And it's just so too much for me to handle at this point. Actually, certainly I can help you, but I don't see myself getting into too deep in that kind of roles. Okay.
Sure. So, right. Yeah, I mean, Mr. Reddy or any of those who have requirements to fix that gap, because that's not something that's going to be fixed by anybody. Now, I don't think going to university is going to help fix it, or your company will send you on a training, but still there's going to be a gap. Yeah, so yes, I see that as an opportunity. Yeah.
Thank you. Kindly share the information. We will reach you, Prasanna. Thank you very much.
Sure.
Okay. Thank you, Prasanna, once again. As always, we appreciate the community support. As always, we appreciate the things that what you bring to the lives. Like, you know, so in terms of like your experience, products you built, solutions you developed, skills that you gained. So these are all so valuable for the audience to get to know. Once again, thank you so much.
Thank you, Prasanna. Thank you, Prasanna, for coming, you know, and helping the team here, like, and creating the awareness along with Jyotiji. It's greatly appreciated. Yeah.
All right, let's move on. Correct, like, you know, so where we stopped, let's start from there and then go deeper into this one. So we kind of stopped this place, like, you know, so in a Lerman time, why do we need to understand machine learning and what it does? As we talked about, no matter whatever we talk, whatever we understood, it's all coming down to software engineering, correct? The core software engineering. Modernize the software engineering, reinvent the business application that you are trying to develop or maintain, correct? So it's going to come down to that level. So for that, we want to dive deep, correct? So let's understand in a simple, basic, very foundational level learning, okay? How to build a machine learning model. So what I'm taking about a simple machine learning model, which is basically like, a problem to be solved, okay? So Prasanna did mention that classification, gender classification. How do you take a set of images or a data set, correct? And classify whether that is male or female, correct? Why do we need this one? That's just an example to learn, correct? So this is basically a learning purpose. Real world, that could be one of the problem you can tackle, but that's not the problem, only problem that we solve, correct? Only problem solved. And also, it is not the only model we want to implement. There could be many models, many complex models you will be implementing. Okay, so but we need a starting point. So that was a question that I asked Prasanna, right? Like, where do I start? Right? So I understand all the things. I understand things that happen around. But if I want to be hands-on, if I want to be a data scientist, if I want to be a machine learning engineer, or if I want to be an AI engineer, where do I start? Okay, where do I start? So I would simply say the best place to start building simple machine learning model. Start building simple machine learning model. Again, I repeat, correct? That is a good place to start. So how far I want to go, it's up to you. If you want to be a project manager or a management person or a strategist, you don't need to code. Okay, you don't need to code. Okay, so it is your goals and objective. You define what you want it to be. If you want it to be a deeper, hands-on subject matter resource, correct? The subject matter resource could be by title anything. By title anything. So if we want to be a hands-on subject matter expert, and this is what we have to do. All right. So now how do I implement? As I said, so this is not a real world application. It is a starting point, someone to get started to learn these things. So the first step is understand the problem. Okay. Second, set up the development infrastructure. Example, if you are decided to go with the Google Colabs, understand that. Okay, then there is a specific library that we will be using. Okay, it could be scikit-learn, it could be TensorFlow, it could be PyTorch, etc. Understand all those things. Then data engineering, which is fundamentally most critical skill, most difficult skill, correct? I can even build models very quickly, but I cannot bring data very quickly. Let's say in a project of 100 hours, in a 100-hour project, correct? It could take minimum 50 to 60 hours on data. Remaining hours will take the other activity that you will be performing on model side. Okay. So the third step, what we are going to focus on, once we set up the development infrastructure, data engineering. The next is model engineering. How do we develop the model? How do we train and test and deploy the model? Correct? How do we analyze the model outcome, etc. The last is the model is deployed. I want to analyze the outcome and see how it's performing. This is just a high level, and it is primarily for training purpose, learning purpose. Correct? This is where we start. So we know the problem, what problem we are trying to solve. We spend time. So we have a simple training data set which we want to use. Here I have training data set which describes, correct? Like I said, it describes someone's what's the height, what's the weight, what's the color. Based on that, it tells whether it's male or female. Again, it is primarily for learning purpose. It's not any practical problem solving. Understand the basics, understand how this works, correct? That's all it does. So I'm going to use this to train the model. Then I'm going to give this test data to ask the model to predict whether the given data belongs to male or female, etc. As we discussed, this is one way to look at it. The second way to look at it, instead of giving this kind of data, I can actually give the image itself. Okay, I can actually give the image itself, correct? So I looked at so we could look at male images, correct? So there are certain number of male images, female images. I can give this images and get this one. As we talked about, don't give a text-based, character-based data. Give the actual image, let the model. We also going to do that one too. Okay, we also going. So there are many different ways to do it. So the goal is to basically take this data, train the model, and ask the model to predict this one. So that is what we want to implement. So from that perspective, so we are going to focus on the Colab. Okay, we are going to focus on the Colab. So where we started, this is where we started. Okay, where we started, this is where we started actually. So there is more insights behind the scene why we want to collab. Collab provides a collaborative development environment. If we have a team of 5 people, 10 people, whatever the number of people, if you want to collaborate and work together, you can use this platform. And second, as I told you, so this comes in a different flavor. One is a hosted infrastructure. That means it is already installed, configured, ready to go. We don't have to spend time. That is what hosted infrastructure. Let's say your company already have a cloud infrastructure, which is on Google Cloud. If you want to connect and work, you could do that. You set up something on local, and this is where it comes to Anaconda, Jupyter Notebook, etc. You can connect and use them. And these are the resources available. You can check the resources that has been available, correct? So like this, there is a lot more involved. Spend time, understand based on your interest. You can also configure runtime. So the runtime could be like, so there are different options available runtime to look at what we can do. So this is basically tells you, correct, so what, like 1 second. So there are options available to set the runtime, actually run selection. Okay, 1 second, not that I wanted. Change runtime type. So here you could see gives an option to work with GPU, right? Let's say I have a large image to be processed and I have large tensor to be processed, TensorFlow I'm using, right? So it gives them a different option to choose this one actually, like, so based on what kind of things you are trying to run, you can set up and do all those things, correct? So spend some time, understand this before you go here, actually, it's important, correct? So as I said, if your data is in Google Drive, you can mount and bring the Google Drive here, correct? So you can click of a button. So all of those are possible. Okay, so what we are trying to understand, how to build a simple machine learning models. So before we go, we have to understand certain terminology. What is features? What is labels? What is training data? What is test data? What is source data? What is target data? What is model outcome, model desired result? All these things as a terminology, you must have to understand, correct? So this is some extent we understood, correct? So what is features? This is what the features are, correct? So height is a feature, weight is a feature, color is a feature. Based on this feature, I'm trying to understand whether this is belongs to male or female, correct? So this is just a feature for me to understand this many height, this many weight, this color, it's female. This height, this weight, this thing, male. So like this, I can understand. So these are all called features. Okay, these are all called features. Labels, that is my target. That is what I wanted to predict, correct? So if we go back to the Excel spreadsheet, so based on these features, I'm telling this is male. The word male or female basically represents label. That's called the target. That's called the target. Okay, understand this one. Training data, the data that is going to the model where the model can learn, that's called training data. Okay, test data, the data that what I give to the model and expect the model to predict. If you notice the difference, in the training data, you have the label. In the test data, there's no label, right? So that is basically what a test data means. Source data, a training data is nothing but your source from where the data is going into. Target data, so this is the target data that I'm giving to the model to be predicted, actually, correct? So like this. Then model outcome, whatever the model predicts, that's what it is. So understand the terminology. The second thing, what I talked about, setting up your development infrastructure, correct? So if you noticed, so once you understand problem statement, setting up your development infrastructure, correct? So what model we are going to implement, we'll get to that point. So setting up development infrastructure in this case, like, so I already have Google Colab, that's where I'm going to build. So in the Google Colab, already I have scikit-learn installed. What is scikit-learn? It's a machine learning framework. Okay, so this is basically an open source library, like PyTorch, like other machine learning frameworks, such as like TensorFlow. So scikit-learn is one of the simple, easy to use machine learning library. You could understand this by browsing this one. So what I'm trying to see, I'm trying to basically import many different libraries which is needed for me. Okay, which is needed for me. So that is my first step. First, import the relevant library. Okay, so this is basically tells me these libraries are required. All right, what is tree? It's a decision tree. What is accuracy score? That is basically the percentage of the accuracy model predicts. And what is this one? I'm going to implement a k-neighbor classification, logistic regression. So this is basically like, different model I want to implement. Then what does this does? This is basically, I want to play with the data. Which data sets works well, correct? So I don't want to do any manual process. I want to use an automatic process to split the data. Okay, so when I say split the data, so I'm talking about my goal is to arrive this state, correct? So I wanted to basically take data sets and I'm going to give this input. I'm expecting this output, correct? On a combination under what combination, correct, I'm getting this curve. Okay, so I have to play around. So in order for me to get this one, I have to, like, my first time I have it, the curve is here. Second time I'm bringing down. Third time I'm bringing down. Fourth time I'm bringing down. This seems to be an optimal one. I want to arrive this one. In order for me to achieve this one, I have to split the data, which I'm doing here. Okay. So basically, what is this? Scikit-learn, it's a machine learning framework. Okay. So if you don't understand Python, it will be so difficult to follow. Okay. It will be so difficult to follow. So this is primarily Python-based implementation. You could also use Scala. You could also use R. It's up to you. But what is widely used and how it has been implemented, this is how it's been implemented. So once I have the library, the next what I want to do, I want to basically have the data. So I have it here, features and labels. Okay, if you see here, whatever I have it in the Excel file, I brought in the form of features and labels, correct? So in this one, you see features, in this one, there's the labels. And that is what I have. I commented out, I will explain why I did that actually, correct? You see this one, it is a features. This basically tells the height, weight, and feature. It's a list of lists in Python. This is a list, and inside a list, you have list. That's a data sets, correct? Number of rows. Okay, so that's what I have. And the labels for each of this list, what is the label? So for this, it's a male. For this, it's a female. For this, it's a male. Like this, there are 8 rows. Okay, if you see how many rows I have, so I have 8 rows, correct? So if you see here, so the number of rows, I have 8 of them. Okay, so for the 8 row, so I'm going to implement this in this form of, like, a Python list arrays, correct? So I have, this is what it does. So the reason I commented this one, so you see this one, these are all strings. I'm converting this into an integer, correct? So this is an encoding. We will cover this later. So, but first understand. So I have features, I have labels. Okay, all I did, so I took the Excel spreadsheet, I transformed into Python list. And in the list, I had values such as black, male, female, etc. So these are all character. I transformed this into 0 and 1. Okay. So for example, black, it's 1. White, it's 0. Correct. Something like that. Correct. So you could use anything. Correct. So you could do encoding. That will come to this one. And same here in the label, I have male and female. I transformed it to 0 and 1. All right. Then I have test data. Then this is my desired outcome. So basically, I'm going to give this for the model to learn. And this is, I'm going to use the model to be tested. So when I give this one, I expect the model to predict this one. This is my desired outcome. If it happens, I'm going to accept it. If it is not, I have to fine tune. I have to rework. I have to do some lot of, like, cleanups. Correct? I need to figure this out. So going back here, what step we are in? So this is our step number 1. Okay, this is our step number 1. So what we have here, so this is our step number 1. So which is setting up your development infrastructure. All right, I'm done with this. Okay, the second step is bringing data together. Okay, as I said, it is primarily learning purpose. So you don't have to worry about other things now. So once you understand, you can figure out. This is step 2, data engineering. Okay, step 2, data engineering. So in the real world, as I said, this is much advanced. Okay. So this is for you to make you understand. This is what I'm doing step 2. I'm ready with data. So what I have, so this is my training data. This is my training data. Okay, this is my training data. And this is my test data. By looking at the label, you can the variable names, you can understand it's my test data. So what is my step number 3? Model engineering. So I'm going to start implementing the model. Okay, I'm going to start implementing the model. All right. So let me start from the very first model that I want to do. In this case, a decision tree. Okay. In this case, a decision tree. As we explained, correct. So this is model is nothing but, okay. In a simple, easy way to understand, a model is nothing but, you could call either a classifier or a model. It's like a function. So this function basically what has, it takes the features and gives the labels. So how does it does? Based on the rule what it learns. Okay, whatever it learned, based on that, when you give a new data set, okay, first it learns. Once it learns, it's become like a function. It becomes like a model. In the model, you give a data, okay, which is not seen by the machine. Take that as a feature and then create the labels. Okay? So that's what it does actually. So I'm going back, that's the step. So for that, I have three different models. Okay, so why I have three different models? Because I want to know which model performs well, which model comes very close to accuracy that what I'm expecting. Okay, so I commented out. I am just going with the first model. In this case, decision tree. Okay, so this is a decision tree model. You can see this one. Correct. So this is coming from tree. So where is tree? It is from the scikit-learn. So from scikit-learn, import tree. So that's a statement which basically let me to import this particular model. So this is called the model or a classifier, whatever you call. So I'm calling it model or a classifier or a built-in function in scikit-learn. However way you want to call it, it's fine, no problem. So I commented out everything, then I'm moving on. So now the model engineering part comes into picture. So first step is I initialize the model, which is in this case, decision tree. So now I want to train the model. How do I train? That's what this method does. The fit method train the model. It takes the features, it takes the labels and make the model to learn. So what the model is to learn, as I explained, like this. Height is this, weight is this, color is this is female. Height is this, weight is this, color is this is female. Height is this, weight is this, color is this is male. And that is what this does. The fit method, what you see here. So this is basically train the model. This is basically train the model. So I'm training the model. Okay, so model you can imagine like a function. The function takes arguments and returns certain labels, right? Returns some values, right? So in this case, I'm passing the training data, which is basically the features and labels. So now the model is fully trained. Now the next step is, okay, predict the model. This is testing or the model prediction. Okay, model prediction. So I'm going to call this a model prediction. Okay, so this is basically the next step where the model, based on what it learned, now it's going to predict. Okay, if you notice, this is basically my classifier. In the classifier, I'm calling this fit method. In the classifier, after learning, I'm calling the predict method. When I call the predict method, I'm passing the test data, which is this guy. Okay, I'm passing the test data. So based on what I'm passing, it's going to predict. So then I'm printing the predicted outcome, which is this guy. The next is accuracy. And what accuracy? Okay, what is the accuracy level of this prediction? Okay, so this is something that we wanted to use. So for that, I'm using a function accuracy underscore score. Where is this function? So this function basically comes from in a scikit-learn, another library called in the scikit-learn library, there's metrics, correct? So this module basically gives accuracy score. So you can see it's a function. It takes certain arguments, it gives you back. So coming back, what we done? So we done three things. One is we were able to tell what model we want to implement. In this case, I told I'm implementing a decision tree model. Then I'm training the model. Then I'm testing the model. Then I'm writing the model outcome. This is model outcome. Okay, this is model outcome. And then I'm understanding the accuracy. Okay, understanding the accuracy. Okay, this is my accuracy. So this is the accuracy percentage. What percentage of this accuracy it does? Okay. So let's run and see this one so that we could understand. So I'm trying to run this one, it tells me. So based on what I'm doing right now, so I'm training the model using this data, okay, which is features and labels, which is happening here, line number 41. All right, that is done. Once it's done, I'm running the prediction, which is a test in the model, how the model is turning. Now the model is going to be given a new set of data, which you never seen this one. In this case, I'm passing this data, line number 32, which is basically test data that goes into the prediction. Once the model is done, I'm writing the model return outcome into this variable. I'm trying to print this one. Once I print this one, I'm going to find out what's the accuracy. Okay, so these are the last print statement you could see here, correct? So this is basically model outcome. So I can say this is model outcome. Okay, this is model outcome. So I'm just going to call this as the model outcome. Okay, so that is one thing. The next one is basically like, so this is not the model outcome. So this is the model accuracy. I'm just going to call. So this one, the one below is the model accuracy. So I'm going to call this model accuracy, which is basically like, what I wanted to see. So now what you notice, the model is not performing well. Okay, why? It could be many factors. It could be a factor of doesn't have sufficient data, it doesn't understand. So you can see this model outcome, this model accuracy. All right. So now what I want to do, how do I improve this one? Okay, how do I improve this one? So the first model, what I implemented, decision tree. All right, I'm going to switch the gear. So I feel that model is not doing well. I'm going to basically implement another model called K-neighbors classifier. Okay, neighbor classifier. Okay, what it does, we will explain, understand this later. So these are all you could call, it's a function already built in. Okay, all it does, it basically takes an input, gives you back an output. Correct? So takes an input, gives you back an output. Correct? So in that context, I'm going to go ahead and run, see what is the accuracy of this model. So right now, what model I'm implementing? K neighbor classifier. Okay, so this also give me the same 0.75. Okay, all right. So this is not working out. I'm going to change this to different model. In this case, I'm going to use logistic regression. So that is another model. It comes from this particular library, linear model. You see this one, linear module. This is a neighbor one, correct? So I am able to do this one. I'm going to run this and see what it does. It's again same thing. So now at this point, what can I do? My goal is to reach 90%. Goal is to reach 99%. Correct? So now I need to work with the data set. I want to split the data. Okay, I want to split the data. I want to work with the data sets. Correct? So how can I do this one? So this is where you have the method, like, you know, the split method comes into picture. Right? So you can implement this one. Okay, so train and test split method. Okay, so what exactly this method does? So this method takes the data and split into two sets. Correct? So these are all steps you go through. Like I said, it's up to your interest how far you want to go. As I said, okay, so what is that we are trying to achieve? We are trying to achieve, take this equation, y equal to mx plus c. We want to solve this one. So x is the input, y is the expected output. Okay, so based on the input and output, this graph will move around. Okay, goal is to arrive on optimal graph point. So for that, I'm going to split the data. I have the training data, I have the test data. So I wanted to basically split this one actually. Like, you know, so this is basically x train, x test, y train, y test. I want to apply this one. So take the data set and split it and run this one, correct? Because I was trying to implement different model, it didn't work out. It didn't work out. So I want to implement this training and test split. So that's basically here. So whoever interested, I'm giving that as an exercise for you to work on. Okay, I'm giving that as an exercise for you to work on. So I will share this Colab notebook. You can take it, you can work on. As I said, you don't have to reinvent anything. Just understand how this works. If you understand how this works, I would say, okay, you gain a lot of confidence. You really gain a lot of confidence. If you don't understand how this works, this is where you speculate. Okay, you speculate. What you speculate? As I said, people doesn't know what is artificial intelligence, what is machine learning, what is deep learning, what is data science. It's all kind of mixed. Okay, everybody have their own view on each of these things. Why? That's because lack of knowledge. They don't understand, correct? They don't understand, correct? And that is why it is. Okay, if you go out and talk to people, AI, ML, DL, all these things, correct? So I don't know what context they're talking about. So it is purely lack of knowledge. So I would strongly recommend, if your goal is to want to be a hands-on person, if you wanted to understand this one, the starting point would be build very simple, basic machine learning model by yourself. For that, you need Python skill set, at least Python skill set. So if you have such skill set, I would strongly recommend go ahead and practice. Okay, so there are two things I'm asking you to do. If you're not able to do, that's fine. We can cover this tomorrow. So number one, apply the split method. How do you split the data? What do you have? Take this data set and split this data set. Okay, so we split the data set and see on what data set the model is performing well. Okay, so second, in terms of if the model is still not performing well, there is a next concept called hyperparameter tuning. Okay, so tune those parameters. Understand. So what we are trying to do. So these are all steps that is involved. Okay, so this is model engineering. Okay, where we are training, testing, deploying model. The next step is model analysis. Model analysis. Analyze the model. Okay, so what am I analyzing? Okay, this is model analysis. Okay, analysis. And optimization. Okay, I'm optimizing the model. So what does this mean? So the model is not performing. I want to optimize this model. Okay, I want to optimize this model. So that is step number 4. That's what we talked about. So if you look at the PowerPoint, it starts from understanding the problem. Second, build your development infrastructure or import any library that is involved. Second, work on data. Prepare your training data. Prepare your test data. Okay.
In this case, we are talking about the features and labels, and test data and decide outcome. All right. So now I'm going into the next step, model engineering. In the model engineering, what I'm trying to do, I'm trying to basically doing which model to implement. So there are several models that I'm considering. I'm going to start with the decision tree, then K neighbor classifier. Then I'm going for a logistic regression. What is these are all? So these are all pre-built functions you could imagine in the scikit-learn library, and this is basically what you are trying to train. This is like a black box. It takes input and learns and understands. Then when you give another set of data, okay, which never seen this before, based on what it learned, it tells you this is what I learned. Okay, the goal is to make this more generalized. Correct? So this will allow you to understand the overall framework. So here I'm doing model training, understanding which model to implement. Second, train the model. Next, test the model, which is basically predicting model. Then write the model outcome, and then see on what accuracy level the model is predicting. Okay, so that is also a function. You call this function. If you understand the function, you can do this one. The last point, I understood the model is okay, but it still need to be optimized. How can I do? And that is where these two methods come into picture. You split the data, okay, and then tune those hyperparameters that's involved. So hyperparameters basically like a way to increase the model accuracy, optimize the model accuracy. Correct? So that needs topic by itself. Correct? It will take some time to cover, but do not worry about all the things. Your goal is to basically solve this problem, which is you have a set of data. You wanted to make the model to learn, machine to understand, then you can do some prediction. Okay, that is the most simple, easy way to build machine learning models. So what we implemented, what we are trying to do, it's a simple supervised machine learning. That is the point I'm trying to say. Okay, so what I'm trying to say here actually, so I'm trying to say, understand the problem, set up some development infrastructure, in this case, Google Colab and any machine learning library, etc. And do data engineering, collect, prepare, make the data available, training data, test data, development data. Then do model engineering. So train the test and deploy the model and do analysis. The analysis what I'm asking you to do, if you are interested. If it is not, I can cover this tomorrow. So going back, what is these are all? So these are all simple basic steps involved implementing a machine learning model. So it is a supervised machine learning model. Okay, so that is basically what we wanted to cover. How does this works in a real world? Okay, so how does this works in a real world? So let me show some of the examples. Okay, so this is, as our Prasanna said, a customer churn. Okay, I can't bring this entire full solution line. I just wanted to give you some idea so that you could understand. Okay. Oh, by the way, in case if you are interested to learn more, and this I found to be more useful learning resource, it is also from scikit-learn. So you can see there are so many examples. Example 1, example 2, example 3. You can dive deep into the space. Okay? But to get started, as I told you, you have to be quite comfortable in programming. You have to quite comfortable understanding how to work with tools like scikit-learn, tools like Colabs and all those things. So I would start practice there and then go from here. So what I wanted to show, this is a large retail company. Okay, so they operate very much across the world. Okay, so what they ask us to do, they ask us to basically understand which customer is going to churn, when and why. Okay, so that's basically what it is. It is full-scale Google Cloud platform. It is built and hosted on Google Cloud. We are using Streamlit. Streamlit is an app. Okay, so it's basically extends to Python. It allows you to build smaller utilities. It's not like a full-scale solution. It's like a smaller utility. You could build this one. Okay, so this is primarily for learning purpose. It's not for an industry standard. So you can see what are the different libraries being used. Okay, so these are the libraries used. For example, Streamlit is one of the library. Okay, Streamlit is one of the library. Pandas. Okay, so etc. All these are a different library we are using. Then what model we are implementing? Decision tree, land of forest logistic regression. Those are the models, correct? And what are the different Google Cloud services? VM instance, compute engine, cloud storage, correct? So VM instance, that's notebook services, correct? Sorry, that's the actual the virtual machine that we are talking about, correct? So then next is compute engine, that's a notebook services. This is a cloud storage. That's basically what it is. Rest everything in library. All right. So going back here, let me refresh. So what this does, this is basically allows you to run the model, understand how it works. Okay? So as we already agreed, the world is leaning towards, correct? Do not code and leverage tools that is already available. That's where we are going. So it's asking you to select the problem statement. So what is the problem I'm solving? Okay, it is a customer churn. Who's going to churn? When the churn will occur? Why the churn is occurring? I'm going to choose who's going to churn. Once I select what's the problem type, it is important to understand. I will cover this tomorrow. So what is the problem type you are solving? It is basically a classification. Whether this customer is going to churn, yes or no. Okay, there are three types of problems, correct? Number, who's going to churn? Second, when is it going to churn in next 30 days, 60 days, 90 days, etc. And last, why the churn is occurring? Okay, not happy, or it could be many reasons. Okay, the product issue, service issue, pricing issue. It could be many factors, correct? So we need to figure this out. So let's start understand. The first one is basically who's going to churn. What kind of problem this is? It is a classification problem. Why? I'm trying to classify. Yes, the customer is going to churn. No, the customer is going to not churn. Now the next thing is model selection. What model you want to implement? Decision tree. What exactly means? This is what we implemented. Okay, this is what we implemented. If you noticed, it's a custom code we built. Correct? If you noticed what we implemented, there are model we implemented. So the number one model is decision tree. Number two, k-neighbors classifier. The next is logistic regression. So it depends on what model you implement. You can choose the model. Okay, you can choose the model. Okay. So what I'm trying to say, so this is basically the model we want to implement. Okay, so the model that we want to implement, decision tree. All right, I'm done with this. Now what it does, behind the scene, it creates a source code. Okay, behind the scene, it creates a source code. You see, whatever I coded, it automatically creates here. So you don't have to really worry coding part. It's up to you, but I would encourage you to code. I would encourage you to code. That's the best way to learn. Otherwise, you can talk, but you are not confident. You are not really confident, correct? It just, you are speaking some abstract concepts, correct? So I would encourage you to code, but there are tools available. You could build this one. All right. So next, it's asking me, give me the training data sets. Okay. So for the demo purpose, I will pick up the training data as sample data sets what we have. So I have it in a specific folder. I'm just going there. Okay. So I'm going to go there and then select this one. So this is basically, okay, the training data that I have. So these are the different data I have. I'm just going to select, give me 1 minute. So this is the training data that I wanted to use. I have the data sets available. So I'm selecting this one. All right. So now it brought the training data. It basically asking me, would you like to see the sample data that what I brought in? Yes. Click here. You will get to see the data. Okay, it's going to show the data that's what's been loaded. In the data sets, I have a customer, I have a product, I have purchase date, I have gender, I have service start date, quantity, price, extra, etc. All this informations I have. Okay, so this is the training data I want model to learn. Okay, I want the model to learn. At the last column, you see it basically tells whether this customer churned or not, based on the historical data. Under this condition, the customer churned. Under this condition, customer is not churned. Okay, done deal. So now I brought the training data. The next, what is asking, out of this training data, which are all the features you want to use? Select this one. I want to use the customer product date. Okay, I want to use customer product date. Yes. So I will come to your question. Okay, so give me 1 minute. I'll let me finish this one. All right. So you need to be very meaningful in terms of what feature you are using. Okay, I'm going to select product, I'm going to select center, quantity, price, service call, etc. So I'm going to select these features. Okay, I'm going to select why. So this will allow you to test, analyze the model, and then what feature the model is performing well, under what feature the model is learning well. I want to see that. Okay, so now I selected, I'm going to see extract features. It's going to take these features. Now what the model is doing, in this given data set, correct? It's going to basically use only these features: purchase date, service call, service failure rate. It takes this one. Now go ahead and train the model. Go ahead and train the model. So now the model is getting trained. All the things what I coded, it's built here itself. Okay, it's built programmatically using this app called Streamlit. And this is what expected you as a machine learning engineer when you go onto the field. Okay, build simple prototype, show to the customer, see the customer how they're doing, okay? Understand this one. So model is trained. If you want to see the source code, it gives you the source code. Every step of the process, it creates source code, correct? You can get to see things that what I've done actually. So you could see there's a fit method, there's a predict method. So it does all the things based on how it does it, okay? All right, so now I'm done with this one. I'm ready to test the model. I'm going to click on browse data. Okay, it's going to basically let me to choose the test data, which is this guy. I'm going to run this model for the testing purpose. Okay, so now the model is ready. Okay, so I want to see the test data, how the test data is looking. If you see the test data don't have the last column. Okay, the test data, which is basically what is expected to predict, which is called the target, which is called the label. The test data doesn't have the label, so it's basically has all the data sets. So now I'm going to go ahead and test the model. Okay, so this is basically run the fit method. Okay, it's run the fit method. It basically gives, okay, so what it does, whether the customer is going to churn yes or no, probability of, okay, and what probabilities occurs actually, under what probability is not churn and what probability is churning out. Okay, it gives you this one. All right, so now I want to analyze this some more in depth. So I want to basically analyze this more in a graphical form. Okay, more in a graphical form. So this will allow you to create data visual charts. Okay, I build this visual charts based on this one. It tells you how many customers, what percentage of customers is going to churn, what percentage is not going to churn, and this tells you how many males and how many females is going to churn, and this is going to tell you in what distribution or what's the trend that you see in this one. Okay, what is trend? So the customers are churning because of product quality, service requirement, product cost. Correct. So based on the reason, it tells you how many gender and male, etc. Correct. So what I'm trying to teach you or tell you, so if you code by yourself, no question, okay, you will be awesome. You have full control on what's going on. If you are not able to code, there are tools available, and this is a tool we build. Okay, there are similar tools like based on what product or platform you're going to use. If you are using AWS, there is SageMaker. Okay, so there is SageMaker. Is what I was talking about. Okay, in the morning. So the current project that we are involved. Okay, we use two of those. Okay, so we use Vertex AI, which is Google platform. We use SageMaker, which is AWS. It is not what I am trying to demonstrate. It is in some level same. Okay, what I demonstrated, it's a custom built app. Okay, it's a custom built app. It doesn't have all the things what is needed. Okay? So here, what we have, it's a full scale platform. It has everything. So this has less coding, more of I would say setup and configuration. So this will allow you to build machine learning models without even coding. But in order to gain deeper skills, I would strongly recommend learn these things. So what we have done, we were able to basically understand how do we build a simple machine learning model, what is the steps involved in order to build them. Whether it is going to be a simple problem, complex problem, it doesn't matter. You have to have a library, you have to have a runtime infrastructure, you have to have model to be implemented, correct? Library, I took scikit-learn. Okay, so that is one of the library that we are going to use. Okay, all right. The second, we are going to use the actual machine learning models, what model we are going to implement. And third, what kind of computing resource or infrastructure we need. So that is must. Next, you start from the problem. So in this case, whatever problem you're going to solve, select the problem. So once you understand the problem, what kind of problem it is. In this case, I'm trying to classify whether the customer is going to churn, yes or no. Yes, this customer is going to churn, no, the customer is going to churn. That falls under a classification. It's a binary class classification because the expected target value, it's only 2, yes or no. Yes, the customer is going to churn, no, the customer is not going to churn. So based on that, I can say it's a classification problem. So once I'm done, select the model. Which model? Decision tree. So now once the model is done, then that part is done. I'm moving on to the data side. Okay, it goes on and on. So this is just one example for you to understand a simple supervised machine learning to classify whether the customer is going to churn, yes or no. Okay, one more example, then I'll move on. So this is language processing. What exactly it does? It analyzes the sentiment. Okay, it analyzes the sentiment of a patient. Okay, so when a patient go to a doctor, there's a conversation, there is a text exchange, correct? So the patient tells this and that, correct? So how do you take that text and parse and extract insights, correct? So this is basically a natural language focused application. So a natural language focused application means you take the patient sentiment or a storyline or the insights, analyze, and come back and tell what is involved, right? Come back and tell what is involved. And this is also a simple supervised machine learning, right? Simple supervised machine learning, understand this one. So I'm just going to select the file which has a data that what I need, right? It's a pre-trained model. The model is already trained actually, right? So 1 second. So this is the data I want to use for this one, right? So now I have the data available, okay? So now it tells me what I could do with this data, pre-process. That means I can analyze this data, remove if there is any unwanted text, if there is a text which I feel not required, based on my requirements. Then generate the sentiments, okay? So this generate the sentiment. Rank the sentiment. When I say rank the sentiment, so based on what the patient spoken or described, understand and rank them, okay? For example, okay? I have a severe headache, so that could be number 1 to look into it, okay? So I feel that I don't want to eat anymore, okay? So that may not be critical one, okay? So you could rank them based on the severity of illness. Severity of illness, we are ranking the sentiment of the patient. Now I'm going to do on a word count. Which word has occurred most frequently? What was this sentence involved? And what kind of things this was spoken? Okay, the next is, okay, so taking and build a chart in terms of so what is basically happened? How many times words, okay, all these different words that has been spoken. So we are going to basically rank them actually and tell them this is the number of words has been spoken and the number of words being naturally. And look at the model outcome in terms of what the model does. It's basically like where it's in a positive, neutral, negative, any type of sentiment you feel, it's going to classify and tell the doctor to understand this one. Okay, so this is a simple machine learning model. Behind the scene, what it does, it takes this text data, which is what we looked at, and then analyze the text in terms of extracting sentiments, which is basically what the patient is feeling about, what kind of health condition, disease condition, behavioral condition, etc. You can analyze this one. So what I'm trying to tell you, you could build these type of simple applications once you learned what we just understood from the lab side. And so in the lab, we were able to implement a simple machine learning model. So the example that I gave you, it is packaged with a lot of other content, other things, but in a nutshell, all it does, this is what it does. It could be implementing different model, or it could be implementing different type of approach, but in essence, it's implementing a simple supervised machine learning model. Okay. So we do need to understand when we say supervised machine learning, what is involved. But my goal for you to make you understand. Okay. So all you have to do, okay, all you have to do, it is very, very simple. Okay. It is very, very simple. I'm just going to remove everything. Okay. So what is involved? How many number of line of code is involved? Correct? So you could understand. Correct? I'm going to remove everything so that you can understand how many number of codes involved. Okay. So just to do a prediction. Okay. Just do a prediction. So I'm just going to remove everything. Okay, this is not required. Okay, this is not required. So I'm going to remove this one so that you can understand how simple this is. But it will take some time. You have to practice and understand. Correct? So you have to practice and understand. So to build a simple supervised machine learning model, correct? So remove everything. Okay, remove everything. So what is involved? That's all involved. Correct? So you have 2 libraries. Okay, from scikit-learn. Okay. In case, if you don't want the model prediction, you can remove this too. I don't want the model accuracy. I just wanted to understand, okay, the model prediction. That's it. Okay, I don't want to, or I'm not interested. I'm not worried about what percentage or what probability it predicts. What's the accuracy? I don't care. All I wanted to understand, okay, how do I simply train and test a model? Okay, in order to train the model, you call the fit method. In order to predict, call the predict method. Test the model, call the predict one. So that's all involved. So the number of lines of code involved, simple. Okay. So if you see this one, so that's all it's doing here. Correct? So you don't have to worry. It's not a rocket science. So if you see, 9 lines of code. You run the model, you see the outcome. Okay, the model is predicts. Simple, correct? So it is not a rocket science. This is the best place to get started. If you build one model by yourself, you understand how it works, that would give you a lot of confidence. That would give you a lot of insights on how in the world this is working. Then you can add everything later on. Okay, so it just takes 9 lines of code to do this one. So 9 lines of code. Even I'm going to decide outcome. I'm going to remove this. So if I take that out, it's just only 8 lines of code. That's it. So this 8 lines of code, what it takes to build your first simple machine learning model. Okay, so I would strongly encourage at least to learn these basics so that you have enough confidence in terms of how this works. Okay, all right. So this is one of the things I really wanted to cover, and I showed you how does it works in a real example, like how when you go on a project, like what is their expectation, what is people are expected to do. So they will expect you to build something at this scale, correct? So where you can see end to end how this entire thing works actually, correct? When I say end to end, how it works. So as a business user, correct? As a business user, I want to run this by myself. Okay, I run this one myself. So here, as we walk through, so the goal is what I would like to understand: who are the customers going to churn, when the churn will occur, and why it is occurring. I want to know all these things. All right. Then I want to go through this process. I also want to understand what features I can use and how do we train the model. I want to change the data. I want to use the chain. I want to change the training data. I want to change the test data. I want to run this by myself. So there is an expectation for you to build these kind of apps for a business user to use and understand these things better. All right. So this is one of my agenda. Okay. So let me quickly go back and what I really wanted to cover in the 10 minutes now. Okay, so we understood how to do the steps. Okay, so like I said, I will send you the Colab notebooks to your email. So once you got the notebooks, you can practice. Correct? So if you could spend some time, understand and practice, that would be awesome. Let's move on. So this is one of the other topic that we kind of discussed in the morning. Somebody was asking the question, like, so emotional intelligence, are we getting there? Correct? Answer is yes. Correct? These are all not my statements. What I have heard from industry, I'm just putting things there. So when you type intelligence, when you build intelligence, what type of intelligence you are building? Solve a problem. It's very narrow focused. Solve many problems using one solution. General problem, general intelligence. Correct? The next is you don't have to train the model. Correct? The model is well enough to do its own thing. Correct? So that is what we want to get to ultimately, super intelligence. When you build different type of intelligence. Okay, when you build artificial intelligence, there are different types. Okay, so there are different types. When I say there are different types, you solve one problem. Let's take an example, correct? Like let's take an example. We have a recommendation system. The recommendation system, when you go to Amazon website, it tells you, okay, the customer who bought this product, they also like this product, they also bought this product, they also interested in this product. Okay, it's just a recommendation. How does it know? It knows based on your purchase history or people who have similar interests who bought the same product, maybe like you. I'm an Indian, I'm an Asian, I'm at this age. So people who have this similar interest may have this interest. In the customer profile, I'm connected with many different people. They all like this one, I may like this one. It's kind of built an algorithm and then comes back, tells this is a recommendation. So my question to you, so let's say I have a recommendation system which built for Amazon. Now I want to take the same recommendation system, put it in Walmart. Do you think that's going to work? Can anyone answer this, please? I have a recommendation system which is currently working in Amazon. Okay, so when you go to Amazon website, it tells you customer who bought this product, they bought this one, etc., etc., etc. I want to take, because very much whatever product you see in Amazon, I could see the same product in Walmart, correct? Example, correct? So I want to buy a television, correct? Which is available in Walmart, which is also available in Amazon, correct? So what I build, can I take and deploy in Amazon? Can anyone tell me?
Yes, it can. It can be done.
Okay.
You have to retrain the data model, right?
Answer is no, you cannot. Okay, why you cannot? The underlying data structures are different. How you read and write data in Amazon could be different in Walmart. But the goal is what? We want to get there. We want to get there. Okay, we want to get there. Why? The model which learned on the data of Amazon may not know the data that comes from Walmart. Okay? Walmart. So we want to build a generic model which understands both. So that is what we wanted to go. That is what we wanted to go. Let's take another example. It is a very classic example. If you look at all the auto manufacturers, whether it's a BMW or Lexus or any other company that for the Porsche, any company name, correct? All these companies are big time into autonomous vehicle, big time into autonomous vehicle. Why? So that is the competitive market space, correct? That's a very competitive market space. Like Tesla, their marketing, their cars are autonomous, fully autonomous, semi-autonomous, correct? So when my competitor in that space, I do want to be in the same space. So what happens now? Everybody's building the same autonomous vehicle. But if you see the rules and regulation, it's not going to change. The rules and regulations still remain the same. What does that mean? Okay, so when you see a red light, stop. When you see a green light, go. When you see an yellow light, slow down, correct? So these rules, doesn't matter whether you drive Porsche or BMW or Lexus, it's all still the same. You look at another way. I'm a driver. I got a license. Is this license given me to drive only BMW or Lexus or a Porsche? No, I can drive any car. I can drive any car. If such, correct? So I have to go and get a license, correct? Like, so if I'm not allowed to drive any car, then I have to get a license for each and every car. So if you look at here, so what is happening in the auto manufacturer? So these manufacturers building their own autonomous vehicle. But it would have been so nice if the autonomous engine is a generic model where it understands all the rules and regulation of road condition and it works on each and every manufacturer. Okay? So what does this mean? It's a one solution for many problems. So the problem that what is BMW is trying to solve, the problem that what is Lexus is trying to solve, or the problem Porsche is trying to solve, same problem. So why we have several solutions for the same problem? Why can't be one single model, an autonomous model? It works regardless of the manufacturer or the make. Correct? Why? The underlying road condition still remain the same. So industries wanted to go towards building a generic model. A model understands, correct, the rules and regulation of circumstances or infrastructure wherever you're going to deploy and functions based on where it is deployed. Okay, you don't have to build based on specific make or vendor or a product, regardless of who's the vendor, who's the manufacturer, who's the location. It has to function by itself based on the rules and regulation that is involved. So what I'm trying to say, industry right now heavily focused on building narrow intelligence. Industry want to go more towards general intelligence. In both the cases, you have to train the model. Okay, where we want to get to ultimately, we want to get to super intelligence. Okay, when it's a super intelligence, no training required. Okay, so over a period of time, this is where we talked about emotional intelligence, right? Emotion comes out without any formal, informal training. You see something, you enjoy it. You see something, you get involved. You see something, you react quickly. So these are all emotion that comes out of you, right? So how do you build such emotional intelligence? That is where industry is leading towards, right? That is where industry is leading towards. So what I'm trying to say, right? When you build artificially, when you create intelligence artificially, you could create narrow, you could create generic models, you could create super models, right? So generic models, narrow models, super models, these are the different type of models you build, right? Again, it is not my way of looking at, it's just an industry projection. So people are basically where we are. In 2020, we are kind of focused on narrow intelligence. Then we moved on to general intelligence, building a generic model. Ultimately, we want to get to the super intelligence. That's just what I read and noticed. It may or may not be true, but I'm just sharing with you. When you build intelligence artificially, that intelligence could be solve a problem, or it could solve many problems, or it could solve without even any training, right? So that's where we are heading towards. That's where we are getting towards. Okay. One last point, I will stop here. Okay. So bottom line, it's all coming down to skill. Okay. As I said, if your goal is to want to be hands-on person or a manager or get to know this well, okay, it's up to each one of you. Your interest is different than somebody else. Your goal is different than somebody else. Your expectation could be different than somebody else. But whatever goal, whatever objective, whatever things you have in your mind, it's irrelevant at this point. What is needed based on your level of involvement, you could decide what level you want to go, right? So when I say level of involvement, I am enjoying coding. I want to code. I also enjoy being a subject matter confidently talk anything. I'm also interested to know on the business side, correct? On the strategy side, I want to develop strategies. I want to develop business. I also want to be very hands-on. So it's all matters the level that I want to get involved, correct? So one is understanding high level speaking is different. One is going in depth and dealing with this is different. So let's assume your goal is to become a data scientist. Your goal is to become a machine learning engineer. Your goal is to become a data engineer and cloud computing professionals, correct? These are the things you want to achieve. In my view, correct? So there's no right or wrong answer. As I said, artificial intelligence reinvents software engineering, correct? A new approach, new methodology, new architecture, new technology. That is what drives right now. That is what drives right now, correct? So for this purpose, okay, in my view, correct? I'm not saying on the surface. In my view, the number one, you have to understand what industry you are going to focus on. Okay. Second, learn to the deepest level data skills. That's where big data IoT comes into picture, correct? In my view, it's a very so difficult skills to understand, correct? So working with structured, unstructured, voice, image, videos, correct? Building data pipeline, all these things matters. So this is basically the skill that what we talk data engineering. The next is model building, correct? So understand the model engineering, do model analysis, build model pipelines, correct? The next is computing power, working on a cloud, building microservices, dealing with technology like Python, Spark, and etc. Correct? Understand this one. So on the surface, without anything about your goals and expectation and where you want to go, in some capacity, if you want to be in the space of artificial intelligence, which underlying covers machine learning, underlying covers data science, everything that is involved, it's going to be covered under this, correct? If you want to be an applied artificial intelligence professional, correct, a subject matter resource, in what form? In the form of a data scientist, in the form of an engineer, in the form of an automation professional, correct? Cloud computing person, whatever the case may be, data engineer, correct? So the skills that is involved, these things, understand business, understand data, work on models, do compute, which connects all the things, correct? So that's just my view. So you could expect an architect role, or a data scientist, or a data engineer, or a model engineer, okay, or an AI developer, or a programmer, or a project manager. All the things covers here. All the things covers here, correct? So this is at a high level, okay? As I said, each one of us have different goals, different objectives, different level we want to learn. That's up to you. But what is expected, you must have to know all the things, correct? You must have to understand why are we solving this, what problem we are solving, and why we are solving. What are the business benefits by doing this one, correct? Some extent you need to know that one. Then working with the data, building model, okay? Then doing computing on the coding side too. So all the skills are required. Whether you use tools like SageMaker, whether you use tools like Vertex AI, still you have to understand these things. If you don't understand, you won't be able to do anything there, correct? So these are all assumptions they make and build the products. Okay, they make, build the product. Okay, so this is basically what I thought I wanted to cover and stop here. All right.
Thank you, Jyotiji. It was a long.
Yes. If you have any questions, you can ask me. Okay, I have a few minutes. If it is not, we can talk on tomorrow. Okay. So, any questions? Please let me know.
Hi, Jyotiji. This is Surendra.
Yes,
and in order to learn, can you guide us where can I learn Udemy or YouTube or any other materials, all those things, or boot camps outside? What is the best way and economical way?
Sure. So the simple answer to this question, the best place to start, first identify what do you want it to be. Okay, example, I want to be a data scientist, because once we have the goal, then we can define the steps to get there. Let's say I don't want to be a data scientist. I want to be a data engineer. I really want to work on a very large complex data sets. Let's say I've been in industry for 15 years, 20 years. I don't want to get into very low level technical. I want to stay as a project manager. I want to learn strategy. Based on that goal, we can define what would be the right learning path and learning material, learning resource. So generic statement, I want to learn, would not help me, would not help you as well, because you also need to understand as a professional, as an individual, where you want to go. Right? If anybody asks me, my simple answer, no matter what I do, I want to be a good teacher. Okay, my answer, no matter what, right? I had opportunities to become a CIO of many large companies. I worked for 3 management consulting. I have degree from many different places, Stanford and all. I can go anywhere. But if anyone asks me, my only one answer, I want to be a good teacher who can teach complex concepts in a simple layman term and anybody can understand. That's my strength. That is where I wanted to be. Like that, you have to define what you want it to be. let's assume you want to be a data scientist. Then we can define what the skill requirement to get there. Then we can look for learning resources, right? So that is how I see this one. I hope that helps.
So I have some couple of year experience. If I want to go into the management role, and if I want to learn the concepts, so what is the best way?
Yes.
So how can I start?
Yes. So there is no one-line answer. So my best answer is I have to put some email and send it to you. Correct? If I simply say, like I said, I do teach at university. Correct? I do teach at University of California. I taught course at MIT. Correct? So these courses are meant for a different purpose, different audience. Correct? So once you said you have few years experience, you want to be management side. Correct? So I'm assuming when I say manager, either it's a project manager or someone who can work on consulting company like a McKinsey, Booz Allen, correct? Or Boston Consulting Group, where you do strategy work. You don't get involved in any low-level technical detail, correct? So if you are on that level, then we can find a course which covers that segment, correct? So that's why I asked you. So I will get back to you. Like I said, I don't have a predefined answer. You take this, then you'll become a management consultant. That's not an answer, correct? I'll go back and get back to you on that.
Jyoti, this is Prasad Tata.
Yes, sir.
If I can ask you a question.
Yes,
I'm so self-centered. My world revolves around the pharmaceutical research.
Okay, sir.
So if you can point me towards any book or a resource that helps me applying this artificial intelligence in pharmaceutical research.
Okay.
Can you shoot an email or message or something like that?
Yes, sir. I will share my email. You send me an email, respond to you. On top of my head, I don't have a book, how artificial intelligence applied in pharmaceutical, correct? So I did, interact with Novartis. I also interact with, other pharmaceutical companies, Bristol Myers Squibb. So I have some connections. I worked with them. I will check with them. But on top of my head, I don't see a book is written. How should artificial intelligence applied in pharmaceutical industry? I don't have it, but I can get back to you.
I work for Novartis, by the way.
Okay. Okay. Yes, I have been to Novartis US, as well as I was a guest speaker at Novartis Hyderabad.
Oh, thank you.
Yeah.
So I'll shoot an email after.
Yes.
Thank you.
Yes. Yes.
Hi, my thing is on 3 issues that we discussed so far, Jyotiji. One, coming to the labels for training data, is it always from past historical, tested results are the labels in training data, or are there assumptions also?
It could be assumptions too. It could be hypothesis too. So that's what it is. It could be facts, correct? So when I look at the data, the actuals, when I say actuals, even that has already occurred. Okay, that's what you're defining history. Something that happened in the past, so that you could say. Let's say I don't have any history. I want to simulate. When I say simulate, that's what we do, correct? So when I build the model, I don't have any data sets. I don't know whether I can even get the data sets. So we simulate by studying industry. Like, for example, the weather pattern that what I'm talking about, location pattern that what I'm talking about, for the air industry, we simulate the data. Going out, getting the data, it is sometimes it's both challenging. It may not even possible. So we simulate the data. So going back to your point, labels don't have to be a historical data. It could be simulated one. It could be hypothesis you develop based on certain factors, certain things.
How accurate that could be if it is hypothesis or what you have assumed so in the labels?
It's a good question. So the simulated data and the other data that what we are talking about, the accuracy is something that we have to create complex scenarios to test it out. We don't have one answer saying this accuracy is high or low or medium. Answer is no. So we have to test out all different possible scenarios, correct? So that is when we can.
Secondly,
so going back to, let me complete it. Going back to, so that is involved model analysis and outcome. Once the model is predicts, now you analyze the model. Okay, so that is where basically you see where the model is not performing. I'm giving right amount of data. I'm giving anything, everything. So now the question is, I can go back and change the data sets. I can go back and adjust the data sets. I can go back and fine tune this one. So all those points part of model analysis. So you have to basically analyze the model and come up with why it's not working. Is it because of the data? Is it because of the, it's not a historical data, it's simulated data. So the model is not learning and etc. So we have to come to this one. Then you can make a decision where to go and fix this one.
Okay. Now coming to the 0 and 1 for male-female replacement, are these aliases or is it a binary concept?
So it's like an alias. It's a encoding, correct? Like, so it's encoding. So it is basically, you don't have to use 0. You can use any number, correct? It's just a match.
So it's not a binary concept. It's just only a alias, right?
Yes. You can call.
Okay. Now coming to the Walmart. Sorry.
Yes. Go ahead.
Okay. Coming to the Walmart and Amazon and Walmart concept, because I do with both of them. Now, so whatever is implemented in Amazon can be implemented in Walmart because the product nature and product category is same. Only the underlying software technology on which they are working are different, but it can be implemented in both the cases, right?
Yes,
with modifications.
Yes, the recommendation system, the model which recommends, correct? You could build two model 1 for Amazon, model 2 for Walmart, correct? So that is same problem you are solving at 2 locations, correct? Problem 1, okay, in Amazon, which is a recommendation system, I'm implementing. Let's take a hypothetical example. So the problem 1 is I'm using a model called linear regression. I'm just throwing something, right?
Sure.
In Walmart, I can use similar model and I can implement. Correct. What I am talking about, a model which is already built and pre-trained on Amazon data. Take that pre-trained model. Do not build anything in Walmart. Directly deploy in production. Okay. Directly deploy in production. That is possible when the model is generalized. That means it understands any product that goes across the board. Correct? It is just not only for Amazon, it's not only Walmart. Whatever product you sell, whatever product you make the model to learn, that model has been generalized to handle both Amazon as well as Walmart. So that is the concept. Do not build 2 models. Build one model which solves 2 problems. Does that make sense?
If this is correct, then when you say the auto industry is trying to build a generic car which can drive with artificial intelligence, how will that give a kind of a proprietary, say that if your rule is correct, then all cars should have the same engine.
It is not different. Hold on. It is not my thinking. If you work in ERP applications, take SAP as an ERP application, correct? SAP does not build ERP application for Apple, for Walmart, for Amazon separately, correct? It is a one ERP application used all different places, correct? SAP does not build separate ERP applications. It's a one ERP application. It is installed, configured in each of those industry or companies.
Customize the front ends, okay.
Not necessarily front end, all the back end data, what product you sell, okay. So that is basically a generic approach. You have a generic ERP which goes across all different companies. That is the concept I'm trying to tell you. So do not build ERP for each and every car. Build one ERP which is installed across all cars. So what does that mean? You build generic model which understand the rules and regulations of road condition. In SAP case, SAP understands financial accounting. What's an income account? What's an expense account? What's an asset account? Liability account? That is not going to change. Balance sheet, it's a balance sheet. Okay. Cash flow, it's a cash flow. Okay. All these things are financial accounting rules. SAP understands. You take and install and configure based on what the customer wanted. That is what the concept of generic model. You create one model, then deploy wherever it wants, whether it goes to BMW or Benz or Porsche, who cares, correct? The rules are same, correct? The rules are same. You customize based on what you want to do.
Okay, thank you. And now we are always looking at the proprietary value of a brand if they implement the same AI into all the automated.
Keep in mind, we are talking software. Correct? Software is basically different than actual physical equipment. That is proprietary. How the car is looking, the design of the car, interior of the car, those are all very proprietary. We are talking in a different level, which is basically a software which runs inside the car, like SAP software. SAP software can run for Amazon, can run for Apple, can run for Walmart, can run for Johnson & Johnson. Correct? So these are all different customer who's using this one. Same concept. You build a generic model, then let the entire auto industry use it. We are not there yet, but that's where we want to get to.
But Tesla will not definitely give their proprietary software, or Apple will not give their iTunes to other phone makers. So it is their own proprietary They need to have that edge of the proprietary for the brand, right?
I'm not denying, but I'm saying where industry is getting towards, correct? Like in industries, see, you could imagine if SAP has to build the ERP for each and every customer. It's so impossible. Why? It is foolish. Why it is foolish? Because the accounting rules are same, correct? So whether you are an Apple, whether you are an Amazon, whether it's your Google, whether you are like Johnson & Johnson, your balance sheet is same as my balance sheet. The number what I see is different, correct? Your balance sheet is same as my balance sheet. Your P&L is same as these accounting rules are common, correct?
Yes,
it doesn't matter
but
what
here in SAP, your scalability is universal, because not only Apple, not only Google, everybody uses the SAP. But when it comes to car, there are limited handful brands.
No, sir. Car, I'm not talking about the components of the car. I'm talking about the software which runs inside the car. That is what controls the car. What has been controlled? The car has been controlled a piece of software. That is why the car manufacturer has been changed now. It is not actual, like, the physical equipment controls the car. When to stop the car, when the car should go, that is controlled by a piece of software which is built on artificially created intelligence. I'm talking that particular software. That is in a global scale, worldwide.
Yeah, got it. Thank you very much. Thanks for the clarification.
Sure. All right. Any other questions?
Yeah, Jyoti,
thank you. Thanks a lot.
Right, Jyoti, one question.
Yes, sir.
So you mentioned like we developed the AI model.
Yes,
The efficiency of the AI model is only depending upon the statistically, like they are above 90% or 97%, or or there is another parameter, like let's say if we are running to Python code and we can see the time complexity or big O notion. So is there those things also evaluate the AI model?
Yes, sir. So there are three key factors that I personally use when I end my project. Like, so one is the probability on something to be occurred. Second, on what confidence level that is occurred actually. Then the factor which influences that to occur. Okay. So the number one, let's say I'm saying tomorrow is going to rain. Okay. What is the probability? 99.9%. All right. How confident you are? 100%. What is the factor? Because it is already, the weather is so bad, it is just a lot of windy. I'm hoping this is going to happen. So there are three key factors that I consider in my projects when I implement any model. Number one, the probability of something to occur and what confidence level it occurs. And the second is the factor which is influenced. Let's take an example, customer churn. So a customer, John is a customer of mine. He's been with me for 15 years. I'm going to say in next 90 days, he's going to churn out. He's going to leave you. Okay, so that is basically my statement to the customer in a report. Now the customer asking, what is the confidence? What's the probability that's going to occur? It's 99.9%. What's the confidence level? 100%. Why? That's because the factor that's influencing the price went up. Okay, number one. Number two, he's not happy with the service calls. He's calling you every alternate week. Okay, and spending hours on this one. These are the factors, the factor which influences this one. Okay, so out of all the reasons, the number one reason why he's going to go, that's my factor. So that factor is basically, in this case, it's the price that went up. It's making him to go out. Okay, so from a business point of view, what I look for, the probability. Second, the confidence level. Third, the factor which influenced something to occur.
Okay, wonderful. But again, that I will come back to the same question. Why then so many predictions get fail in last couple of years?
Again, it's a generic statement. I wouldn't be able to answer this one. We have to take case by case and analyze this one. Correct? So why it is failed? Yeah, it is so difficult to answer in a one line. For a heck, I can tell, oh my God, it failed here and there. Actually, you won't be convinced. Correct? So to answer this question, we have to take case by case and analyze why it is failed. Correct? There must be some root cause. Okay, I'm not saying everything is great. No, it's all trial and error, exploration, exploitation. It's just a lot of things involved. Correct? So we need to understand why it is not working and go from there. But again, I'm going to repeat. Correct? The problem is not model. The problem is implementation. Okay, so the model could perform well. The implementation involves data, bringing right data. Okay, if we don't have right data, if we don't understand, it's good. Let's say when you go to a doctor, your symptoms are headache, but he never told about headache. All you are trying to describe, correct? You are saying so I'm feeling that I'm going to India. I'm feeling that I'm doing this. So we are building stories. How do you expect the doctor to come to a conclusion and make a recommendation what medicine you should take? You never describe your symptoms. You never describe the warnings. It's similar factor here. If we don't have anything in the data for the model to learn to predict something what you're expecting, obviously it won't learn, correct? So we have to look all aspects, correct? It is just not only hyperparameters. It's not only looking at some statistical analysis and etc. Everything has to be looked at, understand why it is not working. Then we can solve one by one. So it is not an easy step. It's pretty lengthy, time-consuming task to accomplish. It's going to take some time.
Okay, thank you. Thank you very much.
Sure.
Jyoti, this is Sarunan here. One quick question.
Yes, sir.
So we really like the way that you explained it. You are very good at explaining. There is no doubt about it. We could see your passion in explaining things very simpler, all the complex concepts. So the question I have is, I know you said something for the high school students. So if my daughter, she's interested in this area, so if she wants to explore, what do you suggest?
I can give my email, or you can contact Mr. Jothi Periyasamy. So he has my email. So send me an email. We'll go from there. I'm heavily involved on schools actually. Like I said, I'm involved with the Fremont High Schools. So I'm coaching them, bringing them into the international level competition for hackathon, and this focus on STEM and AI robotics. So a lot of other schools. So more than 300 schools I'm involved.
Oh, that's awesome. Sure. We'll contact you. Thank you.
Sure. All right. So I hope you enjoyed the sessions. I know
Jyoti,
it's a pretty...
we have one more hand raised.
Yes, sir.
Raja.
Yes, sir. Raja. Yes, Raja.
I just want everybody talk about big data. We hear all the time. What exactly is big data?
Sure. So the best way to understand, you take an example of Facebook. Okay. Do you have, or do we have any control on how many people can go to Facebook and how many people write anything about it, correct? Uncontrollable. What does that mean? The speed in which comes to Facebook, right? How many people can come in the speed in which they're coming? We don't have. So for example, so morning 9 o'clock across the board in Facebook, we have 1 million users. Again, around 7 o'clock, that 1 million went to 10 million. You see the span of 1 hour time, so many users are coming in. And the next point to understand, correct? So what the user can do in Facebook, they can post something. That posting could be involved image or a text or a voice or a video. You could post anything there. Okay, so this is a variety of data that you are dealing with, correct? The variety of data. And if you see the growth, correct, it's pretty exponential, correct? There's unimaginable, correct? So there are 3 key factors in this Facebook case. So number 1, the speed in which data has been created. Okay, that is the velocity, correct? The velocity is the speed, in what speed the data has been created. Second, the variety, different type of data that you create, correct? Example, you could create in Facebook with images, with videos, with voice, with the text, you type something. So these are all different variety of data. And third is the volume, correct? How big the data is going to be, huge, correct? So these 3 are the characteristics of a big data. When you say big data, you have no control on the volume of data that is going to be created and when it's going to be created and how fast it's going to grow, correct? So that is why they call 3 V's. So it is volume, velocity, and variety, correct? So any data which has these characteristics, they're all big data. Okay, they're all big data. But the point what I want you to also understand, that is gone. That is gone. The need right now, not just a big data. Okay, so this is where company like Huntington's, company like Cloudera made huge money. But now we cross this limit. We don't need such platform. We need true intelligence which extracts inside that complex data sets. This is where data engineering comes into picture. Data engineering truly understand all the things. I asked a question in the morning, correct? In my current project, I have image, I have text, I have voice, I also has videos. How do I connect these 3, correct? How do I integrate these 3? Industry never done it. And this is the job of data engineer, true data engineer, correct? I'm not talking by title, correct? Somebody could put title of data engineer, that's up to them. But if you are a data engineer, you must know how to deal these kind of complex data sets. So going back to your question, the concept of big data, it is less value at this point. Why? It became a commodity. Okay. For example, when you go to Google, they have their own Hadoop platform. Okay. They have their own Hadoop platform. You go to Amazon, they have their own Hadoop platform. They don't need company like Huntington's. They don't need company like Cloudera. Okay. It's gone. It is gone. But instead, what is needed? How do I work with that kind of volume of data set? You could imagine going to Facebook, finding out how many people are posted about myself. Do you think that's possible? Building an app for us? Yes, Facebook can do. Right? Type your name, it tell me how many postings are happening in a day and etc. Right? For us to build that kind of an application, it takes enormous time. It takes a lot of skills. So answering your question, big data, no question. It is a good concept to understand. But I would encourage, if you are trying to learn, focus on concepts like lakehouse, concepts like data mesh, concepts like data catalog, concepts like data virtualization. These are the very key area where industry is heavily investing. If you know this company Databricks, I was surprised to see the company is valued about 30 billion, correct? It is just one product they're trying to sell. It's a one product, correct? So with that product, the company is valued as like 30 billion. Oh my God, correct? Like just shocking, mind blowing. All they promote themselves. They're the pioneer. They're the leader in Lakers. I have no clue what leader they are, correct? So, but that's how they promote. Okay, that's how the promote is, correct? So anyway, so I just wanted to tell you, do not spend time on learning big data. Instead, spend time on understanding working data engineering type of skill sets. That's highly marketable, and it is a very unique skill. True data engineers.
And the students you are training on building that board, putting all four together, has been completed.
No, they just started actually. So this I gave them last week. So I gave them to build 3 things, correct? So it is a very industry focused. So what I have given them retail industry focus. So they have to build these models. One is for text-based, one is for voice-based, one is for knowledge graph-based. So the exercise I gave them, it is more for a retail industry. What I asked them to build, take that and build on healthcare. When I say healthcare, between a doctor and a patient, right? So a doctor is chatting and the patient is chatting. That one scenario. A doctor is basically talking, a patient is responding to that. Okay, other scenario. Third is you have medical images such as images, x-rays, medical transcripts, and prescriptions. Take that and build knowledge out of that.
So what age is these children, school children?
Middle school and high school, 6 to 12. I deal with 6 to 12.
So you think that they will be able to build this at that age with that information and mentoring?
You will be surprised.
I know it's a big scary thing that how kids can do what kids can do. I do appreciate that. Yeah.
Yes. It is. You will be surprised the level of learning they have, interest they have, commitment they have. It is shocking.
Yeah.
Yes.
Thank you to know everything. You are an ocean of knowledge, Jyotiji, and thanks for sharing that.
I'm not ocean of the knowledge, but I have a passion. I'm in getting involved in all these things. Thanks.
Yes. We also have to thank TANA, Ram Garu, and the leadership, as well as Karthik ji and Naya ji, everybody else for bringing all this together. Thank you very much, Jyoti.
Yeah. Sure. Thank you.
Thank you, Jyotiji. I think we should stop here because you must be very tired, continuously typing. I really wanted to give you a break, like we wanted to give you a break. Yeah, thank you. Ram, do you want to say anything?
Yeah, sure. Yeah. So it was a great day-long session with full of information. I think, Jyotiji, it's amazing to see your energy. Even at this hour now, you are being very high in energy and ready to go another 6 hours continuously. Thank you for that. And but we need to take a break. So thank you for joining all of you guys. Sharp 9 a.m. tomorrow, we'll have the second day's session starts. Initially, we'll have again introductory session for a few minutes until all the participants can join. Then I think Jothi Garu will drive again an exciting second day. Thank you.
Thank you all.
Have a very good rest for your vocals, please.
Yes, sir. Thank you all actually. So it is more of a community building, so there's nothing comes here. So please make use of this one, learn based on your interest, your goals and objective in life, right? So that's basically the driving factor. So use this, learn as much as you can. If there is any questions, so please feel free to reach out to me. I'm on LinkedIn as well. We'll go from there. I'm here to support you all. Take care. Thanks. Bye.
So Jyotiji, we are going to get those Python notebook.
Yes, right? Yes, I will send you the notebook actually. Okay. So for sure, I'll send it to you.
Thank you.
Thank you, guys.
Thanks. Thank you.
See you tomorrow.
See you all tomorrow. Bye.
Yeah. Bye. I'm going to stop.
Thank you. Good night. Bye-bye.
Bye-bye.